All right, engineers, get ready to unlock the power of cutting, edge automation, and digitalization with PCS 7 version 10, a proven performer that's like transforming industries worldwide. Whether you're in brewing, pharmaceuticals, mining, or energy, this is your ultimate toolkit for efficiency, safety, and honestly, next-level innovation. So let's dive into the groundbreaking features and benefits that are totally redefining process control, right? Before we dive into demonstrating how to install PCS 7 version 10 software on a computer running Windows 11 Enterprise, let's take a moment for an update. All right. Oh, and just so you know, in the next presentation, I'll be sharing even more details straight from my discussion with the Industrial Co-Pilot. So let's start with this. What are the advantages of PCS 7 version 10? Seamless data integration. So let's start with data, the backbone of any plant operation. With PCS 7 version 10's plant automation accelerator, you can say goodbye to tedious manual rework and hello to error-free data transmission between engineering and automation. Honestly, this feature feels like it's built to save time and eliminate frustration, right? Save time, cut costs, and build a rock-solid foundation for your digital plant. Efficiency from start to finish, but wait, there's more. From commissioning to plant extensions, PCS 7 version 10 totally has you covered. It offers consistent data synchronization and modular engineering that delivers unmatched flexibility and cost for savings across your plant's lifecycle. It's all about making things smoother and easier, right? Revolutionary engineering system. Now, speaking of efficiency, let's take a closer look at the engineering system. Imagine this. All your engineering disciplines working in harmony with intuitive, graphic tools-based tools. Sounds great, doesn't it? PCS 7 version 10's control model types accelerate the engineering process, shorten timelines, and simplify technical changes. Honestly, it's like giving your team superpowers, right? Libraries designed for success, and as we're on the topic of tools that make your life easier, let's talk libraries, okay? With the Advanced Process Library, Industry Library, and Condition Monitoring Library, you can streamline your control system like never before. Detect issues early, optimize processes, and future-proof your plant with these robust, well-organized tools. Virtual commissioning and training. All right, here's where it gets even cooler, right? Imagine testing your automation systems before they even go live. With SIMATIC simulation tools, you can detect potential automation errors before commissioning and even train your operators in a super realistic environment. How awesome is that? Reduce risks, improve safety, and get your plant up and running faster than ever. Process safety you can trust, but wait, safety is everything. Right? Let's not overlook the importance of safety in modern plants. With the scalable PCS 7 version 10 safety matrix, you can ensure safety while seamlessly meeting industry regulations. It's like having peace of mind built right into your system, Data archiving and reporting made easy, and speaking of peace of mind, data is king when it comes to making informed decisions, right? Turning raw data into actionable insights has never been simpler. With Process Historian and Information Server, you can monitor trends, improve productivity, and make well-informed decisions. It's like having a crystal ball for your plant's performance, isn't it? Unmatched industrial communication. Now, let's shift gears a bit and talk about connectivity. In today's fast-paced industrial world, seamless communication is key, With ProFiNet, you get hard real-time networking that enables seamless integration of IT for Industry 4.0. Plus, you can modify configurations on the fly with Configuration and Run, ensuring reliability every step of the way, right? Cybersecurity at every level. Okay, security enthusiasts, this one's for you. PCS 7 version 10's defense in depth gives your systems multi-layer protection, certified to IEC 62443 standards, whether it's secure data transmission or robust user authentication. Your plant's integrity is always like top priority, smart power control and distributed I/O, but don't stop there, okay? PCS 7 version 10 offers even more flexibility with power control and ET2's enhanced PA modules, whether it's monitoring medium voltage switch gear or deploying highly adaptable I/O modules. This system is built to meet your needs, batch automation made simple now. If batch processes are your thing, you're in luck with PCS 7 version 10's batch automation. Managing recipes and reducing downtime becomes a breeze. Plus, it's FDA compliant, so you're always on the right side of quality and safety standards, right? Digital assistants for the future, all right. This next part is, really exciting. Say hello to PCS 7 version 1010's EC, your new favorite digital assistant. Whether it's through chat, voice, or QR codes, this assistant makes plant operations smarter, faster, and honestly just plain better, don't you think? Tailored solutions for every industry, and here's the icing on the cake at PCS 7 version 10 provides industry-specific solutions tailored to your exact needs. From Siemens 8 for cement and mining to BRAMT for brewing, it's like having a solution designed just for you. Right? Stay ahead with lifecycle management. Finally, let's wrap it all up with lifecycle management. Okay? Keeping things updated and running smoothly has never been easier. Tools like the PCS 7 Management Console help you manage updates, licenses, and system states efficiently, ready to transform your plant. With PCS 7 version 10, you're not just adopting technology, you're totally redefining the future of your operations. So, what are you waiting for? Dive into the world of PCS 7 version 10 and experience the innovation firsthand, okay? Welcome back, everyone. Ready to dive deep again.
Always up for a deep dive.
Great. Today, we're tackling something pretty crucial, I'd say, for anyone working with industrial automation.
Yeah.
We're looking at the configuration of the Siemens SIMATIC PCS 7 engineering system, specifically version 10.0.
The latest and greatest.
Fresh off the press, actually. Just released in July 2024.
Still got that new version smell.
Exactly. And we've got a ton to cover, so let's just jump right in.
Sounds good to me. Let's get those brains whirring.
So imagine we're building this training material, a comprehensive guide to PCS 7 configuration. What would be the essential chapters, the backbone of this training,
Okay, well, right off the bat, we got to address the elephant in the room, cybersecurity.
Of course, can't ignore that these days.
Nope, not a chance. So we'd need a chapter specifically dedicated to cybersecurity information, and then another diving deeper into industrial security.
Makes sense, laying that security foundation from the get-go.
Absolutely. Then we need to set the stage right.
Have a bit of a warm-up.
Yeah, like a preface, introduce the training material itself, its purpose, that kind of thing.
Okay, so that sets the scene. What about, the actual nitty-gritty of configuring a PCS 7 system?
Getting into the nuts and bolts.
Exactly. Where do we start?
Well, we got a plan, right?
Of course, always plan.
So we need a chapter on planning the plant engineering. This is where we talk about choosing the right components, thinking about the system architecture.
Like a blueprint for the whole thing.
Exactly. Then, got to introduce the core concepts of engineering with PCS 7. Get everyone on the same page.
Okay, foundational stuff.
Yep. And then a chapter that explains, the structure of a typical PCS 7 plant. What are we actually dealing with here?
Makes sense. Build that understanding step by step.
Yep, so we got the foundation, we got the structure.
Time to get our hands dirty.
Exactly. Now we need a chapter on the basic concepts of engineering in PCS 7. How do we actually work with this thing?
Putting theory into practice.
Yep.
Yeah.
Then configuring the engineering system itself, the software environment.
Okay, so that's setting up the tools, the workshop.
Exactly.
Yeah.
Then comes the big one, implementing that configuration.
Putting it all together, making it real.
Boom. System's configured, now what? Got to make sure it can talk to other systems, right? Data exchange, got to have that.
Right, because in the real world, nothing exists in isolation.
Nope. So we need a chapter on data exchange within plant engineering.
Makes sense. Keeping that data flowing.
Exactly. Now we got to get that configuration data onto the actual system, right? Compiling and downloading.
The moment of truth.
Absolutely. Then, of course, we got to test, make sure everything is humming along as it should.
Absolutely crucial. Can't skip the testing phase.
Nope. And then there's this super useful tool called the Version Cross Manager. We'd need a chapter on that.
What does that do?
It helps you compare different versions of your project, track changes, super helpful for troubleshooting and just keeping things organized.
Sounds like a lifesaver.
It is. Then we delve into the specifics, the technological configuration, the nitty-gritty details.
Fine-tuning the engine.
Exactly. And last but not least, we can't forget about servicing and diagnostics. Got to keep that system healthy.
Preventative care.
Absolutely. So, we wrap it all up with an appendix for any extra goodies.
Wow, that's a pretty packed training program.
Comprehensive, that's what we aim for.
So where do we start? Maybe with Chapter 1, Cybersecurity Information.
Good place to start. Can't emphasize this enough, right?
Absolutely. Cybersecurity is crucial now more than ever, especially in industrial automation. What are the key takeaways for this chapter, the things we absolutely have to hit?
First and foremost, gotta hammer home the point that cybersecurity isn't just an IT problem, it's an operational issue.
Right, everyone's responsibility.
Exactly. So we gotta cover the basics, threats, vulnerabilities, risks, all in the context of industrial automation, of course.
So things like malware, unauthorized access, denial of service attacks, all that fun stuff, but tailored to how they affect an industrial control system.
Precisely. Then, gotta talk about defenses, right? Firewalls, intrusion detection systems, antivirus software, the whole shebang.
How do we actually implement those in a PCS 7 environment?
That's the key, right? Tailoring those solutions.
Right, because a generic solution might not cut it in this world.
Absolutely. And of course, you got to train your people. Even the best tech in the world won't help if someone clicks on a phishing link.
Oh, absolutely. Human error is a huge factor.
Huge. So we got to cover things like strong passwords, recognizing those phishing scams, reporting anything suspicious.
Being proactive, vigilant.
Exactly. And to wrap up the chapter, we got to highlight the importance of regular security assessments and updates. Things change so fast in the cyber world.
It's a constantly evolving landscape. Gotta stay ahead of the curve.
Couldn't have said it better myself.
So, Chapter 1 lays the groundwork, establishes that security-conscious approach to PCS 7 configuration. Now, Chapter 2, Industrial Security. How is this different from the general cybersecurity information we just covered?
Chapter 2 drills down into those security measures that are specific to, well, industrial control systems. We got to talk about defense in depth.
Defense in depth? What's that?
It's like having multiple layers of security. You're protecting the physical layer, the network layer, the application layer.
Makes it much harder for those attackers to penetrate the system.
Exactly. And PCS 7 has some built-in security features we got to discuss, like access control mechanisms, user authentication, those audit trails.
All about controlling who can access what and keeping track of any changes that are made.
Exactly. And we got to touch on network security best practices for PCS 7 systems, segmenting the network to isolate critical systems, using those secure protocols for communication, implementing intrusion detection and prevention systems.
It's like building a fortress around your PCS 7 system.
That's a good way to put it. And finally, we got to talk about incident response planning.
Right, because no system is 100% foolproof.
Exactly. Got to have a plan in place for when, not if, something happens, how to respond, how to contain the damage, how to recover quickly.
So Chapters 1 and 2 provide a solid foundation for understanding and implementing cybersecurity in a PCS 7 environment. Now, Chapter 3, the preface. What's the purpose of this chapter?
The preface sets the stage for the whole training material. Introduce the PCS 7 system itself, talk about its capabilities and how it's used in various industries, give an overview of the structure and content of the training material.
It's like giving them a roadmap for the journey ahead.
Exactly. And we also want to emphasize the importance of planning and attention to detail when configuring a PCS 7 system.
Right, because in industrial automation, mistakes can have serious consequences.
Absolutely. We're not just playing a computer game here. We're dealing with real-world processes that can affect safety, production, the whole 9 yards.
Oh, makes sense.
High stakes indeed.
Right.
And we also want to acknowledge that PCS 7 configuration can be complex and challenging. But we want to assure learners that with the right guidance and resources, they can master it.
So it's about giving them the confidence and motivation to tackle this complex topic. Okay, so the preface sets the tone and expectations. Now, Chapter 4, using this training material effectively. What are some key tips here?
Okay, well, first off, gotta encourage them to go through the material sequentially. Each chapter builds on the previous one.
Makes sense. Follow the logical flow.
Exactly. And gotta encourage active engagement, take notes, highlight key points, revisit sections.
Right, because passive reading is not going to cut it.
Nope. Gotta get those brains working. Also encourage them to try out the practical exercises, the simulations.
Getting their hands dirty, so to speak.
Exactly. There's no substitute for actually doing the work. And of course, we gotta encourage them to ask questions, seek clarification, Learning is a two-way street, right?
Absolutely. Open communication is key. And we also want to emphasize the importance of staying up to date with the latest PCS7 resources and documentation.
Absolutely. Technology never stands still. Got to keep learning and evolving.
So, Chapter 4 gives learners the tools and strategies they need to get the most out of the training material. Now, Chapter 5, planning the plant engineering. This is where we start to lay the foundation for any successful PCS7 implementation.
This is where we roll up our sleeves and start designing the system, right?
Exactly.
Yeah.
What are the key concepts, the must-haves for this chapter?
Well, first things first, we got to emphasize understanding the process that's going to be automated. What are we actually trying to control here?
Right. Gather all the information process requirements, equipment, the level of automation they're aiming for, safety considerations. It's like gathering ingredients before you start cooking, right?
Perfect analogy. Can't cook a good meal without the right ingredients.
Exactly. And once we understand the process, we can move on to selecting the right automation system or systems.
Right. Figure out how many automation systems we need and then choose between systems with different, performance capacities.
So it's not a one-size-fits-all situation.
Yeah.
Got to carefully consider the needs of the process.
Absolutely. And then we got to talk about redundancy.
Ah, yes. Redundancy. Can't forget about redundancy.
Nope, not a chance. It's all about minimizing risk, right? Like having a backup generator for your house. If the power goes out, you can still keep the lights on.
And in an industrial setting, those lights might be critical processes that can't afford any downtime.
Exactly. So we got to discuss different redundancy architectures, hot standby, active redundancy, the pros and cons of each approach.
Okay, so we've got the automation system sorted. Now, what about the network infrastructure? This is where we get into the world of Profibus, pronounced Profibus, Profinet, pronounced Profinet, and industrial Ethernet.
The veins and arteries of the automation world, those communication networks.
Exactly. They allow all the different parts of the PCS7 system to talk to each other.
Right.
And choosing the right network technology is crucial for ensuring reliable and efficient communication.
Absolutely. So in this chapter, we got to give a clear overview of the different options. What are the bandwidth requirements, the distance limitations, the cost considerations?
Give them the practical guidance they need to choose the right network for their specific needs.
Exactly. And then we got to dive into designing the network architecture for the PCS7 system, segmenting the network, implementing redundancy, all those security measures to protect against unauthorized access.
Building a robust and secure communication infrastructure.
Exactly. And finally, we got to talk about planning for the administration level and remote access.
So connecting to higher level systems, providing secure remote access for monitoring and maintenance.
Exactly. Integrating PCS7 into the larger operational ecosystem.
Okay, so we've covered a lot of ground in Chapter 5. It's all about laying that solid foundation for a successful PCS7 implementation. What are some common questions or challenges that people run into during this planning phase?
One question that comes up a lot is, how much redundancy is enough? You don't want to over-engineer for redundancy, but you also don't want to skimp on it.
Right. It's a balancing act.
Exactly. And another common challenge is choosing the right network technology. There are so many options out there, it can be overwhelming.
Especially with all the technical jargon.
Precisely. That's why we got to focus on the practical considerations. What kind of data needs to be transmitted? How much bandwidth is required? How far apart are the devices? What's the budget?
Breaking it down into those manageable chunks.
Exactly.
Okay, so Chapter 5 is all about laying the foundation. Now, let's move on to Chapter 6, Introduction to Plant Engineering with PCS7. This is where we really start to delve into the core concepts of working with the PCS7 system.
This is where we give them the PCS7 101, right?
Exactly. We start by discussing the overall architecture of a PCS7 system. What are the different components? How do they all fit together?
Give them a guided tour of the system landscape.
Exactly. And then we talk about the different engineering tools available in PCS7's SIMATIC Manager, HWConfig, the CFC editor.
Introducing them to the tools of the trade.
Precisely. And we also touch upon the different programming languages supported by PCS7, ladder logic, function block diagram, structured text.
Giving them the linguistic skills to communicate with the system.
Love that analogy. And speaking of communication, we also discuss the different communication protocols used in PCS7, such as Profibus and Profanet.
The rules of the road for the PCS7 communication network.
Exactly. And to wrap up Chapter 6, we emphasize the importance of documentation and testing throughout the engineering process.
Right, because we've already established those are essential for building a reliable and maintainable system.
Absolutely. So Chapter 6 provides that essential foundation. What are some common questions or points of confusion that come up during this introductory phase?
One question I get a lot is, what's the difference between an automation system and an operator station?
Because they both involve hardware and software, but they serve different purposes.
Right. The automation system is the brain of the operation. The operator station is the eyes and ears.
I like that. Clear and concise.
And another common point of confusion is understanding the different programming languages and choosing the right one for a specific task.
Right, because there's no one-size-fits-all answer.
Nope. But in general, you can say that ladder logic is good for simple logic operations, function block diagram is good for visualizing signal flow, and structured text is good for complex calculations and data manipulation.
Okay, so Chapter 6 lays the groundwork. Now let's move on to Chapter 7, which delves into the structure of the PCS7 plant.
Zooming in on the layout and organization.
Exactly. We start by discussing the hierarchical structure of the system, plant level, area level, unit level, down to the individual process object level.
Exploring the organizational chart of the plant.
Exactly. And then we discuss the roles and responsibilities of the different components, the automation systems, the operator stations, the engineering station, how they communicate with each other, how they exchange data.
Tracing the flow of information through the system.
Precisely. And we also discuss the concept of distributed automation.
Spreading the control functionality across multiple automation systems.
Right, instead of having everything centralized in one location.
Exactly. And we can use diagrams and examples of real-world PCS7 plants to illustrate these concepts. Maybe even show some pictures of actual installations.
Yes. Pictures. Always a good way to make things more concrete. What are some common questions or challenges people encounter when trying to grasp the structure of a PCS7 plant?
One question that comes up is, why is a hierarchical structure necessary?
Especially for smaller systems, it might seem like overkill.
It might. But as the complexity of the plant increases, a hierarchical structure becomes essential for managing that complexity. It's like organizing a large company, you need a clear chain of command.
Right, that makes sense.
And another common challenge is understanding the different roles and responsibilities of the various components and how they all work together.
So it's not just about seeing a static diagram, but understanding the dynamic interactions.
Exactly. We got to bring the system to life for them.
Okay, so Chapter 7 breaks down the structure. Now let's move on to Chapter 8, Basic Concepts of Engineering in PCS7. Now that we've laid the groundwork, it's time to start getting into the actual process of configuring the system.
Getting down to business.
Exactly. What are some of the key concepts, the building blocks of PCS7 engineering that we need to cover in this chapter?
Well, first off, we got to emphasize the importance of creating a structured and organized project, clear naming conventions, logical grouping of objects, using the hierarchical structure of the system to our advantage.
Good organization is key to any complex project.
Absolutely. Then we need to introduce the concept of a system ID. This acts as a unique identifier for the entire project.
Like a fingerprint for the projects.
Exactly. Then we talk about distributed engineering. This allows multiple engineers to work on the project simultaneously, which is essential for larger projects.
Divide and conquer.
Precisely. But with distributed engineering comes the need for coordination and version control. We got to make sure that everyone is on the same page and that changes made by one engineer don't conflict with the work of others.
Right, because you don't want to end up with a Frankenstein system.
Definitely not. We also need to cover user roles and access control.
Who has permission to do what?
Exactly. Different users will have different levels of access. We got to explain how to set up these roles and permissions to ensure that only authorized personnel can access and modify sensitive parts of the system.
So it's about establishing that clear hierarchy of responsibility and control.
Right. And then we introduce the concept of a multi-project, which allows you to group multiple individual projects under a single umbrella. This is helpful for managing large, complex projects that are broken down into smaller chunks.
So it's like having a project manager overseeing multiple teams.
Exactly. And within this multi-project structure, we explain the benefits of using type definitions and reusable components.
So we're not reinventing the wheel every time we need to create a similar object or function.
Precisely. And to illustrate all of these concepts, we can walk through a simple example. Let's say we have a fill level sensor in a boiler. We can show how that sensor is connected to an analog input module and processed by automation blocks. We can even show a diagram of the CFC, the continuous function chart.
Visual aids are always helpful. And finally, we need to touch on the concept of project-specific catalogs.
Ah, yes. This is where we define the specific hardware components that are allowed to be used in a project.
Ensuring compatibility and preventing those oops moments.
Exactly.
Okay, so Chapter 8 covers a lot of ground. What are some common questions or challenges that people face when they're first starting out with PCS 7 engineering?
One question I get a lot is, what's the best way to organize a PCS 7 project?
Because there's no right or wrong answer, really. It depends on the project and the preferences of the engineering team.
Right. But we can give them some best practices using a hierarchical structure that mirrors the physical structure of the plant, using clear and descriptive names, grouping objects logically.
Make it easy to navigate and understand, both for the engineers and for the operators who will be using the system.
Exactly. And another common challenge is understanding the different types of objects in PCS 7 and how they all relate to each other.
Right, there are stations, channels, modules, blocks, tags. It can be a bit overwhelming.
It can be. That's why it's important to start with the basics and gradually build up your understanding. And don't be afraid to experiment. The more you practice, the more comfortable you'll become with the system.
Great advice. Now, Chapter 9, Configuration of the PCS 7 Engineering System. This is where we start getting into the specifics of setting up the software environment for our project.
Setting up our workshop.
Exactly. We walk through the steps of installing and configuring the PCS 7 engineering software on the engineering station.
Checking those system requirements, getting those licenses sorted, making sure the network is all set up.
Laying the foundation.
Exactly. And once the software is installed, we guide them through the process of creating a new PCS 7 project, choosing the right template, defining the project structure, setting up those basic project settings.
Like framing a house.
Exactly. And we also introduced the concept of the master data library in this chapter.
Ah, yes, the master data library. This is like a central repository for all your reusable components.
Exactly. We explain how to create and organize the master data library, how to use it to streamline the configuration process, and ensure consistency across the project.
So we're promoting efficiency and organization right from the start.
Absolutely. And we wrap up Chapter 9 with some considerations for configuring the engineering station itself, setting up user accounts and permissions, configuring network settings, optimizing system performance.
Making sure the engineering station is secure, connected, and running smoothly.
Exactly.
Okay, so Chapter 9 gets the engineering environment up and running. What are some common pitfalls or challenges people face when configuring the engineering system?
One common pitfall is not paying close enough attention to the system requirements. If the engineering station doesn't meet the minimum specs, you're going to have a bad time.
Right. Trying to run a high-performance application on a low-end machine, it's just not going to work well.
Exactly. And another common challenge is understanding the concept of the master data library and how to use it effectively.
It's a powerful tool, but it can be a bit intimidating at first.
It can be. That's why we emphasize the importance of planning and organizing the master data library up front and then using it consistently throughout the project.
Okay, so Chapter 9 is all about setting up the engineering environment for success. Now, let's move on to Chapter 10, Implementing the PCS 7 Configuration. This is where we finally get to put all our planning into practice and start building the actual system.
This is where the rubber meets the road, right?
Exactly. We start by discussing the different configuration tasks involved creating the plant hierarchy, configuring the hardware, developing the control logic.
Taking all those blueprints and turning them into a real working system.
Precisely. And one of the first things we do is create the plant hierarchy, or PH. This is the backbone of the project, defining the hierarchical structure of the entire system.
Organizing all those different elements in a logical and manageable way.
Exactly. And once the PH is in place, we move on to configuring the hardware using HWconfig. This is where we define the physical components of the system, the CPUs, the I/O modules, the network interfaces.
Connecting the virtual world to the real world.
Precisely. And HWconfig is a powerful tool that allows us to do this graphically. We can drag and drop components, connect them together, configure their properties. We can even simulate the behavior of the hardware to test our configuration before we deploy it.
Catch those errors early.
Exactly. And once the hardware is configured, we move on to configuring the connected I/Os. This involves mapping those physical I/O points to logical tags that can be used in the control logic.
Wiring up the nervous system of the plant.
Love that analogy. And then we cover the concept of configuration changes in RUN mode, or CRR.
Ah, yes, CR. This allows us to make certain configuration changes without having to stop the system completely.
Essential for minimizing downtime.
Absolutely. We explain the principle of CR, the types of objects, the permitted changes. We even walk through the steps of adding, deleting, and converting CR elements during runtime.
Okay, so Chapter 10 is packed with information. What are some common challenges that people face when they're trying to implement their PCS7 configuration?
One challenge is understanding the relationship between the different configuration tools, SIMATIC Manager, HWConfig, the CFC editor. They're all interconnected, but they each have their own specific role.
So it's not a linear process. You might need to jump back and forth between the different tools as you refine your configuration.
Exactly. And another challenge is understanding the concept of symbols and addresses. In PCS7, we don't program directly with physical addresses, we use symbolic names.
So it's like using variables in a programming language.
Exactly. And one of the key tasks in HWConfig is to assign those symbols to the physical addresses of the I/O modules and other hardware components.
Creating that translation layer between the human-readable symbols and the machine-readable addresses.
Precisely. And then there's the challenge of configuring communication between the different parts of the system.
Especially when you have a mix of protocols and network technologies.
Right. You might have Profibus, Profinet, Ethernet, and they all need to talk to each other seamlessly.
So it's a complex puzzle.
It can be, but with a little bit of patience and a good understanding of the different communication options in PCS7, it's definitely solvable.
Okay, so Chapter 10 is all about bringing the pieces together and building the actual system. It's a complex and challenging process, but it's also incredibly rewarding when you see it all come together.
Absolutely. There's nothing quite like seeing your configuration come to life and start controlling a real-world process.
It's like watching your creation take its first steps.
Exactly. It really is. Okay, moving on to Chapter 11.
Chapter 11, Data Exchange with Plant Engineering. Earlier you mentioned how no system is an island. So why is data exchange so crucial in a PCS7 system?
Well, in today's world, it's all about data, right? And in industrial automation, that data's got to flow smoothly between different systems.
Makes sense. Got to keep things running efficiently, make sure everything is talking to each other.
Exactly. So Chapter 11, it focuses on how PCS7 handles that data exchange, how it integrates with other systems within the plant, even beyond the plant.
Okay, so what are the main avenues of data exchange that we need to cover here? What are we focusing on?
Well, we start with the different communication protocols. PCS7 supports a bunch, things like OPC, that stands for OLE for process control, and S7 communication, that's Siemens' own thing.
Right. So we explain how these protocols work, how they're used to exchange data between PCS7 and like MES systems, ERP systems.
Yep, connecting the shop floor to the top floor. Got to have that data flowing up the chain.
Okay, so we've got communication with those external systems. What about data exchange within the PCS7 system itself? How does that work?
Good point. We got to cover that too. So we talk about how data moves between different components within a PCS7 plant, between the automation systems, the operator stations, all that.
And this is where the process image comes in. Yeah.
Got it. The process image, it's like a shared memory space where all the process data is stored. Everyone can access it.
A central hub for all the important information.
Exactly. And we also talk about how to configure data transfer between different automation systems, especially in those redundant setups.
Right, because if one controller goes down, the other one needs to be able to pick up right where it left off.
Exactly. Seamless transition, gotta have it. So yeah, Chapter 11, we cover both internal and external data exchange. Pretty important stuff.
It sounds like it. Now, what are some common challenges people might face when they're setting up data exchange? What are some things to watch out for?
One thing that trips people up is understanding all those different communication protocols and, picking the right one for the job.
Right, because there are a lot of options.
There are. OPC is a widely used open standard, but then you have S7 communication, which is Siemens specific. So, got to weigh the pros and cons of each.
So it's about understanding the strengths and weaknesses of each protocol and choosing the best fit for the specific application.
Exactly. And then there's the whole security aspect, right?
Yeah,
got to make sure that data is being transferred securely, that you're not leaving any doors open for, unwanted visitors.
Cybersecurity. Always got to be thinking about that.
Always. So we talk about setting up firewalls, using encryption, implementing authentication mechanisms. Got to protect that data.
Okay, so Chapter 11 is all about making sure that data is flowing smoothly and securely. Now let's move on to Chapter 12, compiling and downloading. This sounds like the moment of truth when we take our configuration and make it real.
Exactly. This is where we go from the virtual world to the plant floor.
Bridging the gap.
Yep. So first step, compiling the configuration. We're taking that human-readable stuff and turning it into machine code.
Right, got to speak the language that the PCS7 system
Yeah.
understands.
Exactly. PCS7, it's got built-in compilers for that. And then once it's compiled, we download it, usually over the network.
Sending those instructions out into the world.
Exactly. Chapter 12 walks through all the steps, gives tips for troubleshooting. We also talk about different download options, downloading to individual components, groups, or the whole system.
So we can be strategic about it.
Right. And we really emphasize backing up the existing configuration before you download a new one.
Safety first.
Always. Got to have that safety net.
Absolutely.
Oh.
Okay, what are some common pitfalls people run into during this compiling and downloading process? What should people be aware of?
One big one is not fixing those compilation errors. The compiler, it'll flag any errors like syntax errors or missing stuff. Got to fix those before you download.
Right, because if you download a faulty configuration, you could really mess things up.
You could. It's like baking a cake with a bad recipe.
Yeah.
It's not going to turn out well.
Perfect analogy. And another challenge is making sure that communication between the engineering station and the PCS7 system is solid. No interruptions, no dropped connections.
Right. If that connection drops during the download, you could corrupt the configuration.
Not good.
Not good at all. So we always recommend using a wired network connection for this and try to avoid downloading during peak traffic times.
Minimize those risks. Okay, so Chapter 12 is about bringing our configuration to life, sending it out into the real world. Now, Chapter 13, testing. This is where we make sure everything actually works as intended.
Got to put it through its paces.
Exactly. We can't just assume everything will work perfectly. We have to verify it. So Chapter 13 covers a bunch of different testing techniques, from simulation testing to online testing to factory acceptance testing.
Testing, 1, 2, 3.
Okay, let's break it down. What's simulation testing all about? How does that work?
So simulation testing, you're using a software tool like S7PLCSM to basically mimic the PCS7 system.
So you're testing in a virtual environment.
Exactly. You can test your control logic, all that functionality, without needing the actual hardware. It's a safe way to try things out.
Makes sense. So it's like a test run before the real show.
Exactly. And it's great for testing complex scenarios that might be too risky or difficult to do in the real world.
Okay, that makes sense. Now, what about online testing? What's that all about?
Online testing, that's where you test the system while it's actually running in the plant.
So you're testing with the real equipment, the real process.
Exactly. This is where you catch any issues that might not have shown up during the simulation.
Right, because the real world is always a bit more unpredictable.
It is. And it's also a good opportunity to train those operators, get them familiar with the new system.
Hands-on experience.
Yep. And then there's factory acceptance testing, or FAT.
FAT?
Okay. This is usually done before the system is shipped to the customer. It's a big, comprehensive set of tests to make sure everything meets the requirements, that it's ready to go.
The final inspection.
Exactly. Usually done in a controlled environment, like a test lab.
Okay, so we've got simulation testing, online testing, and factory acceptance testing. A pretty comprehensive testing regime.
Got to be thorough. Now, what are some common challenges people might run into during the testing phase? What are some things to watch out for? One challenge is simply knowing what to test. Got to think through all those possible scenarios, normal operating conditions, and those abnormal conditions, equipment failures, process upsets, you name it.
Right, because you want to make sure the system can handle anything that's thrown at it.
Exactly. Got to test the happy path and the not so happy path. And when you're creating those test cases, you got to be specific. Define those inputs, the expected outputs, the pass-fail criteria.
Got to have those clear objectives.
Absolutely. And then there's the challenge of interpreting the results.
Right, because a failed test doesn't mean the whole system is doomed.
Nope. It could be a simple configuration error, a faulty piece of hardware. You got to be systematic, start with the most likely causes and work your way down.
Like a detective solving a mystery.
Exactly.
Okay, let's move on to Chapter 14, comparing project versions with the Version Cross Manager. We've talked about version control before, but let's dive into the specifics of this tool. What's it all about?
The Version Cross Manager, or VXM, it's like having a time machine for your PCS7 project.
A time machine. Sounds intriguing.
It is. You can track all those changes, compare different versions side by side, see what's been modified, who did it, when they did it.
So it's all about keeping a detailed history of the project.
Exactly. And it's super helpful for troubleshooting. Let's say you're having a problem with the system. You can use the VXM to see if any recent changes might have caused it.
So you can track down those pesky bugs.
Exactly. And if you need to go back to an older version of the project, the VXM can help you do that too. Super easy.
Like an undo button for your whole project.
Exactly. And it's also great for documentation. You can generate reports that highlight the differences between two versions so you have a clear record of all the modifications.
So it's a versatile tool.
It is. Chapter 14 goes through all the details, explains how to use it effectively.
Okay, so the VXM is all about managing the evolution of your project. Now, are there any common challenges that people face when using this tool? What should people be aware of?
One thing that trips people up is, well, there are a lot of different comparison options in the VXM. Got to choose the right one for the job.
Right, because you can compare entire projects, specific folders, even individual objects.
Exactly. And then you got to know how to interpret those results. The VXM throws a lot of information at you.
It can be a bit overwhelming.
It can. So we show them how to filter the results, focus on specific types of changes, understand what all those colors mean.
Make it easy to find the information they need.
Exactly.
Okay, so the VXM is a powerful tool, but it takes a little bit of practice to master it.
Yeah.
Now, Chapter 15, Technological Configuration. This is where we really start to dig into the technical details of PCS 7.
The nitty-gritty.
Exactly. What are some of the key concepts that we need to cover in this chapter? What are the building blocks of PCS 7 configuration?
Well, we start with control modules, or CMs. They're like the workhorses of the system. They handle individual process loops, interact with those field devices.
So they're the bridge between the software and the real world.
Exactly. Chapter 15 explains all the different types of CMs, each one designed for a specific task. And then we introduce the concept of control module types, which are reusable templates for configuring common control functions.
Ah, so you don't have to start from scratch every time.
Nope. We also talk about equipment modules, or EMs. These are collections of related control modules that work together to control a specific piece of equipment or, a part of the process.
So it's like grouping those individual control loops into larger units.
Exactly. And just like with control modules, you can create equipment module types, reusable templates for common configurations.
Makes things much more efficient.
It does, and we provide examples of how to configure these modules for different applications.
So it's not all just theory. They get to see how it works in practice. Now, are there any common challenges that people face when they're working with control modules and equipment modules? What are some things that trip people up?
One thing that can be confusing is understanding the relationship between control modules and equipment modules. When do you use one versus the other?
Right, because they're both kind of modular building blocks.
Exactly. So we got to explain that relationship, show how those control modules are the building blocks for the equipment module.
No.
And we give them guidance on choosing the right type of control module for a specific task.
Help them make those decisions.
Yep. Another challenge is understanding the whole synchronization thing, between type and instance.
That sounds a bit technical.
It is a bit technical, but basically, when you create an instance of a module, you're making a copy of that type definition. But those two things, the type and the instance, they're linked.
So if you change the type definition, those changes can be propagated to all the instances.
Exactly. And we explain how to do that, how to keep things synchronized.
Okay, so Chapter 15 is all about those building blocks, the control modules, and equipment modules. Now, Chapter 16, Servicing and Diagnostics. This is all about keeping our PCS 7 system running smoothly.
Got to keep that engine purring.
Exactly. What are some of the key takeaways from this chapter? What do people really need to know?
Well, first off, we got to introduce the maintenance station. This is a dedicated tool for diagnostics in a PCS 7 plant.
So it's like having a doctor for your system.
Exactly. You can monitor system health, identify potential issues, access diagnostic information.
Catch those problems before they become major headaches.
Exactly. And then we talk about archiving, versioning, documenting.
Always got to have those backups.
Absolutely. We explain how to back up the project data, track changes, keep good records, and we talk about the version trail add-on package, which automates a lot of this stuff.
So you don't have to do everything manually.
Nope. And then we talk about the version cross manager again, the VXM. This is a great tool for comparing different versions of your projects, seeing what's changed.
We've already covered that, right?
We have, but it's worth mentioning again here because it's a really helpful tool for diagnostics.
Okay, so we've got the maintenance station, we've got archiving and versioning, we've got the VXM. What else is in Chapter 16?
We also talk about the different diagnostic tools available in PCS 7, things like online monitoring, trend analysis, event logging.
Gathering those clues.
Exactly. And then we talk about how to implement software updates and upgrades safely, got to minimize downtime, make sure everything is
You
compatible.
don't want to break anything while you're trying to fix it.
Exactly. And always test the system thoroughly after any update or upgrade.
Okay, so Chapter 16 is packed with practical advice on keeping your PCS7 system healthy. Now, what are some common challenges that people face when it comes to servicing and diagnostics? What are some things that trip people up?
One challenge is simply knowing where to start when you're troubleshooting a problem. PCS 7 is a complex system. It can be hard to pinpoint the root cause.
Right, it's like trying to find a needle in a haystack.
It can be. That's why that maintenance station is so helpful. It gives you a structured approach to diagnostics. And we emphasize using those diagnostic tools like the online monitoring, the trend analysis.
Gathering the evidence.
Exactly. And another common question is about those software updates. How do you do it safely? How do you minimize downtime?
Right, because keeping the system up to date is important.
It is. So we walk them through the process, explain how to minimize those risks.
Okay, so Chapter 16 is all about being proactive, keeping the system running smoothly.
Preventative maintenance is key.
Absolutely. Now, before we wrap up, let's touch on a topic that's fundamental to any reliable automation system: redundancy. We've talked about it throughout this deep dive, but I think it deserves a bit more attention.
Redundancy, it's like that insurance policy you hope you never have to use, but you're sure glad you have it when you need it.
Exactly. In industrial automation, downtime can be incredibly costly, so having those backup systems in place is crucial. And PCS 7, it offers a whole range of redundancy options, right?
It does. We're talking redundant controllers, I/O modules, networks, power supplies, you name it. You can probably make it redundant in PCS 7.
So you can tailor the level of redundancy to the specific needs of your plant, your risk tolerance, all that.
Exactly. And, throughout all these chapters, we've seen how redundancy is baked into the PCS 7 philosophy. From picking those redundant components during planning to actually configuring them in HWConfig and testing them, it's all about minimizing risk.
Building that safety net into every level of the system.
Exactly. And that's one of the things that makes PCS 7 such a reliable platform for automation. It's designed with reliability in mind from the ground up.
Absolutely. Now, are there any specific types of redundancy or configurations that you think our listeners should, pay particular attention to? What are some of the key things to focus on?
Well, controller redundancy is a big one. PCS 7 supports both hot standby and active redundancy.
Right, so you can choose the approach that best suits your needs.
Exactly. Hot standby, that's where the backup controller is just kind of hanging out, waiting to take over if the primary controller fails. Active redundancy, both controllers are active, processing in parallel.
So even if one controller has a hiccup, the other one can keep things running smoothly.
Exactly. Seamless transition. And then there's network redundancy. PCS 7, it supports that too, using various technologies like MRP for Profinet and RSTP for industrial Ethernet.
So even if a cable gets cut or a switch fails, the network can still keep chugging along.
Exactly. And when you're setting up that network redundancy, you got to pay attention to that failover time.
Failover time.
Yeah, it's the time it takes for the backup network to take over. You want to make sure that time is short enough so your process isn't interrupted.
Right, so it's a smooth transition.
Exactly.
Okay, so controller redundancy, network redundancy, those are some key things to focus on. Now, I want to talk about a tool that we've mentioned a few times already. The Version Cross Manager, or VXM. This seems to be a really valuable tool for managing and understanding the evolution of a PCS 7 project.
It is. It's like having a detailed history log for your project. You can see how it's changed over time, who made those changes, when they were made.
So it's all about keeping track of those changes.
Exactly. And it's incredibly helpful for troubleshooting, especially if you suspect that a recent change might have caused a problem.
Right, you can go back and see what changed.
Exactly. And if you need to revert to a previous version of the project, the VXM can help you do that too.
So it's like having a giant undo button.
Exactly. And beyond troubleshooting, the VXM can also be used for documentation purposes. You can generate reports that highlight the differences between two versions of the project.
So you have a clear record of all those modifications.
Exactly. And it's important to note that the VXM can be used not just for PCS7 projects, but for other types of automation projects too, like WinCC configurations and Step 7 programs.
So it's a versatile tool.
It is.
Okay. Now, are there any specific tips or best practices that you would recommend for using the VXM effectively? What are some things that people should keep in mind?
One tip is to use those filtering options. The VXM lets you filter the results by, object type, modification date, user, all sorts of stuff.
So you can quickly find the information that you need.
Exactly. And I'd also recommend using those reporting features to generate documentation that summarizes the changes between different versions of the project.
So you have a nice, clear record of what's changed.
Exactly. It's all about keeping things organized and transparent.
Okay, great tips. Now let's move on to a chapter that's absolutely crucial for any industrial automation system, especially in today's world. Chapter 2, Industrial Security. What are some of the key takeaways from this chapter? What do our listeners really need to know about securing their PCS7 systems?
Well, this chapter is all about protecting your system from those cyber threats. And the first thing we have to emphasize is that the landscape of industrial security is constantly changing. Those attackers are getting more sophisticated all the time.
It's a never-ending arms race.
It is. So we really stress the importance of a defense in-depth approach. You've got to have multiple layers of protection. We're talking physical security, network security, application-level security.
Protecting the system from all angles.
Exactly. And when it comes to network security, we talk about firewalls, intrusion detection systems, all those things that can help prevent unauthorized access and malicious traffic.
Keeping those bad guys out.
Exactly. And then we talk about user access control, making sure that only the right people have access to the right parts of the system.
Right. You don't want to give everyone the keys to the kingdom.
Exactly. And finally, we emphasize the importance of staying up to date with those security patches.
Because those vulnerabilities are constantly being discovered.
They are. And Siemens is always releasing new security updates for PCS7. Got to stay ahead of those attackers.
Absolutely. Now, are there any specific security measures or best practices that you would recommend our listeners pay particular attention to? What are some of the most important things they could do to secure their systems?
One thing I always emphasize is network segmentation. Divide that network up into smaller, isolated segments. It limits the damage if there is a breach.
Right, containment.
Exactly. And you got to pay attention to those communication paths between the segments. Make sure you have the right security controls in place.
So you're not accidentally creating backdoors for those attackers.
Exactly. And there's user access control. Got to have strong passwords, multi-factor authentication, all that good stuff.
Make it hard for those attackers to get in.
Exactly.
Okay, so network segmentation, user access control, those are two key areas to focus on. Now, before we move on, I want to revisit a concept that we've touched on in several chapters, but I think it's really fundamental to understanding how PCS7 works. Process objects. What are these process objects and why are they so important?
Process objects, they're the building blocks of a PCS7 configuration. They represent those real-world elements of the process you're controlling, like valves, pumps, sensors, motors.
So they're the digital representation of the physical equipment.
Exactly. And each one, it has its own set of properties, parameters, signals that defines how it behaves, how it interacts with other process objects.
Like a little virtual version of each piece of equipment.
Exactly. And when you configure a PCS7 system, you're basically creating this network of interconnected process objects.
Like building a digital twin of the plant.
Exactly. And understanding those process objects, it's essential for configuring and troubleshooting the system. You got to know how to create them, set their properties, connect them together.
Building that virtual model of the process.
Exactly.
Now, are there any specific types of process objects or configuration techniques that you would recommend our listeners pay particular attention to? What are some of the key things they should focus on?
One thing I always emphasize is faceplates. They're like the graphical representations of those process objects.
So the operator can see what's going on.
Exactly. PCS7, it has a bunch of pre-built faceplates, but you can also make your own.
So you can customize the interface.
Yeah. And another important concept is interlocks and permissives. These are safety mechanisms.
So they help prevent accidents.
Exactly. An interlock, it's a condition that has to be met before you can do something. A permissive, it's a condition that has to be met before you can be in a certain state.
Okay, so it's all about making sure that the system operates safely.
Absolutely. Safety is always the top priority.
Now, before we move on to our final chapter, I want to touch on a topic that's essential for any complex project, but especially for automation projects, documentation. Throughout this deep dive, we've seen how important it is to document everything we do in PCS 7. But it can be overwhelming to know where to start. What are some of the key types of documentation that people should focus on?
Documentation. It's one of those things that a lot of people dread, but it's so important. Good documentation, it's like a lifeline for your project.
Right, because if you don't document what you're doing, it's going to be a nightmare to troubleshoot problems or make changes down the road.
Exactly. So when it comes to PCS 7, there are a few key documents you got to have.
What are those?
Well, first, you need a functional specification. This outlines the big picture, the goals of the project, the functions the system's supposed to perform.
So it's like the mission statement for the project.
Exactly. Then you need a design specification, which dives into the technical details, the hardware, the software, the network, the control logic.
So it's like the blueprints for the system.
Exactly. And once the system's actually configured, you need to create as-built documentation. This reflects the actual configuration, the settings, the diagrams, the code.
So it's a snapshot of the system as it exists in the real world.
Exactly. And finally, you need operational documentation. This is like the user manual for the people who are going to be operating and maintaining the system.
So it explains how to start and stop the system, how to monitor it, how to troubleshoot problems.
Exactly.
Now, are there any tools or techniques that you would recommend for creating and managing all this documentation?
Well, PCS 7 has its own documentation system built in. It's pretty helpful. It's got templates for different types of documents, and you can link those documents to specific objects in your configuration.
So everything is connected, easy to find.
Exactly. And then there's the version cross manager, the VXM. We've talked about that before.
Right. The time machine for your project.
Exactly. It's great for generating reports that document those changes over time.
Okay, so there are tools available to help with the documentation process. Now, Chapter 17. Appendix. This is often the most overlooked part of the documentation. What kind of hidden gems can we find in there?
The appendix, it's like the treasure chest of random but useful information. For PCS 7, you'll usually find things like installation guidelines, EMC compliance basics, and information on those degrees of protection, the IP ratings.
So it's like the bonus material for those who want to dig a little deeper.
Exactly. For example, those installation guidelines, they tell you how to physically install the hardware. Mounting racks, connecting cables, all that.
So it's the practical stuff.
Yep. And then the EMC compliance basics section, it explains how to make sure your PCS 7 system doesn't interfere with other electronic equipment.
Right, because you don't want your automation system causing electromagnetic mayhem.
Exactly. And then the degrees of protection section, it explains the IP rating system. Those IP codes that tell you how protected an enclosure is against dust and water.
So you can choose the right enclosure based on the environment.
Exactly.
Okay, so the appendix is definitely worth a look.
It is. You never know what you might find in there.
Now, before we wrap up this deep dive into PCS 7 configuration, are there any final thoughts or recommendations that you would like to share with our listeners? Any parting words of wisdom?
Well, my biggest piece of advice is to approach PCS 7 with a mindset of continuous learning. This system, it's incredibly powerful and versatile. There's always something new to learn.
So it's not just a one-time thing, it's an ongoing journey.
Exactly. Embrace the challenge, don't be afraid to try new things, and keep learning.
Great advice. And on that note, I want to thank you for joining us for this deep dive into the world of PCS 7 configuration. We've covered a lot of ground, explored a lot of tools and techniques, and hopefully given you a solid foundation for configuring and maintaining your own PCS 7 system.
It's been my pleasure. I always enjoy talking about PCS 7.
Now, before we sign off, I want to leave our listeners with a final thought to ponder. With so much depth in PCS 7 configuration, what areas are you most excited to explore further to optimize your process automation?
Ooh, that's a good one. PCS 7 offers so many possibilities.
It does. And we hope that this deep dive has given you the knowledge and the inspiration to embark on your own journey of discovery with PCS 7. Until next time, happy configuring.
It has. It really has. Lots of options.
Okay, so we've covered a lot of ground here, from the high-level concepts to the nuts and bolts of configuration. We've explored a whole toolbox of techniques and tools. But now I'm curious, what are some of those hidden gems, those lesser-known features or functionalities of PCS 7 that you think our listeners might find particularly useful or interesting? What are those things that often get overlooked but can really make a difference?
Interesting question. Well, one feature that often gets overlooked is the ability to create custom function blocks.
Custom function blocks,
Yeah,
okay.
a lot of people stick to the standard library blocks, which are great, don't get me wrong. But if you really want to tailor your system to your specific needs, creating your own function blocks can be incredibly powerful.
So it's about extending the functionality of the system.
Exactly. You can create blocks that perform very specific tasks or blocks that combine the functionality of multiple standard blocks. It really gives you a lot of flexibility.
So it's about taking that extra step, going beyond the standard building blocks to create something truly unique and tailored to your specific application.
Exactly. Another feature that I think is really cool, but often overlooked, is the alarm logging and analysis capabilities of PCS7.
Alarms, right? Crucial in an industrial setting.
Absolutely. You need to know when something's wrong, and you need to be able to analyze those alarms to figure out what happened and how to prevent it from happening again.
So it's not just about detecting those alarms, it's about understanding them, learning from them.
Exactly. And PCS7 has some really powerful tools for doing that. You can filter alarms, you can create trends, you can generate reports. It's a really comprehensive system.
So it's like having a detective on call helping you investigate those incidents.
I like that analogy. And one final hidden gem that I want to mention is the online help system in PCS7.
Online help, huh? Most people just ignore that.
I know, right? But the online help in PCS7 is actually really good. It's very comprehensive, it's well organized, and it's context sensitive. So if you're working on a specific task, you can just hit F1 and get help on that specific task.
So it's like having a PCS7 expert right there at your fingertips.
Exactly. I encourage everyone to spend some time exploring the online help system. You might be surprised at how much useful information is in there.
Great tips. Now, before we wrap up this deep dive into PCS7 configuration, I want to ask you a more personal question. What sparked your interest in automation? What drew you to this field?
I've always been fascinated by how things work, taking things apart, putting them back together, figuring out the mechanisms. And automation, it just takes that to a whole other level.
Right, because you're not just dealing with the physical components, you're dealing with the logic, the software, the intelligence that controls those components.
Exactly. And for me, the most rewarding part of working in automation is seeing those complex systems come to life, seeing how the software I write can control those real-world processes, make them more efficient, more reliable, safer.
It's like being a conductor, orchestrating this symphony of machines.
I like that. It's a great feeling knowing that you're playing a part in making those industries run smoothly, producing the goods and services that we all rely on.
Absolutely. And on that note, I want to thank you for joining us for this deep dive into the world of PCS7 configuration. I hope our listeners have found this exploration insightful and hopefully even a little bit inspiring.
It's been a pleasure sharing my knowledge and hopefully sparking some curiosity and enthusiasm for automation.
And for those who are eager to delve even deeper into the world of PCS7, we've provided links to some additional resources in the show notes. Don't hesitate to check them out and continue your learning journey. Until next time, happy configuring. Today, we're going to make you a PCS7 PC configuration expert.
Oh, that's a big promise.
Well, think of it like we're in a workshop, right? And we're going to break down all these complex PCS7 PC configuration concepts and procedures into manageable chunks.
Exactly.
So by the end, you'll be able to configure your own PCS7 system.
With confidence.
With confidence, yeah, exactly.
Yeah, and we're not just going to list steps or features.
Yeah.
We're going to really get in there.
Get into the nitty-gritty.
Yeah, the nitty-gritty and unpack, why certain steps are done.
Why are we doing this?
And give you really practical insights to help you avoid common pitfalls.
And, before we jump in, I think it would be helpful to just take a look at the map of what we're going to cover.
Absolutely.
So we're going to focus on the most important chapters to get a PCS7 system up and running.
Right.
So we'll start with cybersecurity.
Of course.
And then we'll move on to the PC components.
Okay.
And then, understand high availability.
Uh-huh.
And then we'll explore different operating strategies for engineering stations.
Right. And we'll also cover how to connect all those PC stations, select the right hardware, and then we'll walk you through the installation process.
Step by step.
Step by step.
Yeah. And then, of course, we can't forget licensing.
Yeah, licensing is important.
So we'll demystify that for you as well.
Absolutely.
So are you ready to dive into Chapter 1?
I'm ready.
Cybersecurity information.
All right.
Okay. So this is where it gets interesting, right? We all know that cybersecurity is important.
Right.
But in the world of industrial control systems, the stakes are even higher.
They are much higher.
Yeah.
The consequences can be huge.
So imagine like a hacker taking control of like a power plant or like a chemical factory.
Right.
The consequences could be catastrophic.
Absolutely. And that's why Siemens, they developed this whole concept of a holistic security concept.
Right.
That covers everything from, the products and solutions that they offer to, your own security practices.
Right.
It's a shared responsibility to keep these systems safe.
Yeah, it's like building a fortress.
Yes.
You need strong walls.
Right.
But you also need vigilant guards.
Absolutely.
Want a clear plan for defending against intruders.
Yeah, you need to think ahead.
So it's like you said, it's a shared responsibility.
It is.
And, just like any defense system, you need to stay ahead of the attacker.
Yes.
By constantly updating your defenses.
Exactly.
And this is where those product updates and patches come in.
Yes.
They're crucial.
So think of it like updating the software on your phone or your computer.
Right.
Those updates often include security patches that fix vulnerabilities that could be exploited by hackers.
Exactly.
So, the key takeaway here is that cybersecurity is an ongoing process.
It is.
It's not a one and done.
Set it and forget it.
You have to be constantly learning.
Yes.
You have to stay informed about potential threats. Keep your system updated.
Keep it updated.
And implement strong security practices throughout the entire life cycle of your PCS7 system.
Exactly. Okay, so let's move on to Chapter 2.
Okay.
Industrial security.
This chapter really gets into the details of securing your PCS7 system.
Right.
We're talking network security, access control, and system hardening.
You're right.
We're going to dive deep into the specifics of how to keep your system secure.
It's like the specialized training for your cybersecurity guards.
Exactly.
It's all about, understanding the specific threats and vulnerabilities that are relevant to industrial environments.
Yeah, and implementing the right measures to mitigate those risks.
Exactly.
It's all about being prepared.
Okay, so now let's jump ahead to Chapter 4.
Okay.
PC components of a PCS7 system.
All right, so this chapter is all about introducing the key players on your PCS7 team.
Okay.
It's like getting to know the different positions on a football team.
I love that analogy.
Yeah, each player has a specific role, and they all need to work together to win the game.
So who's our star quarterback?
The star quarterback. That's got to be the engineering stations.
The ES.
The ES for short.
Okay.
They design the plays, and they call the shots.
So the ES is where the magic happens.
Exactly.
It's where you do all the configuration, the programming, and the system management.
Yeah, you can create and modify control, logic, config for hardware components.
Right.
And design the operator interfaces all from the ES.
All from the ES.
It's a powerful tool.
So then who are our wide receivers?
The wide receivers. Those are the operator stations.
The OS.
The OS, yeah.
Okay.
They're on the front lines interacting with the system in real time.
So they're monitoring the plant processes and making adjustments as needed.
Right. They can start and stop processes, acknowledge alarms, and make sure everything is running smoothly.
And every team needs a good coach.
Oh, absolutely.
So that's where the maintenance station comes in.
The MS is like the team doctor always on call.
Always on call.
To diagnose and treat any problems that might arise.
Right. So if there's a problem with the system,
you go to the MS.
You go to the MS.
To troubleshoot the issues, monitor system performance, and perform maintenance tasks to keep the system healthy.
So what about those specialized players like the BTCH stations?
The BTCH stations,
Yeah.
they're like your special teamed units.
Okay.
They come in for specific plays. Like handling batch processes, which are common in industries like pharmaceuticals and chemicals.
So give me an example of a batch process.
Sure. Imagine a recipe where you have to add ingredients in a specific order.
Okay.
Under precise conditions.
Yeah.
That's what BTCH stations do for industrial processes.
Okay, that makes sense.
Yeah, they're the specialists.
And finally, we have the route control stations.
The RCS.
The RCS.
They're like the air traffic controller,
Okay.
managing the flow of materials and products throughout the plant.
So imagine like a complex network of conveyor belts and pipelines.
Exactly.
The RCS makes sure everything moves smoothly and efficiently.
That's right. They keep everything running on schedule.
So we've got all these different players on our team.
Right.
But how do they communicate with each other?
That's where the bus system comes in.
Okay, the bus system.
Yeah, it's the communication backbone of the entire PCS7 system.
So it connects all those components and allows them to share information and work together seamlessly.
That's right. It's the central nervous system of the plant.
I like that it's carrying vital information to all its organs.
Exactly. And just like the circulatory system has different types of vessels.
Okay.
The PCS7 bus system has two main branches,
Okay, what are they?
the terminal bus and the plant bus.
Okay, so the terminal bus is like what?
The terminal bus is like the aorta.
Okay.
It connects the PCS7 system to the outside world,
Right.
allowing communication with higher-level systems and external networks.
And the plant bus?
The plant bus is like the network of capillaries.
Okay.
It connects the servers and automation systems within the plant.
So it ensures smooth communication between all the internal components.
Exactly. It keeps everything talking to each other.
So the bus system is what allows all these different PC stations to work together as a team,
Right.
controlling and monitoring the plant processes efficiently and reliably.
It's the glue that holds everything together.
Okay, so now let's move on to Chapter 4.2,
Okay.
High Availability, Redundant Configurations.
So this is where we talk about building in resilience.
Okay, resilience.
Yeah. Imagine your star quarterback gets injured during the game. What happens next?
Right.
Do you forfeit the game or do you have a backup quarterback ready to step in?
That's a great analogy.
Yeah. So in critical process, control systems downtime can be extremely costly or even dangerous.
Right.
So you need to have backup systems in place to ensure that the process continues to operate even if the component fails.
So that's what redundancy is all about.
Exactly.
Having those backup systems ready to take over at a moment's notice.
Right. And in a PCS7 system, you can have redundant servers, network adapters, communication paths, and even power supplies.
So if one component fails,
The backup component kicks in automatically,
so
minimizing downtime and ensuring continuity of operations.
it's like having a spare tire in your car.
Exactly.
You hope you never need to use it,
Right.
but it's there just in case.
It's there for peace of mind.
Okay, so let's dive into the details of how redundancy is implemented in a PCS7 system.
Sure. One common approach is redundant servers.
Okay.
Redundant servers.
So picture this, you have two identical servers running in parallel,
Okay.
each with the same configuration and data.
Right.
The servers are constantly communicating with each other,
Mm-hmm.
synchronizing their data, and ensuring that they're always in sync.
Okay.
So if one server fails,
Yeah.
the other server can immediately take over.
Without any interruption.
Exactly.
Wow.
The system automatically switches over to the backup server,
Okay.
and the process continues to operate as if nothing happened.
That's incredible. It's a seamless transition, minimizing downtime and ensuring the integrity of the process.
Wow, so it's truly like having a hot spare,
Exactly.
ready to go.
Ready to take over at any moment.
Okay, so now let's talk about another critical aspect of high availability.
Okay.
Redundant communication paths.
All right, so imagine a highway with only one lane in each direction.
Okay, I'm picturing it.
If there's an accident or construction work, traffic comes to a standstill.
Right.
But if there are multiple lanes,
Yeah.
traffic can flow around the obstruction,
Okay.
minimizing delays.
So redundant communication paths work in a similar way.
Exactly.
Instead of having a single communication path between components.
You have multiple paths.
Got it.
If one path fails,
Yeah.
the system automatically switches to another path,
Okay.
ensuring that communication continues uninterrupted.
So this is especially important to PCS7 systems,
It is.
where critical process data needs to be transmitted reliably and in real time.
Exactly. Even a brief interruption in communication can have serious consequences.
Now let's move on to Chapter 4.3,
Okay.
Possible Ways to Operate Engineering Stations.
This chapter explores different approaches to working with engineering stations,
Okay?
especially in larger and more complex PCS7 projects.
So think of it like choosing the right tools and workspace
Okay.
for a large construction project.
Exactly.
So if you're building a small shed, you might be able to handle all the work yourself.
With basic tools.
Yeah.
The basic tools.
But if you're building a skyscraper,
Right.
you'll need a team of specialized workers,
Of course.
each with their own expertise and tools.
Yes.
You'll also need a central command center to coordinate the work and ensure that everyone is on the same page.
Exactly. So in large PCS7 projects,
Right.
a single engineering station might not be enough
It might
to
not.
handle the complexity and workload.
Yeah. You might need to use multiple PCs to distribute the engineering tasks.
Improving performance efficiency and collaboration.
So this approach is known as a multiple station system.
Exactly.
Okay.
And it involves a client-server architecture
Okay.
where multiple engineering station clients connect to a central server.
Okay, so each client can then focus on a specific part of the project.
Right, like configuring certain process units
Okay.
or designing specific operator interfaces.
An essential server manages the project data.
Exactly, ensuring that all the clients are working with the latest versions of the project files and that their changes are synchronized and merged seamlessly.
So it's like having a team of architects and engineers
Right.
working together on a large construction project.
Exactly, each contributing their expertise to the overall design.
Now, how do you decide whether to use a multiple station system or a single station system?
That's a good question, and that's the focus of Chapter 4.4.
Okay.
Differences between multiple station systems and single station systems.
So this chapter helps you choose the right tool for the job.
It does.
It provides a detailed comparison of these two architectures,
Right.
highlighting their strengths and weaknesses to guide your decision-making.
Exactly. It's all about making an informed decision.
So multiple station systems are like those large construction teams.
They are.
They're ideal for large and complex projects.
Right.
With high performance and collaboration needs.
Yeah, they offer greater flexibility, improved performance, and enhanced collaboration among engineers.
Yeah.
But they're also more complex to set up and manage.
Right.
And they require more hardware and software resources.
And single station systems are like that solo shed builder.
Exactly.
Simpler, more cost-effective,
Right.
and suitable for smaller projects,
Or training environments.
where a single PC can handle the entire workload.
Yeah, it's all about finding the right fit for your needs.
So the choice between the two architectures really depends on your specific needs and constraints.
It does.
It's about finding the right balance between complexity, functionality, and cost.
Exactly.
Yeah.
You need to weigh the pros and cons.
Now let's dive into some specific solutions for engineering stations.
Okay.
In Chapter 4.5,
Right?
Solutions for Engineering Stations.
So this chapter presents various options for setting up engineering stations,
Right.
tailored to different needs and scenarios.
So it's like choosing the right workspace and
Right.
tools
Yeah.
based on the type of project you're working on.
Exactly.
One solution is to use multiple engineering stations, which we've already discussed.
Right?
This approach is ideal for large and complex projects, where you need a team of engineers working concurrently on different aspects of the system.
It's all about teamwork.
Another solution, especially for smaller systems or training environments,
Right.
is to combine an engineering station and an operator station on a single PC.
Yeah. That can be a cost-effective option.
Right.
It simplifies the setup,
Okay.
allows you to perform both engineering tasks and operator monitoring from a single workstation.
So it's like a multi-tool
Exactly.
that combines the functionality of several different tools.
Into one compact package.
Now let's shift our focus to solutions designed for those larger, more demanding applications.
Okay, sounds good.
Chapter 4.6, Solutions for Multiple Station Systems, explores these in detail.
All right, so this chapter dives into various configurations for ensuring high availability and redundancy in multiple station systems.
So think of it like building in multiple layers of backup power
Right.
for a critical facility,
Exactly. If one power source fails, another one automatically takes over.
ensuring continuous operation.
That's the goal.
Okay, so one important solution is the redundant OS server,
Okay.
based on a server-client architecture.
So this configuration involves multiple operator station clients
Mhm.
connected to a central server or even redundant servers for high availability.
So if one server fails,
Another one seamlessly takes over.
ensuring that operators continue to have access to real-time process information and control.
Exactly. It's all about minimizing disruptions.
So imagine a hospital with multiple operating rooms,
Okay.
each with its own control panel for monitoring and controlling medical equipment.
And then picture a central server that manages all those control panels,
Good.
providing backup and redundancy in case one of the panels fails.
So that's what a redundant OS server does for a PCS7 system.
Exactly. It's the safety net for your critical operations.
Another important solution is a redundant BATCH server,
Right.
which is designed for applications that rely heavily on batch processes.
This configuration ensures that batch processes can continue uninterrupted,
Okay.
even if one of the BATCH servers fails.
It's like having two chefs working on the same recipe,
I like that analogy.
each with their own set of ingredients and equipment.
If one chef gets sick, the other chef can seamlessly take over and finish preparing the dish.
And you can also have redundant configurations for other critical functions,
Absolutely.
like root control and maintenance.
Each of these solutions is like having a backup generator for a critical facility.
Right. It provides peace of mind knowing that your system can handle unexpected events and continue operating reliably.
Exactly. It's all about planning for the unexpected.
Okay, now let's not forget about our smaller scale setups and specialized applications.
Right.
Chapter 4.7, Solutions for Single Station Systems. dives into those.
So this chapter explores various configurations,
Mhm.
suitable for smaller plants or specific functions that don't need the complexity of a multiple station system.
So it's like choosing a smaller, more fuel-efficient car for city driving,
Exactly.
rather than a large SUV that's designed for off-road adventures.
It's all about choosing the right tool for the job.
Okay, so one common solution is the OS single-station system,
Right.
where all the operator control and monitoring functions are handled by a single PC.
This is a great option for smaller plants or process cells where a full-blown multiple station system isn't necessary.
It's like having a single control panel for a small machine or process unit,
Exactly.
rather than a complex network of control panels for a large factory.
It keeps things simple and manageable.
And you can also have single-station systems for BATTH processes, root control and maintenance functions.
The key is to choose the configuration that best fits your needs.
Right. Balancing complexity with functionality and cost.
Exactly. You need to find the sweet spot.
Now let's talk about remote access and monitoring.
Okay.
In Chapter 4.8, Combined Web and Terminal Server.
This chapter introduces a powerful solution that allows you to access your PCS 7 system and control processes from anywhere in the world.
So it's like having a remote control for your plant.
Exactly. You can monitor processes, troubleshoot issues, and even make adjustments.
From your laptop, tablet, or smartphone.
That's right. You have complete control at your fingertips.
A combined web and terminal server allows you to connect thin clients,
Right.
which are basically simplified computers that rely on the server for processing power.
This approach has several advantages:
Like,
reduced hardware costs and centralized management.
it's like having a powerful central hub that controls multiple remote workstations. And for even greater reliability, you can set up 2 combined web and terminal servers in a redundant configuration.
Right. That way, even if one server fails,
You still have access to your system.
Exactly. It's like having a backup pilot for your airplane.
Okay, I like that analogy.
You always have someone ready to take over.
Now let's move on to Chapter 4.9,
Okay.
Connecting PC Stations.
So this chapter is all about the network infrastructure that connects the different parts of your PCS 7 system.
Right, ensuring that information can flow smoothly between the various components.
Exactly. It's the nervous system of the plant,
Transmitting signals between the brain
the engineering station,
and the various organs and limbs.
like the operator stations, the ATCH stations, and other components.
And what's the communication standard?
PCS 7 systems typically use industrial Ethernet.
Okay, industrial Ethernet.
Yeah, it's a robust and reliable networking technology
Okay,
that's specifically designed for industrial environments.
so it's like the high-speed rail network that connects major cities.
Yeah. Exactly. Fast, efficient, and reliable.
And just like different cities might have different rail layouts,
Right.
PCS7 systems can be set up with different network topologies.
That's right. There are several options to choose from.
So what are some of the common topologies?
Well, there's the bus topology,
Okay.
which is a simple linear layout where all the devices are connected to a single cable.
Like a string of pearls.
Exactly.
Okay, what else?
Then there's the star topology,
Oh, yeah.
which is a more centralized layout where all the devices are connected to a central hub.
Like spokes on a wheel.
Right.
Okay, and then there's the ring topology.
Yes, that's a circular layout where each device is connected to 2 other devices, creating a continuous loop.
And finally, the tree topology.
That's a hierarchical layout that combines elements of the bus and star topologies,
Okay,
creating a branching structure that resembles a tree.
so the choice of topology depends on what?
It depends on factors like the size and layout of the plant,
Okay.
the number of devices, the required bandwidth, and the redundancy requirements.
And some systems use a shared plant terminal bus,
Right.
which combines the functions of both the plant bus and the terminal bus.
This approach can be more cost-effective in terms of cabling,
Right.
but it also has some drawbacks.
Correct.
Reduced bandwidth and potentially lower availability.
So it's like having a single road that handles both local and long-distance traffic.
Exactly. It can get congested, and a problem in one area can affect traffic in other areas.
Now let's talk about a more flexible option for connecting PC stations. Wireless communication.
Okay.
Chapter 4.9.3, Connecting PC Stations via Wireless LAN, explores this in detail.
So wireless LAN, or WLAN, allows you to connect PC stations without physical cables,
Okay.
providing greater mobility and flexibility.
So it's like using a smartphone instead of a landline phone.
Exactly. You can move around freely and still stay connected.
In a PCS7 system, you can use WLAN to connect operator stations, maintenance stations, and even engineering stations.
Right, allowing operators and engineers to move around the plant and still access the system.
But it's important to remember that WLAN also introduces security risks.
It does. Just like anyone within range can potentially connect to an unsecured Wi-Fi network.
Right.
An unsecured double LAN can be vulnerable to unauthorized access and cyber attacks.
So it's crucial to implement strong security measures,
Absolutely.
like encryption and access control.
To protect your double LAN from intruders.
Now let's move on to Chapter 4.9.
Okay.
Time synchronization in a PCS7 system.
This chapter highlights the importance of having synchronized time across all the components of your PCS7 system.
So it's like an orchestra where all the musicians need to be playing in sync
Exactly.
to create a harmonious sound.
If the different components of your PCS7 system have different time settings,
Yeah.
it can lead to all sorts of problems, inaccurate data logging, or even control issues.
So give me an example.
Sure, imagine a situation where a sensor sends a signal indicating a pressure drop,
Okay.
but the timestamp on that signal is off by a few seconds.
Oh.
This discrepancy could lead to a delayed response, potentially allowing the pressure to drop further and cause a problem.
So that's why time synchronization is crucial
It is.
for ensuring the accuracy and reliability of your PCS7 system.
Because time is of the essence.
To synchronize time in a PCS7 system.
You typically designate one component as the time master.
Okay. The time master.
Yeah, this time master can be a dedicated server, a specific PC station, or even an external time source like a GPS receiver.
So the time master distributes time signals to all the other components in the system,
Right.
ensuring that they're all on the same page time-wise.
Exactly. Keeping everyone in sync.
And there are different time synchronization protocols that can be used.
There are like NTP,
Network time protocol.
SNTP.
Simple network time protocol.
These protocols allow the time master to communicate with other time servers
Okay.
and synchronize its clock with highly accurate time sources.
Ensuring that the entire system is running on the same precise time.
It's all about precision and accuracy.
Okay, so we've covered the key players in a PCS7 system, the importance of redundancy and high availability, and the different ways to connect those components and keep them in sync.
We've laid the groundwork.
Now let's move on to the physical hardware that makes up a PCS7 system.
Okay. Chapter 5, Hardware for PC Stations, dives into that world.
This chapter is like going shopping for the ingredients for your recipe.
I like that analogy.
You need to make sure you have all the right components in the right quantities.
Right.
And that they're all compatible with each other.
It's all about choosing the right ingredients for your PCS7 dish.
One option is to use pre-configured PC systems,
Okay.
also known as product bundles.
These are basically pre-built systems that are optimized for specific PCS7 roles.
It's like engineering stations or operator stations.
Exactly.
So it's like buying a pre-assembled computer
Right.
instead of building one yourself.
You save time and effort, and you can be sure that all the components are compatible and work together seamlessly.
Another option is to build your own systems, selecting the individual components based on your specific needs and budget.
This gives you more flexibility, but it also requires more expertise and careful planning.
Right. To ensure that all the components are compatible and meet the requirements of your PCS7 system.
Exactly. It's a trade-off between convenience and customization.
So whether you choose pre-configured systems or build your own, you need to consider the basic hardware requirements for each PCS7 role.
This includes the CPU speed,
Okay.
the amount of RAM, the hard disk space, the graphics card, and the network adapter.
And it's crucial to use approved and certified hardware components
Absolutely.
to ensure reliability and safety.
Industrial control systems operate in demanding environments.
Right.
And you don't want to risk using subpar hardware that could fail and potentially compromise the safety of your plant or process.
Now let's zoom in on a specific set of components. The network adapters and communication modules
Okay.
that connect your PC stations to the communication buses.
Chapter 5.2, Components for Connection to the Terminal Bus Plant Bus, delves into those.
So this chapter focuses on the connective tissue of your PCS7 system,
Right.
ensuring that information can flow freely between the various components.
It's all about keeping the lines of communication open.
Okay, so there are two main options for connecting PC stations to the buses:
Right?
standard network adapters and communication modules with onboard processors.
Often referred to as CP162X modules.
Those standard network adapters are like the basic roads
Right.
that connect different neighborhoods.
They're readily available, cost-effective, and suitable for less demanding applications where high speed and advanced features aren't critical.
Okay.
Communication modules with onboard processors, on the other hand, are like the highways that connect major cities.
Okay, so they offer higher performance.
Yes,
They can handle more traffic and provide advanced features like redundancy and diagnostics.
exactly. They're built for speed and reliability.
And the choice between these two options depends on what?
It depends on factors like the number of devices you need to connect.
The required communication speed, the level of redundancy you need, and your budget.
And just like any other software component in a PCS 7 system,
Right.
these network adapters might require specific licenses to operate correctly.
That's right. You need to make sure you have the right permissions.
Now let's explore some optional hardware components that can enhance the functionality and flexibility of your PCS 7 system.
Chapter 5.3, Optional Hardware, dives into those.
So this chapter is like adding accessories to your car.
Right.
You can choose the ones that best fit your needs and preferences, adding extra comfort, convenience, and functionality.
It's all about customizing your PCS 7 ride.
One optional component is a smart card reader.
Okay, a smart card reader.
This device adds an extra layer of security
Right.
by requiring users to authenticate themselves with a smart card before they can access the system.
It's like having a security guard at the entrance to your plant.
Right, checking everyone's ID before allowing them entry.
Exactly.
Another optional component is a printer.
Okay. This allows you to generate hard copies of reports,
Right.
logs, and other documentation from the PCS 7 system.
So which can be useful for troubleshooting,
Right.
auditing record keeping, and providing operators with hard copies of critical information.
So it's like having a printing press in your office,
Exactly.
allowing you to create physical copies of important documents.
It's always good to have a paper trail.
And for those critical situations that require immediate attention, you can add a sound card to your PCS 7 system.
Okay, a sound card.
Yeah, this enables audible alarms and notifications,
Right.
making sure that operators are aware of important events.
Even if they're not looking at the screen.
Exactly.
So it's like having a siren that goes off when there's a fire or a security breach.
Right, alerting everyone in the vicinity to take immediate action.
Exactly. It's all about getting people's attention when it matters most.
Now let's shift gears and talk about the process of installing your PCS 7 system.
Okay. Chapter 6, Installing PC Stations, is where the rubber meets the road.
So this chapter is all about making the installation process as smooth and efficient as possible.
Right.
Minimizing downtime and ensuring that your PCS 7 system is up and running quickly and reliably.
It's all about getting you up and running as smoothly as possible.
So think of it like assembling a piece of furniture.
Okay, I can visualize that.
You want to make sure you have all the parts,
Mm-hmm.
that you understand the instructions,
Right.
and that you have the right tools before you start putting together.
Exactly. Preparation is key.
So before you begin the installation, it's crucial to carefully read the installation instructions provided by Siemens.
Of course, those instructions are your roadmap to success.
They'll provide valuable information about the installation process, the system requirements,
Right.
and any special considerations
Mhm.
specific to your PCS 7 configuration.
It's all about being prepared and knowing what to expect.
And you'll also need to make sure that your PC stations meet the necessary hardware and software requirements
Absolutely.
for the PCS 7 software packages you'll be installing.
So this includes things like the operating system version,
Right.
the amount of RAM, the hard disk space,
Okay.
and the network adapter compatibility.
It's like making sure that all the pieces of the puzzle fit together.
Exactly. Everything needs to work in harmony.
Once you've verified the system requirements and gathered all the necessary materials,
Okay.
like the PCS 7 installation media,
The license keys.
and any additional drivers or software, you can begin the installation process.
Sounds good. Let's get started.
So the installation typically involves two main steps.
Okay. What are they?
First, you install the operating system,
Right.
which involves installing the chosen operating system on each PC station,
Okay.
creating the foundation upon which the PCS 7 software will be installed.
Makes sense.
And then second, you install the PCS 7 software,
Okay.
which involves installing the PCS 7 software packages themselves, configuring the system settings,
Right.
and activating the software with your license keys.
So we're basically building the house and
Yep.
then furnishing it.
Exactly. We'll break down each of these steps in detail,
Okay.
providing clear instructions and guidance.
To help you navigate the installation process smoothly and confidently.
Now imagine you're setting up a workspace for a team of people.
Okay.
You need to decide how you want to manage access to resources and data,
Right.
and how you want to handle security.
So it's about setting the ground rules for collaboration.
Exactly. And
Yeah.
that's similar to choosing between a work group and a Windows domain for your PCS 7 system,
Okay, I see the analogy.
which we'll discuss in Chapter 6.2, Work Group and Windows Domain.
All right, let's explore these options.
A work group is a simple networking model
Okay.
where each computer manages its own resources and security settings.
So it's like a group of independent contractors,
Exactly.
each responsible for their own tools and security.
This approach is suitable for smaller networks
Right?
with limited security requirements where a centralized administration model isn't necessary.
It keeps things simple and straightforward.
A Windows domain, on the other hand, is a more centralized networking model,
Okay.
where a dedicated server known as a domain controller
Right.
manages security and access control for all the computers in the network.
So it's like a corporation with a central IT department
Exactly.
that sets security policies and manages access to resources for all employees.
This approach offers greater control and security, especially in larger networks with sensitive data and stricter compliance requirements.
So it's a more robust and secure option.
The choice between a workgroup and a Windows domain depends on factors like the size of your network,
Okay.
your security needs, your existing IT infrastructure,
Right.
and your budget.
It's all about finding the right balance for your specific situation.
Smaller networks with simple security needs can often get by with a workgroup,
Yeah.
while larger networks with more demanding security and management needs typically benefit from the centralized control and features of a Windows domain.
It's about choosing the right level of complexity and control.
Now let's dive into the details of installing the operating system.
Okay. Chapter 6.3, Installing the Operating System.
This is where you lay the foundation for your PCS 7 system.
Right. It's the bedrock upon which everything else is built.
So it's crucial to choose the right operating system and install it correctly.
Absolutely. The operating system is the heart of the system.
PCS 7 supports various versions of Microsoft Windows,
Okay.
both for client workstations and for servers.
So you have a range of options to choose from.
The specific version you choose will depend on the specific PCS 7 software packages you'll be using, the hardware requirements of those packages,
Right.
and the overall system architecture.
It's all about finding the right fit.
And just like you wouldn't build a house on a shaky foundation,
Of course not.
you don't want to install PCS 7 on an unstable or incompatible operating system.
That would be a recipe for disaster.
Exactly. It's essential to choose a supported operating system version and install it correctly to ensure the stability and reliability of your PCS 7 system.
So you're saying we need a solid base to build upon.
Right. And remember, just like you wouldn't want to paint over a dirty wall,
Yeah, that would make sense.
it's essential to use a clean installation of the operating system.
A clean installation ensures that there are no conflicting file settings or applications from previous installations that could potentially cause problems with PCS 7.
So it's like starting with a blank canvas.
Exactly. You want a fresh, clean slate to work with.
And of course, you'll need to go through the standard operating system installation process, which includes partitioning your hard drives, formatting those partitions, and configuring basic settings like the language, time zone, and network settings.
These are the essential steps for setting up the operating system.
These steps are typically straightforward,
Yeah, they usually are.
but it's essential to follow the instructions carefully and configure the settings correctly to ensure that your operating system is properly set up and ready for PCS 7.
It's all about laying a strong foundation for your PCS 7 system.
Okay, so now let's delve into some specific operating system configuration tasks that are important for PCS 7 systems.
Right.
These are like fine-tuning the engine of your car to make sure it's running smoothly and efficiently.
So we're optimizing the system for peak performance.
Exactly. And one such task is installing the message queuing service,
Okay.
which is covered in Chapter 6.3.7, How to Install the Message Queuing Service.
So this is all about setting up reliable communication between applications.
Exactly. The message queuing service, or MSMQ for short, is like a reliable postal service for applications in a PCS 7 system.
Okay. I can see the analogy.
It allows applications to communicate with each other reliably, even if they're not running at the same time,
Right.
or if there are temporary network interruptions.
So it's like sending a letter. You don't have to wait for the recipient to be home to deliver it.
Right.
You can just drop it in their mailbox and they'll get it when they check their mail.
Exactly. MSMQ provides that same level of reliability for application communication in a PCS 7 system.
So applications can send messages to each other without worrying about whether the recipient is currently available.
Right. The messages are stored in a queue until the recipient is ready to receive them.
That's a clever way to ensure reliable communication.
This is especially important in industrial automation systems, where continuous operation is essential.
Right.
And applications need to communicate reliably even if there are temporary glitches or outages.
It's all about keeping the system running smoothly no matter what.
So to install the message queuing service, you need to enable it as a Windows feature.
Okay, so it's already built into the operating system.
Exactly. It's like flipping a switch to turn on a light.
You're just activating a feature that's already there.
Now let's move on to another essential operating system configuration task, configuring the Microsoft Internet Information Service, or ISA.
Okay. Chapter 6.3.8, How to Configure the Microsoft Internet Information Service, ISA for the server, covers this.
So ISA is like the web server for your PCS 7 system.
Right. It allows authorized users to access web pages, data, and applications hosted on your PCS 7 system.
From anywhere in the world.
So think of it like setting up a website for your plant.
I like that.
Authorized users can visit the website to monitor processes, view reports, or even control certain aspects of the plant remotely.
So ISA is required for various PCS 7 functions like remote access to operator interfaces,
Right.
web-based configuration tools, and data exchange with external systems.
It's a versatile tool.
To configure EVI for PCS 7, you'll need to enable specific features, set up security permissions, and configure other settings to ensure that it works correctly and securely with the PCS 7 software.
So it's like setting up security cameras and access control for your plant.
Right. You want to make sure that only authorized personnel can access sensitive areas.
Exactly. Security is paramount.
Now let's talk about another important operating system concept, virtual memory.
Okay.
Chapter 6.3.1a. How to set the paging file explains this.
So this is about expanding the memory capacity of the system.
It's exactly. Virtual memory is a clever technique that allows your computer to use hard disk space as an extension of RAM,
Right.
giving it more memory capacity than is physically installed.
So it's like having a magic bag that expands to hold more items than you'd think possible.
I like that analogy. The paging file, also known as the swap file, is the portion of the hard disk that's used as virtual memory.
Oh, yeah.
So when your system runs out of physical RAM,
Which can happen if you're running many applications or working with large files.
right,
It starts swapping data between RAM and the paging file.
and this allows the system to keep running smoothly,
Yes.
even if it's working with more data than can fit in RAM.
So it's like having a temporary storage room where you can put some of your belongings when your house is full of guests.
Exactly.
Okay.
You can retrieve those belongings later when you have more space.
It's a clever way to manage limited resources.
Configuring the paging file correctly is crucial for optimal system performance.
Absolutely.
If the paging file is too small, the system might slow down or even crash when it needs to swap data.
Imagine a highway with too few lanes.
Right.
When traffic volume increases, the highway gets congested and everything slows down.
On the other hand, if the paging file is too large, it can waste valuable disk space
Right.
and potentially slow down the system as well.
It's like having a storage room that's much larger than you need.
Exactly. It takes up valuable space, and it can be time-consuming to find the items you need.
So it's all about finding the right balance.
Right. We'll discuss the recommended settings for the paging file size and explain how to configure it correctly for your PCS 7 system,
Okay.
finding that balance between performance and efficiency.
So we're optimizing the system for speed and storage.
Exactly. Now, just like fine-tuning the engine of your car can improve its performance and fuel efficiency,
Right.
tweaking your system settings can optimize your PCS 7 system for peak performance.
Chapter 6.3.11, How to Make Additional System Settings, dives into those details.
So this involves things like setting up local users in groups.
Okay.
This is like assigning different access levels to different employees in your company.
Right. You don't want everyone to have access to everything.
And then configuring the time zone and regional settings.
Okay.
This ensures that your system displays the correct time and date, and that it uses the appropriate language and formatting conventions for your region.
So we're making sure the system is set up for the correct location.
And then disabling unnecessary services and startup programs.
Okay.
This is like removing unnecessary weight from your car to improve its fuel efficiency.
Right. You want to streamline the system.
By disabling services and programs that you don't need, you can free up system resources and improve performance.
It's all about making the system run as efficiently as possible.
And then adjusting the power saving options.
Okay.
This allows you to balance power consumption with performance.
Right.
You might want to prevent the system from going to sleep or turning off the monitor during critical operations.
Right.
But you might also want to enable power-saving features when the system is idle to conserve energy.
So it's about finding the right balance between performance and energy efficiency.
It's all about finding the right settings for your specific needs and preferences.
Right. Customizing the system to work best for you.
Making sure that your PCS 7 system is running smoothly, efficiently, and reliably.
That's the goal.
Now let's talk about personalization.
Okay.
Just like we like to personalize our workspaces with things like photos, plants, and comfortable chairs, we can also personalize the user interface of our PCS 7 system to make it more comfortable and user-friendly.
Chapter 6.3.12, how to set the color scheme and font size covers this.
So the color scheme and font size can affect the readability of the screen,
They can.
especially for users who spend long hours working with the system.
If the color scheme is too bright or the font size is too small, it can cause eye strain and fatigue,
Right.
leading to errors and reduced productivity.
It's like trying to read a book with tiny print in a dimly lit room.
Exactly, a recipe for headaches and frustration.
By adjusting the color scheme, you can reduce glare and improve contrast, making it easier to distinguish between different elements on the screen.
Okay, so we're making the screen easier on the eyes.
And by adjusting the font size, you can make text easier to read,
Right.
especially for users with visual impairments or those working on larger monitors.
So we're making the system more accessible.
PCS 7 allows you to customize these settings to create a more comfortable and accessible working environment for each user, reducing eye strain and improving productivity.
It's all about making the system work for the user.
Now, just like a mechanic might need specialized tools to work on different parts of a car,
Right.
you might need to install additional services to support specific functionalities in your PCS 7 system.
Chapter 6.3.14, installing additional services for SIMATIC Batch, covers one such scenario.
So SIMATIC Batch is a powerful software package designed for handling batch processes,
Okay.
which are common in industries like pharmaceuticals, chemicals, and food processing.
Right.
Think of a bakery where different batches of cookies are baked throughout the day.
Okay, I like cookies.
Each batch might have a different recipe, baking time, and temperature. SIMATIC Batch helps you manage those different batches,
Okay.
ensuring that each batch is processed correctly and that the final product meets the required specifications.
So it's like the master baker, keeping everything running smoothly.
To transfer SIMATIC Batch archives, which contain data about the batch processes, you might need to use FTP,
File transfer protocol.
a common method for transferring files over a network.
And to use FTP with SIMATIC BAT-CH, you need to install specific services on the PC stations involved in the process.
Right, it's like setting up a delivery service for your batch data.
I see the analogy.
You need the right vehicles and infrastructure to transport the data from one location to another.
So what services do we need to install?
For example, you'll need to install the FTP service on the PC station that will be sending the BAT-CH archives,
Okay.
and the ICA service on the PC station that will be receiving them.
Makes sense.
We'll provide clear instructions and explanations to ensure that you install and configure these services correctly,
All right.
making sure that your batch data is delivered safely and reliably.
So we're making sure the cookies get delivered fresh and intact.
Now imagine you're working on an important project and suddenly your computer crashes.
Oh, no.
All your work is gone.
It's a nightmare scenario.
It's a nightmare scenario, right?
Yes, data loss is never fun.
That's why backups are so important,
Absolutely.
which we'll discuss in Chapter 6.3.15, creating a backup.
So this is all about protecting ourselves from data loss.
Backups are like insurance policies for your data.
I like that analogy.
You hope you'll never need them, but you're incredibly grateful to have them when you do.
It's like having a safety net.
They allow you to recover your valuable data in case of unexpected events,
Right.
like system failures, hardware malfunctions, accidental deletions, or even cyber attacks.
So backups are essential for peace of mind.
Think of it like having a spare key for your house.
Okay.
If you lose your main key, you can still get into your house using the spare key.
It's always good to have a backup plan.
Creating backups regularly is one of the most important things you can do to protect your PCS 7 system and ensure business continuity.
It's like wearing a seatbelt in a car. A simple precaution that can prevent a lot of pain and suffering if something goes wrong.
There are various ways to create backups,
Okay.
like creating a system image.
Right.
This is like taking a snapshot of your entire system.
Capturing the operating system, applications, settings, and data.
You can use this image to restore your system to its previous state if something goes wrong,
So it's like going back in time.
and then copying critical files to an external drive.
Okay.
This involves manually selecting the files and folders that are most important to you and copying them to a separate storage device,
Like an external hard drive or a USB flash drive.
and then using cloud-based backup services.
Okay.
This involves backing up your data to a remote server over the internet. This provides off-site storage and protection against local disasters like fires, floods, or power outages.
So it's like having a backup copy of your data in a different location.
The best backup strategy for you will depend on various factors,
Okay.
like the size of your data, your budget, your security requirements, and your recovery time objectives,
RTO.
which define how quickly you need to restore your system after an outage.
So it's about finding the right backup solution for your specific needs.
We'll discuss the different backup options in more detail and provide recommendations for creating a robust backup strategy that meets your specific needs
Okay.
and ensures that your PCS7 system is protected against data loss.
So we're covering all the bases.
And remember, it's essential to back up not only your data, but also your license keys.
Right. Those keys are essential for activating your PCS7 software.
And if you lose them,
You might not be able to use your system.
potentially leading to costly downtime.
So back up everything important.
Now let's move on to the main event,
Okay.
installing the PCS7 software itself.
Chapter 6.4, Installing the PCS7 software, guides you through the process.
So this is where you actually transform your PC stations into fully functional components of your PCS7 system.
Right. We're bringing the system to life.
Breathing life into the hardware with the power of software.
It's like turning on the lights.
Before you begin the installation,
Yeah.
it's crucial to make sure that you have gathered all the necessary materials.
Okay, what do we need?
This includes the PCS7 installation media.
Right.
This could be a DVD, a USB flash drive, or a downloaded image file containing the PCS7 software packages.
So we have options for how to get the software.
And then your license keys.
Okay.
These are unique codes that you'll need to enter to activate the software.
Like a password?
And then any documentation or instructions provided by Siemens.
Of course.
This might include release notes, installation guides, or configuration manual.
It's always good to have the documentation handy.
You'll also need to double check that your PC stations meet the hardware and software requirements for the PCS7 software packages you'll be installing.
Right. We need to make sure everything is compatible.
This includes things like the operating system version, the amount of RAM, the hard disk space, and the compatibility of the network adapters.
So we're making sure the foundation is solid.
There are typically two main ways to install PCS7.
Okay. What are they?
Using the SIMATIC PCS7 USB flash drive.
Right.
This is a convenient option for single PC installations.
So you just insert the USB drive into the PC station and run the setup program.
And then installing it over the network.
Okay.
This is more efficient for installing PCS7 on multiple PCs simultaneously.
So you can distribute the installation files over the network and install them remotely on multiple PC stations.
Right, without having to physically visit each station.
That's much more efficient.
The choice between these two methods depends on factors like the number of PC stations you're installing PCS7,
Okay.
the speed of your network, and your personal preference.
So it's about choosing the method that works best for you.
And just like you need the right credentials to access a secure facility,
Right.
you'll need administrator rights to install PCS7 on your system.
This ensures that the installation program has the necessary permissions to access system files and make changes to the operating system configuration.
So it's like having the keys to the kingdom.
Exactly. You need the proper authorization.
Once you've chosen the installation method, verified your administrator rights, and gathered all the necessary materials, you can start the installation process.
Okay, let's get the show on the road.
The installation typically involves following a series of steps,
Okay.
like choosing the language and accepting the license agreements.
Right.
This is where you select the language for the installation process and agree to the terms and conditions of the software license agreement,
Standard procedure.
and then selecting the PCS7 software packages you want to install.
Okay.
PCS7 is a modular system,
Right.
so you can choose to install only the packages you need for your specific application.
So you can customize the installation.
And then configuring the system settings,
Okay.
like the network settings and the time zone.
This ensures that your system is properly configured to communicate with other devices on the network and to display the correct time and date.
And then entering your license keys to activate the software.
Okay.
This unlocks the full functionality of the software
Right.
and allows you to use it according to the terms of the license agreement.
So the license key is like the key that unlocks the treasure chest.
We'll provide detailed instructions for each step of the installation process, guiding you through the process and ensuring that you install and configure the PCS7 software correctly.
So we're here to help you every step of the way.
Now let's talk about collaboration.
Okay.
In Chapter 6.4.4, how to prepare the engineering station for multi-user operation.
So this is about enabling teamwork in the engineering process.
In large and complex PCS7 projects, multiple engineers often need to work on the same project simultaneously.
Right.
This can lead to conflicts and confusion if the engineers are not working with the latest version of the project files, or if their changes are not synchronized properly.
So it's like multiple authors working on the same book.
Exactly.
If they're not careful, They might end up with different versions of the same chapter, leading to inconsistencies and errors in the final book.
To prevent these problems, PCS 7 uses a central database system called Sybase to manage the project data.
Okay, Sybase.
Sybase acts like a central library where
Right.
all the project files are stored.
So everyone has access to the same information.
Multiple engineers can connect to Sybase and work on the project concurrently.
Okay.
But the system ensures that they're always working with the latest version of the files
Right.
and that their changes are merged seamlessly.
So it's like having a shared online document where multiple people can edit the same document simultaneously.
Exactly, without overwriting each other's changes.
That's a very efficient way to collaborate.
To use Sybase for multi-user engineering, you'll need to install it on a dedicated server and configure the engineering stations to connect to that server.
Okay, so we need to set up the central library.
Once the Sybase server is up and running, multiple engineers can connect to it and work on the PCS 7 project collaboratively, improving efficiency, consistency, and communication within the engineering team.
So it's a win-win situation for everyone.
Now imagine you're a historian tasked with preserving and analyzing historical records
Okay.
to understand the past, learn from it, and make informed decisions about the future.
So we're talking about learning from experience.
That's essentially the role of the process historian in a PCS 7 system,
Okay, the process historian.
which we'll explore in Chapter 6.4.5, How to Install the Process Historian.
So this is about capturing and analyzing data from the process.
The process historian is like a digital archive for your plant,
Right. It's like a giant library of process information.
recording vast amounts of data about the process over time,
Okay, what kind of data are we talking about?
including process values.
Okay.
These are measurements of process variables, like temperature, pressure, flow rate, and level. It's like keeping a detailed log of the temperature and humidity in a greenhouse to track the growing conditions over time.
So we're tracking the vital signs of the process.
And then alarms and events.
Okay.
These are notifications triggered by specific conditions in the process, like exceeding a temperature limit or detecting a pressure drop. It's like having a security system that alerts you if someone tries to break into your house.
So we're getting notified when something goes wrong.
And then batch data.
Okay.
This includes information about specific batches of products produced in the plant, like the start and end times of the batch, the ingredients used, and the quality control results. It's like keeping a recipe book that records the ingredients, quantities, and cooking times for each dish you make.
So we're documenting the production process.
And then operator actions. This includes information about any actions taken by operators, like starting or stopping processes, acknowledging alarms, or making manual adjustments. It's like having a security camera that records who entered and exited a building and what actions they performed while inside.
So we have a complete record of what happened.
This historical data is invaluable for various purposes,
Right. It's like having a time machine.
like troubleshooting.
Okay.
By analyzing past events, you can identify patterns and trends that might indicate potential problems. It's like a detective examining clues to solve a crime.
So we're using the data to solve problems.
And then optimization.
Okay.
By analyzing process data over time, you can identify areas where the process can be improved,
Right.
such as reducing waste, increasing efficiency, or improving product quality. It's like a coach analyzing the performance of an athlete to identify areas for improvement.
So we're using the data to make things better.
And then reporting.
Okay.
You can generate reports for various purposes, such as compliance with regulations. Some industries have strict regulations about record keeping and reporting, and the process historian can help you meet those requirements.
So we're staying on the right side of the law.
And then performance monitoring.
Okay.
You can track key performance indicators, KPIs, over time to monitor the efficiency and effectiveness of your process.
So we're keeping an eye on the bottom line.
And then historical analysis.
Okay.
You can analyze past trends to make informed decisions about the future, such as forecasting demand, planning production, or making investment decisions.
So we're using the past to predict the future.
To use the process historian, you need to install it on a dedicated server and configure the PCS 7 system to send data to that server.
Okay, so we need to set up the archive.
It's like setting up a secure vault to store your valuable historical records.
A safe place for all that important data.
Once the process historian is set up and running, you can use various tools and interfaces to access the data, analyze it, and generate reports, gaining valuable insights into the past, present, and future of your process.
So it's a powerful tool for understanding and optimizing your process.
Now let's revisit the concept of redundancy,
Okay.
but this time focusing on the central archive server,
Right.
which is covered in Chapter 6.4.6, how to install the Central Archive server.
So this is about backing up the process historian data.
The Central Archive server is like a backup system for your process historian data.
Okay, a backup for the backup.
It mirrors the data from the primary process historian server to a separate server,
Right.
ensuring that your valuable historical data is protected even if one of the servers fails.
It's like having a backup copy of a valuable book stored in a different location.
If one copy is damaged or destroyed.
You still have the other copy.
To set up the Central Archive server, you need to install it on a separate server, preferably in a different physical location, from the primary process historian server.
Okay.
This provides additional protection against disasters like fires, floods, or power outages that could potentially affect both servers if they were in the same location.
So we're spreading the risk.
You'll also need to configure the Central Archive server to synchronize with the primary process historian server,
Right.
ensuring that the data on both servers.
Is always up to date.
This synchronization process can be set up to occur automatically at regular intervals,
Right.
such as every hour or every day,
So we're constantly backing up the data.
ensuring that your historical data is always backed up and protected.
It's like having a safety net for your data.
Now let's move on to a crucial aspect of system administration,
Okay.
managing user counts and permissions.
Right. Chapter 6.4.8, Setting Up User Groups and Users, covers this.
This is all about controlling who has access to your PCS 7 system
Right.
and what they're allowed to do within the system.
So it's all about security and access control.
Think of it like having different levels of security clearance for different personnel in a company.
Okay, I see the analogy.
You wouldn't want everyone to have access to all the confidential information
Right.
for the ability to make changes to critical systems, right?
Absolutely. You need to have a way to control access to sensitive data and functions.
Exactly, ensuring that only authorized personnel can perform certain actions.
So it's like having different job titles within a company.
Right.
Each job title has a specific set of responsibilities and access privileges.
Exactly. A receptionist might have access to the phone system and the company directory,
Right.
but they wouldn't have access to the financial records or the ability to make changes to the company website.
So we're talking about role-based access control.
Exactly. PCS 7 uses a role-based access control model to manage user permissions.
Okay.
This means that users are assigned to specific roles,
Right.
and each role has a set of permissions that define what the user can and cannot do within the system.
Makes sense.
To manage users in groups in PCS 7, you use a tool called SIMATIC Logon.
Okay, SIMATIC Logon.
SIMATIC Logon is like the security guard for your PCS 7 system.
Right. It's the gatekeeper.
It controls who can enter the system,
Mm-hmm.
what areas they can access,
Okay.
and what actions they can perform.
So it's a very important tool.
SIMATIC Logon allows you to create user accounts.
Okay.
This involves setting up new user accounts for people who need to access the PCS 7 system,
So we're creating the user ID.
and then assign users to groups.
Mhm.
This allows you to group users together based on their roles or responsibilities,
Okay.
simplifying the process of assigning permissions,
So it's like creating departments within a company.
and then define roles and permissions.
Okay.
This is where you define the specific actions that each role is allowed to perform within the system.
So we're defining the access levels for each role.
SIMATIC Logon integrates with Windows User Management, so you can use your existing Windows user accounts and groups to manage access to PCS 7.
Okay.
This simplifies administration and ensures consistency across your systems.
So we're leveraging existing infrastructure.
Now let's dive into the world of drivers.
Okay. Chapter 6.5, Installation of Drivers for PCS 7.
Drivers are like translators that allow the operating system to communicate with specific hardware devices.
Okay, I see the analogy.
Think of it like needing an interpreter to communicate with someone who speaks a different language.
So the driver is the bridge between the software and the hardware.
Without the right drivers, the operating system wouldn't know how to interact with the hardware, and the hardware wouldn't be able to function properly.
So the drivers are essential for everything to work together.
PCS 7 systems use a wide variety of hardware devices such as communication modules, network adapters, field devices, and I/O modules.
Right.
These devices are like the workers in a factory, each with their own specialized skills and tasks.
Each playing a vital role.
To work together effectively, they need to communicate with each other and with the central control system.
The PCS 7 software.
And to facilitate that communication, each device needs a specific driver.
Right.
The driver acts as a translator, converting the signals and data from the device into a format that the operating system can understand, and vice versa.
So it's a two-way communication channel.
Fortunately, the PCS 7 setup program automatically installs drivers for many common communication modules and network adapters, simplifying the installation process.
That's a nice time saver.
However, if you add new hardware or change the configuration of existing hardware after the initial installation, you might need to install or update drivers manually.
Okay, so we might need to do some manual work.
It's like hiring a new worker for your factory. You might need to provide them with specific training or tools to help them integrate into the existing workforce and perform their tasks effectively.
So we're onboarding the new hardware?
To install drivers manually, you typically use the device manager in Windows.
Right, the device manager.
The device manager is like the HR department for your computer hardware.
Okay.
It lists all the devices connected to your system and allows you to view and manage their properties, including their drivers.
So we can see all the players on the team?
You can use the device manager to update drivers, uninstall drivers, or troubleshoot problems with devices.
It's a handy tool for managing your hardware.
Now let's focus on configuring a specific type of communication module, the CP162X, which is covered in Chapter 6.5.1.5. How to prepare a PC station with CP162X for operation in PCS 7.
So this is about getting those high-performance communication modules ready for action.
CP162X modules are high-performance communication modules designed for demanding industrial applications, where high availability, reliability, and diagnostics are paramount.
They're the workhorses of the communication system.
You're like the elite special forces unit of your PCS 7 system. Highly skilled, highly trained, and ready to handle the most challenging missions.
You're the best of the best.
CP162X modules use something called NDIS adapters, which are virtual network adapters that allow the PC to communicate with the PCS 7 system using the ISO protocol, a specialized industrial communication standard.
So it's a specific language for industrial communication.
NDIS adapters are like virtual versions of physical network adapters, providing a software-based interface for communication over the network.
So we're creating virtual connections.
To configure these NDIS adapters for use with PCS 7, you need to perform several steps, including setting the adapter name. This gives the adapter a unique identifier, making it easier to manage and troubleshoot.
So we're giving each adapter a name tag.
And then configuring the IP address and subnet mask. This determines the adapter's network address and how it fits into the overall network topology.
So we're assigning addresses to the adapters.
And then configuring other network parameters. This might include settings like the default gateway, the DNS server addresses, and the WS server addresses.
So we're fine-tuning the network settings.
We'll provide step-by-step instructions for configuring the NDIS adapter, ensuring that it's set up correctly for communication with the PCS 7 system.
So we're providing a roadmap for success.
Now let's move on to the sometimes confusing world of software licensing.
Okay. Chapter 6.6, licensing.
Software licenses are like legal contracts that grant you permission to use specific software components and features.
So they're the rules of the game.
Think of it like renting a car. The rental agreement specifies the terms and conditions of use, such as the rental period, the mileage limits, and the insurance coverage.
So we're talking about the fine print.
Software licenses work similarly. They define how you can use the software, how many users can access it, and what features you're allowed to use.
So it's about defining the boundaries of use.
PCS 7 uses different types of licenses, depending on the required functionality and the number of users or devices.
Right.
You might need a separate license for each engineering station, station or server in your system.
So each component might need its own license?
You might also need separate licenses for specific software packages or features.
So it's like buying tickets for different rides at an amusement park.
To manage these licenses, PCS 7 provides a handy tool called the Automation License Manager.
Okay, the Automation License Manager?
The Automation License Manager is like the key master for your PCS 7 system.
Right, it keeps track of all the keys.
It keeps track of all your licenses, and it allows you to view the licenses you have installed. This provides a quick overview of your current license inventory.
So we can see what we have.
And then add new licenses. When you purchase new software or features, you can use the Automation License Manager to add the corresponding licenses to your system.
So we can expand our license collection.
And then transfer licenses between different storage locations. This allows you to move licenses between different storage devices or servers, providing flexibility and redundancy.
So we can move the licenses around as needed.
And then generate license reports. This allows you to create reports about your license inventory,
Okay.
which can be useful for auditing purposes or for tracking software usage.
So we can keep track of our license usage.
License keys are typically provided as a string of characters that you enter into the Automation License Manager to activate the software.
Okay, so it's like a password.
It's like entering a password to unlock a door. The license key acts as the password, granting you access to the software's functionality.
So it unlocks the features.
Once the license key is entered and validated, the software is unlocked and can be used according to the terms of the license agreement.
So we're good to go.
Now, before you put your newly installed PCS7 system into operation, it's crucial to perform some final checks and configurations.
Okay. Chapter 6.7, Preparing PC Stations.
This chapter is like the final inspection before a new building is occupied.
Right.
You want to make sure that everything's in working order, that all the systems are functioning correctly, and that the building is safe for occupancy.
So we're doing a final walkthrough.
Preparing your PC stations for operation involves several steps, such as creating the Logon Administrator user group. This group is used to manage user accounts and permissions, and SIMATIC Logon, the tool we discussed earlier for user management in PCS7.
Okay.
This group has full administrative privileges, allowing members to create and manage other user accounts, define roles and permissions, and perform other administrative tasks.
So it's the super user group.
And then setting the language for a user, MUI, PCS7, supports multiple languages, allowing you to customize the language of the user interface for each user. This is especially helpful in global companies where users might speak different languages.
So we can make the system multilingual.
And then setting the communication module for connecting to the terminal bus. This involves selecting the network adapter or communication module that will be used to connect the PC station to the terminal bus, which is the communication pathway to higher level systems and external networks.
So we're choosing the gateway to the outside world.
And then setting up the connection between the PC station and the plant bus. This involves configuring the network settings for the plant bus, which connects the PC station to other PCS7 components and automation systems within the plant.
So we're connecting to the internal network.
And then setting the standard network adapters. This involves configuring the settings for any standard network adapters installed in the PC station, such as the IP address, subnet mask, default gateway, and DNS server addresses.
So we're configuring the basic network settings.
And then installing security patches, hotfixes, and service packs. This ensures that your PCS7 system is up to date with the latest security patches, bug fixes, and performance enhancements.
So we're keeping the system secure and up to date.
These preparation steps are essential for ensuring that your PCS7 system is properly configured, secure, and ready to perform its intended functions reliably.
So we're making sure everything is in tip-top shape.
By carefully following these steps, you can minimize the risk of problems occurring during startup and operation, ensuring a smooth and successful PCS7 implementation.
So it's all about minimizing risk and maximizing success.
Now let's talk about one of the most important aspects of security in any computer system, especially in industrial environments, encrypted communication.
Right. Chapter 6.7.11. How to configure encrypted communication between the PC stations.
Encrypted communication is like sending a secret message in a coded language that only the intended recipient can decipher.
So we're protecting the data from prying eyes.
It protects the data being transmitted from eavesdropping, tampering, and unauthorized access.
It's like putting the data in a lockbox.
In a PCS7 system, encrypted communication is used to protect sensitive process data control signals and configuration information from being intercepted or modified by unauthorized parties.
So we're keeping the bad guys out.
It's like having a secure tunnel between your PC stations, ensuring that the data traveling through that tunnel remains confidential and protected.
A safe passage for sensitive information.
PCS7 supports various encryption methods, including pre-shared key, PSK encryption.
Oh, fair.
This method uses a shared secret key that is known to both the sender and the receiver of the data. It's a relatively simple and efficient method for encrypting communication between trusted devices.
So it's like having a secret handshake.
And then certificate-based encryption. This method uses digital certificates to verify the identities of the communicating devices and establish a secure connection. It's a more robust and secure method, especially in complex networks or when communicating with devices from different organizations.
So it's like having a digital passport.
The choice of encryption method will depend on your specific security needs and the complexity of your network.
Right. It's about choosing the right level of security.
To configure encrypted communication in PCS7, you'll need to enable the appropriate encryption settings in the system configuration tools and configure the encryption parameters, like the type of encryption, the key length, and the authentication method.
So we're setting the encryption rules.
These settings will determine the strength of the encryption and the level of security provided.
So we're making sure the data is well protected.
We'll provide step-by-step instructions for configuring encrypted communication, ensuring that your PCS7 system is protected from eavesdropping, tampering, and other security threats.
So we're providing a security checklist.
Now let's wrap up our discussion of PCS7 PC configuration by exploring some additional software tools and utilities that can enhance the functionality and manageability of your system.
Okay, Chapter 6.8, Notes on Add-ons and Utilities.
These add-ons and utilities are like optional accessories for your car. You don't necessarily need them to drive the car, but they can add extra features and convenience, making your driving experience more enjoyable and efficient.
So they're like the bells and whistles.
Some commonly used PCS7 add-ons and utilities include the Automation License Manager. We've already discussed this tool,
Right.
which is used for managing and transferring software licenses for PCS7.
It's the key master.
It helps you keep track of your licenses, add new licenses, transfer licenses between different storage locations, and generate license reports.
So it's a handy tool for license management.
And then the SIMATIC Management Console, SMC, this tool provides a central console for managing and configuring all the SIMATIC software products installed in your system, including PCS7.
Okay.
It's like the control panel for your entire SIMATIC software ecosystem,
Yeah.
giving you a single point of access for managing your software, configuring settings, monitoring system health, and performing administrative tasks.
So it's the command center for SIMATIC software.
SMC allows you to install and update software packages. You can use SMC to easily install new SIMATIC software products or update existing ones to the latest versions.
So we can keep the software up to date.
And then configure system settings. You can use SMC to configure various system settings, such as network settings, time settings, and user account settings.
So we can fine-tune the system settings.
And then monitor system health and performance. SMC provides tools for monitoring the health and performance of your SIMATIC system, allowing you to identify and resolve problems before they become critical.
So we're proactively monitoring the system health.
And then manage user accounts and permissions. SMC integrates with Windows User Management, allowing you to manage user accounts and permissions for SIMATIC products using your existing Windows user accounts and groups.
So we're leveraging existing infrastructure.
And then perform backups and restores. SMC provides tools for backing up and restoring your SIMATIC system configuration and data, helping you to protect your system and recover quickly from unexpected events.
So we're creating a safety net for the system.
And then Diagmonitor, this tool, is specifically designed for monitoring the health and performance of your PCS7 system.
Okay, Diagmonitor.
It's like having a doctor for your PCS7 system, constantly checking its vital signs and alerting you if there are any problems.
So it's the health monitor for PCS7?
Diagmonitor provides real-time information about various system components, like CPU's Diagmonitor can monitor the CPU load temperature and other parameters, alerting you if the CPU is overloaded or overheating.
So we're keeping an eye on the CPU.
And then communication modules, Diagmonitor, can monitor the status of communication modules such as network adapters and field bus modules, alerting you if there are any communication errors or failures.
So we're monitoring the communication channels.
And then hard drives Diagmonitor can monitor the health and performance of hard drives, alerting you if there are any errors or if the drive is nearing capacity.
So we're keeping an eye on the storage system.
Diagmonitor can also generate alerts and reports, helping you to identify and resolve problems quickly.
So it's a proactive tool for problem solving.
This proactive monitoring can help you prevent downtime and ensure the smooth operation of your PCS7 system.
So it's all about keeping the system running smoothly.
And finally, no discussion of system administration would be complete without mentioning the importance of security, specifically virus scanners.
Right.
Virus scanners are essential tools for protecting your computer systems from malware, viruses, and other cyber threats.
So we're talking about the first line of defense.
In industrial environments where computer systems control critical processes and infrastructure, a virus infection could have severe consequences, potentially leading to downtime, data loss, or even safety hazards.
So the stakes are high.
That's why it's crucial to install and maintain a reputable virus scanner on all your PCS7 PC stations.
Right. You need to have a good antivirus solution in place.
You should configure the virus scanner to perform regular scans of your system,
Okay.
such as daily or weekly scans, to ensure that any threats are detected and removed quickly.
So we're scanning for threats on a regular basis.
You should also keep the virus scanner up to date with the latest virus definitions.
Okay.
These definitions are like the wanted posters for viruses and malware, helping the virus scanner to identify and neutralize new threats.
So we're keeping the virus database up to date.
By taking these precautions, you can significantly reduce the risk of a virus infection and protect your PCS7 system from cyber threats.
So it's all about being proactive and staying ahead of the bad guys.
Now let's dive into the details of Chapter 1, Cybersecurity Information.
Okay.
This chapter sets the stage for cybersecurity in PCS7 systems, highlighting the importance of protecting industrial control systems from cyber attacks.
Right.
And outlining the steps you can take to secure your system.
So we're laying the foundation for a secure PCS7 system.
It's like building a fortress around your plant, with multiple layers of defenses to protect it from intruders.
A comprehensive security strategy.
Siemens has a comprehensive security concept that covers everything from the products and solutions they provide to the security practices you implement within your own organization.
So it's a holistic approach to security.
It's a shared responsibility to keep these systems safe.
Absolutely.
Siemens provides the building blocks for a secure system, but it's up to you to assemble those blocks and implement the necessary security measures within your own environment.
So it's a partnership between Siemens and the customer?
The chapter emphasizes the importance of a holistic approach to cybersecurity,
Right.
which goes beyond simply installing firewalls and antivirus software.
It's about looking at the big picture.
It involves considering all aspects of security, including physical security, network security, application security, data security, and user awareness training.
So we're covering all the bases.
It's like protecting a valuable asset.
Mm-hmm.
You need to consider all the potential threats and vulnerabilities and implement a comprehensive security strategy to mitigate those risks.
A multi-layered approach to security.
One key aspect of cybersecurity is staying up to date with product updates and security patches.
Absolutely. Those updates are crucial.
Think of it like getting regular checkups at the doctor. You might feel fine, but those checkups can detect potential problems early on, preventing them from becoming more serious issues later.
Preventive maintenance for your system.
Security patches are like those checkups for your PCS7 system. They fix vulnerabilities that could be exploited by attackers, keeping your system healthy and protected.
So we're patching up the holes in the system.
Siemens strongly recommends installing security updates as soon as they're available and using the latest product versions.
So staying up to date is key.
Using outdated or unsupported product versions is like driving a car with worn-out tires and faulty brakes. You're increasing the risk of an accident.
So we need to keep the system in good working order.
To stay informed about security updates and potential threats, Siemens provides various resources, including the Siemens Industrial Cybersecurity RSS feed.
Okay, the RSS feed.
This feed delivers the latest security advisories, vulnerability reports, and best practice guidance directly to your inbox, helping you stay ahead of the curve and keep your PCS7 system secure.
So it's a valuable resource for staying informed.
Now let's move on to Chapter 2, Industrial Security.
Okay.
This chapter dives into the specific security challenges and solutions relevant to industrial environments, where cybersecurity is not just about protecting data, but also about protecting physical processes and infrastructure.
So we're talking about the real-world consequences of cyber attacks.
It's like the difference between securing a bank vault and securing a power plant.
Right. In a bank vault, the primary concern is protecting the money and valuables stored inside.
But in a power plant, the stakes are much higher.
They are.
A cyber attack could potentially disrupt the power supply,
Right.
causing widespread blackouts and economic damage.
So it's a critical infrastructure.
Chapter 2 covers a range of topics related to industrial security, including network security.
Okay.
This involves protecting your network from unauthorized access intrusion and attacks.
So we're building a firewall around the network.
And then access control. This involves controlling who has access to the PCS7 system and what actions they're allowed to perform.
So we're managing user accounts and permissions.
And then system hardening. This involves configuring the PCS7 system and the underlying operating system to minimize security vulnerabilities and make it more difficult for attackers to exploit those vulnerabilities.
So we're making the system tougher to crack.
And then incident response. This involves having a plan in place to respond to security incidents such as detecting, containing, and eradicating malware infections or responding to suspected intrusions.
So we're preparing for the worst-case scenario.
This chapter provides valuable guidance for implementing a comprehensive industrial security strategy, ensuring the safety, reliability, and resilience of your PCS7 system.
So we're building a secure and resilient system.
And with that, we've reached the end of our deep dive into PCS7 PC configuration.
It's been a long but informative journey.
We've covered a lot of ground today, from the basic concepts of cybersecurity and hardware selection to the intricacies of operating system configuration, software installation, and network setup.
We've explored all the key aspects of PCS7 PC configuration.
I hope this deep dive has been helpful in equipping you with the knowledge and confidence to tackle your own PCS7 PC configuration projects. Welcome to our deep dive into configuring the PCS7 operator station.
Yeah, if you're ready to become like a PCS7 operator station configuration pro,
This is the place to be.
that's right.
We're going to break down like all the essentials, highlight the must-know features,
Yeah,
and help you avoid some of those common pitfalls.
absolutely. We'll be walking through those key chapters that lay the foundation for, a robust and efficient operator station.
It's like having a system that's so intuitive
Yes,
that you can monitor your entire plant at a glance,
that's it.
crystal clear visuals and like instant access to that critical data.
Exactly.
That's the power of PCS7.
Yeah.
We're going to show you how to unlock it.
And we're going to do it without, overwhelming you with technical jargon.
Right.
We'll keep it practical.
Yeah.
Step-by-step guidance.
Make it easy.
Make it feel manageable.
All right. So before we jump into the specifics,
Yeah,
let's take a tour of the chapters that we're going to be covering.
absolutely. So first up, we have Chapter 7, Configuring the OS Data in SIMATIC Manager.
All right, this is where we lay the groundwork.
Okay.
We'll be setting up the hardware, defining those communication paths, making sure your operator station is ready to talk to the rest of your automation system.
Gotcha.
Then we move into Chapter 8, Configuring the OS Data in WinCC Explorer.
Okay.
Think of WinCC Explorer as your control panel for customizing, that operator station experience.
Yeah.
So we'll be looking at personalizing the interface, setting up those handy user cycles and hotkeys, and even delve into those global design settings.
All right. And of course, we can't forget about, those process pictures.
Absolutely. Chapter 10, Creating Process Pictures Basics.
Yes.
This is where we walk you through designing those intuitive visuals,
Right.
giving you a clear overview of your plant.
Yeah.
So we'll be talking about dynamic objects, status displays, input-output fields, and those all-important group displays to keep you informed at a glance.
Yeah. Well-configured system is more than just pretty pictures, though, right?
Right. Chapter 12, Message System Settings.
We uncover the secrets to, an effective message system,
Right.
making sure you get the right alerts at the right time.
Yeah.
We'll even touch on how to use the horn effectively.
Yeah, because sometimes visual just isn't enough, right?
Sometimes you need that extra auditory.
All right, data is gold.
That's right.
Chapter 13, Configuring the Archiving, shows us how to set up archiving.
Yeah.
Ensure we're capturing and storing all that precious information.
Absolutely. We'll cover both local archiving on the OS server
Okay.
and how to leverage the power of a process historian for, that long-term data storage.
All right. And just like a well-rehearsed orchestra,
Yes.
every component needs to be in sync.
Chapter 14, Time Synchronization.
Okay.
Make sure all your components are aligned.
Working in perfect harmony.
That's it.
All right. And for that extra peace of mind.
Chapter 15, Life Beat Monitoring.
Yes.
This is where we guide you through setting that up.
Okay.
It's like having a guardian angel, watching over your system,
Keeping an eye on things.
making sure everything is running smoothly.
But what if you need to pull information from, different parts of your system?
Yeah, that's where Chapter 16, Process Pictures with Tags from Different OS Servers, comes in.
Okay.
We show you how to create, those comprehensive views that seamlessly integrate tags from multiple servers.
All right. So we're connecting everything,
That's right.
getting a full picture,
Exactly.
and finally we'll peek behind the curtain.
Chapter 17, Server Data.
Okay.
Learn how to manage, that all-important server data,
Yeah.
streamline downloads,
Yeah.
and even set up default servers for your OS clients.
Okay. You ready to roll up our sleeves and get into this first chapter?
Let's do it.
All right. Chapter 7. Configuring the OS data in SIMATIC Manager.
This is it.
This is where we build the foundation for our operator station.
Yeah.
And it all starts with getting those hardware settings just right.
Think of it like constructing the frame of a house.
Okay.
Before you can, hang drywall or paint.
Right.
You need that solid structure. In this case, our building materials are network connections and PC stations.
So let's walk through the steps to set up a PC station in the SIMATIC shell using the Configure PC Station Configuration console.
Okay.
You'll find this in the manual under section 7.1.
This is where we define those network connections for your engineering station, OS servers, and OS single stations.
Okay.
Picture number 7.1 in the manual illustrates this beautifully.
Think of it like giving each component like a unique address so they can all talk to each other.
Exactly.
Communicate effectively.
Right.
Next, we'll head over to SIMATIC Manager.
Okay.
Insert those operator stations into our project as PC stations.
Okay.
This is detailed in section 7.1.2.
Gotcha.
See picture 7.2 for a visual guide.
It's like formally introducing them to the system.
Yeah.
Hey, you're part of the team now.
All right. And to make those stations like fully functional, we'll use the HW config editor to add the WinCC application and all the necessary hardware components.
Exactly.
This step's outlined in section 7.1.3. And you can follow along with picture 7.3.
It's like furnishing our house, adding all the essential equipment to make it livable and functional.
All right, here's where it gets really interesting.
Okay.
Setting the OS properties. This is where we give our operator station a name.
Right.
Specify the path to the target computer and determine, whether it's an OS server or an OS client.
Gotcha.
It's like giving our house a street address.
Yes.
Letting everyone know where to find it.
Exactly.
You can find the details for this in section 7.1.4.
Okay.
And picture 7.4 provides a helpful visual.
And to ensure, that smooth data flow, we need to configure those communication paths.
Okay.
This is covered in section 7.2 of the manual.
Right. So we're talking about how our operator station will talk to the rest of the automation system.
Exactly.
It all starts with those network connections.
Yeah.
We'll be focusing on configuring those connections for an OS, specifically using Profibus or Profinet.
Okay.
You can see a diagram of this in picture 7.6.6.
All right. Think of these connections like the roads and highways that allow data to travel quickly and efficiently between, different parts of our system.
We'll walk through the steps to define your OS network connection.
Okay.
Making sure you select the right protocol and settings. This is covered in detail in section 7.2.1.
Right.
Picture 7.7 provides a visual guide.
And once it's all set up, we'll show you how to check and modify the configuration if needed.
Oh, okay.
Just to make sure everything is humming along perfectly.
Yeah.
This is covered in section 7.2.2.
Right.
Picture 7-8 shows you where to find these settings.
Okay, so we've got our hardware in place.
Yes.
Those communication paths established.
Now it's time to fine-tune the behavior of our operator station with some global and specific settings.
Okay.
This is covered in section 7.3 of the manual.
So it's like adding those finishing touches to our house.
Yeah.
Making sure everything's just right.
Exactly. We'll be exploring a range of settings, but let's focus on a couple of key ones. Defining the higher level designation and the OS area identifier.
Okay, now the higher level designation, or HID, helps us organize our project.
Yes.
By grouping related components together, think of it like creating folders on your computer.
Yeah.
Keep everything neat and tidy.
Exactly. We'll walk through how to define those settings for the HID.
Okay.
Make sure we have a clear and logical structure for our project.
All right.
You can find these settings in section 7.3.3.
Gotcha.
And picture 7.9 provides a visual representation.
And the OS area identifier is like giving each room in our house a specific name.
Yes.
Lets us easily identify and access different areas of our plant.
Exactly.
Section 7.3.4 provides detailed instructions for configuring this identifier.
Yeah, right.
Picture 7.10 shows you where to find these settings.
So imagine we want to access the control system for our reactor.
Oh.
We can simply navigate to the reactor area within our operator station easy, right?
Absolutely. These identifiers make navigation so much more intuitive.
Yeah.
And while we're talking about organization, let's not forget about configuring the overview area.
Absolutely. This is covered in section 7.3.8.
Okay.
This is where operators get that big picture view of the plant.
Yeah.
With quick access to key functions and areas.
Right.
Picture 7.14 shows you what this overview area looks like.
So it's like having a central control panel in our house.
Yeah.
Giving us an instant snapshot of everything that's going on.
And the beauty of the overview area is that it's fully customizable.
Okay.
So we can design button sets, add our own custom buttons.
Yeah, to access frequently used functions or areas.
Exactly. And even design faceplates for those buttons.
All right.
This is covered in sections 7.3.8.1 and 7.3.8.2.
Okay.
Check out pictures 7.15 and 7.16 to see how these customizations look.
Think of it like adding those personalized shortcuts on your, smartphone home screen.
Yeah.
You can access your most important apps and functions with a single tap.
Exactly.
I love that analogy. It really brings the concept to life. So we've covered a lot of ground in Chapter 7. Setting up our hardware, configuring communication paths, and fine-tuning those all-important settings.
But our journey isn't over yet.
That's right. In the next part of our deep dive, we'll move into the exciting world of WinCC Explorer and unlock the secrets of Chapter 8, configuring the OS data in WinCC Explorer.
We're going to transform our operator station from a basic structure into a personalized command center,
Yeah,
tailored to our specific needs and workflows.
I like it.
So stay tuned, deep divers.
Much more to come. Welcome back, deep divers.
Ready to transform that basic operator station structure into a personalized command center.
I am.
All right, we're diving into Chapter 8,
Okay.
configuring the OS data in WinCC Explorer.
Okay.
This is where you become the architect of that operator experience.
Think of WinCC Explorer as your toolbox for customizing the entire look and feel of your operator station.
Yeah, it's like choosing the paint colors, furniture, and decor
Right.
to make your house truly feel like home.
I like that.
So first, we need to familiarize ourselves with the layout.
Okay.
Menus, the editors within WinCC Explorer.
Right.
So think of it as getting to know the tools in your workshop
Yeah.
before you start building.
Okay.
So we'll be spending some quality time in the graphics designer,
Okay.
alarm logging editor, tag management, even the process historian editor.
I'm already feeling more empowered, so where do we start?
All right, so section 8.3 is all about the properties of the OS.
Okay.
Each operator station has its unique set of properties,
Yeah.
kind of like a personality
Uh-huh.
that determines how it behaves
Okay.
and interacts with the rest of the system.
Like setting the house rules,
Exactly.
establishing how things will run,
Yes,
who has access to what, making sure everything operates smoothly.
exactly. So we'll start with project properties, which
Okay.
apply to the whole OS, like setting the overall design theme or language preferences.
Okay.
Then we'll get granular with computer properties. Specifically for the operator station, you know that you've opened from SIMATIC Manager.
So it's like setting the overall vibe of the house
Yes,
and then fine-tuning each room to match the people using it.
perfect analogy.
I like it.
All right, so let's jump into section 8.3.2, setting the project properties.
Okay.
This is where you define those overarching settings that affect the entire operator station experience.
Okay.
We'll focus on 4 key areas here:
All right.
WinCC service mode, user cycles, hotkeys, and global design.
Ooh, global design sounds fun. But first, what's WinCC service mode?
So WinCC service mode controls how the WinCC runtime starts and operates.
Okay.
Think of it like choosing whether your house lights turn on automatically at sunset,
All right.
or if you prefer, that manual control.
So it's all about how WinCC starts up, automatic or manual.
Exactly. You can find the details on configuring WinCC service mode in section 8.3.2.1.
Okay.
Picture 8.1 shows you those different startup modes that you can choose from.
Got it. What about those user cycles you mentioned?
So user cycles are like the heartbeat of your operator station,
Okay.
controlling how often those background tasks happen.
Okay.
Like data acquisition and screen updates.
Right?
It's like setting your thermostat to regulate the temperature at specific intervals, ensuring a comfortable environment.
So user cycles keep everything running smoothly behind the scenes.
Exactly. You can find detailed steps on setting up user cycles in section 8.3.2.2.
Okay.
And picture 8.2 illustrates these settings visually.
What about hotkeys?
Hotkeys are your keyboard shortcuts to efficiency.
Ooh, I like that.
Think of them like a remote control for your house,
Okay.
allowing you to quickly access frequently used functions
Right.
without navigating through those menus.
So no more clicking through endless menus to find the function I need.
Exactly. Section 8.3.2.3 guides you through defining hotkeys,
All right.
mapping specific key combinations to actions like opening screens,
Okay.
acknowledging alarms, or even shutting down the system. Have a look at picture 8.3 for a visual representation of these settings.
Okay, this is getting exciting. We've got automatic startup, background tasks running smoothly, and now keyboard shortcuts.
Bring on the global design.
Yes.
This is where you unleash your inner interior designer.
Okay.
Global design is all about customizing the look and feel of your operator station.
Okay.
You can choose different design styles, adjust color palettes, customize fonts, make it visually appealing and easy on the eyes.
So we can go from a stark industrial look to something sleek and modern.
Absolutely. You'll find these settings in section 8.3.2.4.
All right.
And picture 8.4 shows you the different design styles that you can choose from.
So we set the stage with those overarching project properties.
Mm-hmm.
What about fine-tuning the individual operator station itself?
That's where computer properties come in.
Okay.
Those granular settings specific to the operator station you're working on.
Right.
Think of it like adjusting the temperature or lighting in each room of your house
Okay.
to make it comfortable for the occupants.
All right. So how do we access and modify those computer properties?
Section 8.3.7 guides you through setting those computer properties.
Okay.
We'll be working in the computer properties dialog box, a treasure trove of settings that give you granular control over how your operator station behaves. You can see this dialog box in picture 8-7.
Sounds powerful. What kind of things can we tweak in there?
Everything from the operator station's name and description to its communication settings and diagnostic options. You can define how the station handles data, how it interacts with other systems, and even how it reports on its own health. It's all about optimizing performance, making sure your operator station is running smoothly.
I'm feeling like I'm really getting under the hood here.
You are, and remember, each setting we adjust, it's like fine-tuning an instrument in an orchestra. You get them all working in harmony. You'll have a beautifully orchestrated operator experience.
Okay. We've explored the properties both at the project level and the individual station level. What's next in our WinCC Explorer adventure?
Time to meet the OS project editor. This is your command center for defining how operators interact with the plant in runtime. It's like creating a user manual for your house. Explaining how to use all the different features and controls.
So we're going beyond just the look and feel.
Yes.
And actually shaping how the operator interacts with the system.
Exactly. We'll explore the various tabs and settings within this editor, covering everything from basic data and runtime window configuration to message display and process control options. You'll find a detailed overview of the OS project editor in section 8.4. Picture 8.8 provides a clear visual of its layout and tabs.
Okay, let's break down those tabs, starting with basic data. What kind of foundational settings do we find there?
So think of the basic data tab as setting the default behavior for your house. You can define whether you want the system to restore the factory state of an object. Set the screen update cycle, and even choose the language settings for the operator station. You can access these settings in section 8.4.1. Picture 8.9 provides a helpful visual.
So basic data is about establishing those core settings that determine how the system operates out of the box. What about the runtime window tab? What kind of control does that give us?
So this tab lets you manage how many windows can be open at once, how many faceplates can be displayed on a monitor, and even the display name of your operator station in the overview area. You can find these settings in section 8.4.1.2, and picture 8.10 shows you where they are located.
So it's like deciding how many windows you want open in your house at any given time. Too many, and it gets overwhelming, right?
Exactly. It's all about creating an efficient and manageable workspace for your operators.
Okay, let's move on to the message display tab. This one sounds particularly important.
It is. This tab is all about how messages, those crucial alerts and notifications are presented to the operator. You can configure message filtering, acknowledgement options, and even define the behavior of the horn. That trusty alarm that can really get your attention when needed. You'll find detailed information on these settings in section 8.4.1.3. Picture 8.11 gives you a visual guide.
So it's like choosing the ringtone for your house alarm. You want something that's noticeable and effective, right?
Precisely. You need those alarms to cut through the noise. Alert operators to those critical situations.
And finally, let's talk about the process control tab. This one sounds like it gives us some serious control over how operators interact with the process itself.
It does. Here you can define key settings related to operator control, like the maximum number of operator input messages, the response behavior of the process control system, and whether to enable the prevent standalone operation option. This is all covered in section 8.4.1.4. And you can see these settings in picture 8.12.
So it's like setting up the security system for your house, determining who has access to what and how they can interact with the controls.
Perfect analogy. It's all about balancing control with security, ensuring operators have the tools they need while preventing those unauthorized actions.
Okay, we've walked through those main tabs in the OS project editor. Are there any specific functions within the editor that we should be aware of?
Yes. Section 8.4.2 highlights a powerful function that lets you control which process control messages and operator input messages are activated for archiving. This is all about making sure you're capturing, the most valuable data for analysis and troubleshooting.
So it's like choosing which events to record on your house security camera.
You
don't want to record everything, just those critical moments that might provide valuable information later.
Exactly. We'll walk you through how to adapt to that preset message configuration,
Okay.
activating or deactivating specific messages based on your needs. This level of control ensures you're archiving the right data without getting bogged down with, unnecessary information.
I can see how that would be really valuable for optimizing storage and analysis.
Absolutely.
So are we done with the OS project editor?
Almost. There's one more editor we need to explore within Chapter 8.
Okay.
The Process Historian editor.
Okay.
Think of it like having a massive library in your house
Right.
that stores all the historical records of your plant's performance.
Wow, a whole library dedicated to plant data.
Yeah.
That sounds impressive. What kind of things can we do with the Process Historian editor?
So we can configure data connections,
Okay.
define archiving parameters,
What?
manage storage structure,
Right.
basically control how that historical data is captured, stored, and accessed.
Okay.
This data can be invaluable for identifying trends, optimizing processes,
Yeah.
making those data-driven decisions that lead to real improvements.
This is starting to sound like a data analyst's dream.
Section 8.5 introduces this powerful tool
Right.
and outlines its capabilities.
Okay, so have we covered all the essentials of configuring the OS data in WinCC Explorer?
We have. You're now equipped with the knowledge to personalize your operator station.
Yeah.
Tailor the interface,
Uh-huh.
optimize that operator experience, but there's much more to discover.
That's right. And the next part of our deep dive, we'll move on to Chapter 9, Setting User Rights,
Right.
where we'll delve into controlling who has access to what within your operator station. It's all about security,
Yeah.
ensuring that only authorized personnel can access and modify those critical systems.
So stay tuned, deep divers.
We're about to enter the world of digital security and access control. Welcome back, deep divers. Are you ready to unlock those advanced features that can really make your PCS7 operator station shine?
Absolutely. In this final part of our deep dive, we're going beyond the basics, exploring those powerful capabilities that can elevate your operator station from just functional to exceptional.
I'm excited to see what we can accomplish.
Mm-hmm.
Where do we begin?
So we'll start with Chapter 11, Creation of Process Pictures Advanced.
Okay.
This is where we uncover, those hidden gems that let you create those highly customized and sophisticated interfaces that make PCS7 so versatile.
So we're moving from building a basic house
Yeah,
to designing a custom dream home.
exactly. And remember, we're here to guide you through every step,
Right.
making even the most complex concepts, clear and manageable.
Okay.
We'll start by exploring the dynamic duo of faceplates and block icons.
All right.
These are the elements that bring your process pictures to life,
Okay.
combining visual representation with interactive functionality.
Okay, I'm intrigued. Tell me more about these faceplates and block icons.
So think of a faceplate as the control panel for a specific piece of equipment in your plant,
Okay.
like a motor, a valve, or a controller.
Right.
It provides a detailed view of that equipment's status parameters and controls,
Uh-huh.
allowing operators to monitor and interact with it in real time. Section 11.2 provides a great overview of faceplates and block icons,
Right.
explaining how they work together to create those intuitive and informative displays.
So if the faceplate is the control panel, what's the role of the block icon?
The block icon is like the visual shortcut to that faceplate.
Okay.
It appears in your process picture,
Yeah.
giving operators a quick glimpse of the equipment status.
Right.
Clicking on the block icon opens up the corresponding faceplate,
Okay.
providing access to all those detailed controls and information.
I see. It's like a visual cue that says, hey, there's more information here if you need it.
Precisely. And just like we can customize those button sets
Yeah.
in the overview area,
Right.
we can also customize faceplates and block icons
Okay.
to match our specific needs,
Right.
adding that extra layer of personalization to our operator station.
So we can make those block icons visually distinctive, maybe using different colors or shapes to represent different types of equipment.
Absolutely. And you can customize the information that's displayed on the icon itself. Giving operators a quick overview without even having to open the faceplate, you can even add animations or dynamic behavior
Right.
to those icons, making them even more informative and engaging.
Okay, I'm starting to see how powerful these elements can be. But how do we actually configure those block icons? Where do we find those settings?
So Section 11.2.3 walks us through configuring block icons.
Okay.
We'll access the block icon configuration dialog box
All right.
and explore all those important settings that determine how the icon looks and behaves. Picture 11 to 5 shows you what this dialog box looks like.
What kind of things can we customize?
We can set the background color,
Okay.
define the text that appears on the icon, link the icon to a specific faceplate, and much more.
Okay.
It's all about making those icons visually distinctive and informative.
Yeah.
Providing operators with a clear and intuitive understanding of each equipment's status.
So it's like designing those little icons on your smartphone.
Yeah.
You want them to be recognizable and easy to understand at a glance.
Exactly. And just like smartphone icons often use those standardized designs,
Right.
PCS 7 leverages templates to streamline the creation and management of block icons. This ensures consistency and efficiency.
Yeah.
Across your entire project, Section 11.2.4 delves into the world of block icons and the matter at template APL version.pdl file.
What's special about this template file?
It acts as a central repository for block icon definitions,
Okay.
storing those standard configurations that can be applied to multiple instances throughout your project.
Gotcha.
It's like having a master blueprint for your block icons,
Right.
ensuring that they all adhere to the same design principles and functionality.
That makes a lot of sense. It would be a nightmare to have to recreate those icons from scratch every time you need one.
Exactly. Templates save you time and effort while ensuring consistency across your entire operator station.
Okay, we've got our block icons looking sharp and behaving just the way we want. What about those faceplates? How do we control how they're displayed?
So PCS 7 offers various ways to display process information. Okay. Section 11.2.5 focuses on those different representation types.
Right.
We'll explore options like full screen, loop display, and group display,
Right.
understanding the advantages and use cases for each.
Okay, let's break those down. Full screen. Sounds pretty self-explanatory.
It is the faceplate takes up the entire screen,
Right.
providing a detailed and immersive view of the selected equipment.
Got it. What about loop display?
So loop display allows you to display multiple faceplates simultaneously,
Okay.
arranged in a loop or carousel format.
Right.
It's great for monitoring, several pieces of equipment at once, kind of like flipping through channels on your TV.
I can see how that would be useful for keeping an eye on multiple processes simultaneously. And what about group display?
So group display lets you group related faceplates together,
Okay.
presenting them in a compact and organized manner.
Right.
It's like having a folder on your computer that contains all the relevant files for a particular project.
Yeah.
You can access them all from a single location.
So we've got different ways to view those faceplates, depending on our needs. But how do we actually make the connection between the block icon and the faceplate?
That's covered in Section 11.2.9, connecting block icons to faceplates.
Okay.
We'll walk through a step-by-step procedure showing you how to link those block icons to the corresponding faceplates.
Right.
Ensuring that clicking on the icon opens up, the correct control panel.
Okay.
It's like setting up a hyperlink on a web page.
Okay.
You click on the link, it takes you to the desired destination.
And PCS 7 makes this process easy with a dynamic wizard.
Exactly. The dynamic wizard guides you through the process, making it simple and intuitive to establish those connections.
Okay, we've covered a lot of ground with faceplates and block icons, but what about those crucial messages that keep operators informed about what's happening in the plan? How do we incorporate those into our process pictures?
Excellent question. Section 11.3 dives right into the world of messages.
Okay.
Specifically, how to display them effectively within your process pictures. We'll explore different options from using dedicated message lists to incorporating message displays directly into your process pictures.
So we have flexibility in how we present those messages to the operator.
Yeah.
What are some of the key considerations?
It all depends on, the type of message and the context.
Okay.
For critical alarms that require immediate attention, we might want a prominent eye-catching display,
Right.
maybe with flashing lights or a distinctive sound.
Yeah.
For less urgent messages, a simple list or log might suffice.
And PCS 7 gives us the tools to customize those displays to match our needs, right?
Absolutely. We can configure those message displays, filtering messages by type, priority, and even source, ensuring that operators are seeing the most relevant information. We'll even explore the WinCC alarm control,
Okay.
a powerful tool that provides a flexible and customizable way to display messages.
Tell me more about this alarm control. What makes it so special?
So the WinCC alarm control lets us create dynamic and interactive message displays. We can insert it into our process pictures, configure its properties to match our preferences, and even link it to specific events. It's like creating a custom notification center for our operators,
Right.
tailored to their specific needs and workflows.
I'm seeing a pattern here. PCS 7 seems to be all about customization
Yeah.
and giving us the flexibility to tailor the system to our unique requirements.
You're absolutely right. And that focus on customization extends even further with the concept of customized objects.
But-
Section 11.4 introduces us to this powerful world
Right.
where we can create complex and reusable graphical elements
Right.
that can enhance the functionality and visual appeal of our process pictures.
So faceplates and block icons are like pre-built furniture. Customized objects are like designing and building our own unique pieces.
Perfect analogy. Customized objects are like those bespoke pieces
Right.
that perfectly fit, our style and needs.
Yeah.
We can combine basic shapes, images, and even other objects to build complex and dynamic elements. And best of all, we can store those customized objects in a library,
Yep.
making them easily accessible and reusable across multiple projects.
So it's like building our own toolkit of specialized graphical elements that we can use to create truly unique and powerful process pictures.
Exactly. And to streamline the process even further, we can leverage customized object templates.
Okay.
Section 11.5 dives into this concept,
Right.
explaining how templates can save us time and effort while ensuring consistency across our entire project.
So if customized objects are like building our own furniture, templates are like having the blueprints for those pieces, right?
Exactly. A customized object template is like a master copy of our customized object,
So,
storing all its definitions and settings in a central location.
right.
We can then create instances of that template,
Okay.
placing those customized objects throughout our process pictures without having to recreate them from scratch each time.
That makes a lot of sense. It'd be incredibly inefficient to have to rebuild those complex objects every time we need them.
Exactly. Templates save us time and effort while ensuring that all our customized objects are consistent and up to date.
Okay, we've mastered the art of creating those customized objects and templates. But what if we need to display information that's not directly related to a specific piece of equipment or process variable? How do we handle that?
That's where Section 11.6 comes in. Using picture windows.
Okay.
Think of picture windows as those versatile picture frames in your house,
Right.
allowing you to display different images or documents within a larger context.
Okay.
We can embed additional information, documents, or even other process pictures within our main process pictures.
So it's like adding a little window to the outside world, bringing in external information or visuals to enhance our overall understanding of the process.
Exactly. And just like those picture frames in your house can be different sizes and shapes, we can customize the appearance and behavior of those picture windows
Okay.
to fit our specific needs.
I'm really starting to appreciate the level of detail and customization that PCS 7 offers, but with all this complexity, it seems like it could be easy to lose track of everything.
That's a valid concern, and that's where Section 11.7 comes in, working with cross-reference lists.
Okay.
These lists are like those detailed inventories you keep for your house,
Okay.
listing every item, its location, and any relevant information.
So it's like a master index for our process pictures, helping us keep track of all those objects, tags, and connections.
Precisely. Cross-reference lists are incredibly valuable for troubleshooting issues,
Yeah.
ensuring data consistency, and even tracking down missing or unused objects.
It sounds like an indispensable tool for maintaining order and sanity in complex process pictures.
Absolutely. And PCS 7 makes it easy to generate and interpret these lists,
Okay.
helping us identify potential problems,
Right.
optimize our configurations, and ensure the overall integrity of our process pictures.
Okay. We've covered a lot of ground in Chapter 11, mastering those advanced techniques for creating process pictures. Where do we head next in our configuration journey?
Let's move on to Chapter 12, Message System Settings,
Right.
where we'll fine-tune how our operator station handles those essential alerts and notifications.
Okay.
Section 12.1 provides a comprehensive overview of the message system,
Right.
explaining its purpose, functionality,
Yeah.
and the different types of messages we'll encounter.
So if Chapter 11 was about creating the visual interface, Chapter 12 is about setting up the communication channels that keep operators informed and in control.
Exactly. The message system is like the communication network within your plant,
Okay.
keeping operators informed about events,
Right.
conditions, and potential issues.
Sounds like a critical component for maintaining smooth and efficient operation.
It absolutely is. And to really understand how it works,
Yeah.
we need to explore those key components, understand how messages are generated. Processed, displayed, and archived, we'll even delve into those different message categories, from those critical alarms that demand immediate attention
Right.
to those informational messages that provide valuable insights into the process.
So it's not just about displaying messages, it's about managing the entire life cycle of those messages. from creation to archival.
Precisely, and to fine-tune how our message system operates.
Okay.
We'll dive into the OS project editor once again.
Okay, so we're back in familiar territory with the OS project editor.
Section 12.2 explores the specific settings available within this editor,
Right.
allowing us to customize the behavior of our message system.
What kind of message-related settings can we adjust?
So we'll focus on those settings related to message display and acknowledgement,
Okay.
ensuring that operators are seeing the right information at the right time
Right.
and can respond appropriately.
Okay.
We can configure message filtering, prioritization, and even control the behavior of that trusty horn. The attention-grabbing alarm that can really make a difference in critical situations.
I'm starting to see how we can really tailor the message system to match our specific needs and workflows.
Absolutely. It's all about striking that balance between providing essential information without overwhelming the operator with too many alerts,
Right.
and to make those messages even more accessible and organized.
Okay.
We'll dive into the world of message lists in section 12.4.
Message lists. Tell me more about those.
So message lists are dedicated displays that show a chronological list of active messages.
Okay.
They're like those notification centers you see on smartphones or websites,
Yeah.
keeping you informed about, recent activity. We can configure these lists,
Okay.
defining their appearance filtering options and even how they interact with other elements in our process pictures.
So it's like having a dedicated inbox for those important messages,
Yeah.
making it easy for operators to stay informed and track any outstanding issues.
Exactly. And by incorporating these lists into our process pictures,
Right.
we can provide operators with a centralized location to monitor and manage those messages.
Okay, we've covered a lot of ground with the message system, but there is one element we haven't talked about yet that always seems to grab attention, the horn.
You're right. The horn is that ultimate attention-grabbing device.
Yes.
Section 12.6 delves deep into its world,
Okay.
explaining its functionality, configuration,
Right.
and various use cases.
I'm eager to hear how we can harness the power of the horn.
We'll explore how to configure the horn, linking it to specific message types,
Okay.
defining its sound patterns, and even setting up acknowledgement options.
Right.
It's all about making the horn an effective part of our message system, ensuring that critical alerts are never missed.
So it's not just about making a loud noise, it's about using the horn strategically to convey the urgency of different situations.
Precisely. And just like we can customize those message displays,
Right.
we can also customize the horn's behavior, ensuring that it's used appropriately and effectively.
Okay, so we've got our message system humming along, alerting operators to those essential events and conditions.
Yeah.
But what if we need to temporarily silence or hide those messages, maybe to prevent operator overload or to focus attention on a specific issue?
That's a great point. And Section 12.7 addresses that very scenario.
Okay.
Locking, unlocking, or displaying hiding messages.
All right.
This section explores those techniques for managing message visibility,
Okay.
giving us control over when and how messages are presented to operators.
So it's like having a snooze button for those messages,
Yeah.
allowing us to temporarily silence those less urgent alerts while still ensuring that critical messages get through.
Exactly. We can lock or unlock messages,
Right.
preventing them from being acknowledged or cleared until specific conditions are met.
Okay.
We can even hide or show messages either manually or based on specific criteria.
Right.
It's all about giving us that fine-grained control over how messages are presented to the operator.
I can see how those techniques would be incredibly valuable for managing those high-stress situations where operators are dealing with multiple issues simultaneously. You don't want to overload them with unnecessary information.
Absolutely. It's all about providing the right information at the right time, and these techniques help us do just that.
Okay, we've mastered the art of configuring the message system, ensuring that operators are always informed and in control. Where do we go from here?
Let's shift our focus to archiving,
Okay.
that essential process of capturing and storing valuable process data. Chapter 13 dives deep into the world of archiving, covering everything from basic configuration to advanced techniques.
So we're moving from real-time monitoring and control to preserving those valuable data points for future analysis and decision-making.
Think of archiving as creating a historical record of your plant's performance,
Okay.
a treasure trove of information that can be used to optimize processes. Identify trends and make those data-driven decisions that can lead to significant improvements. Section 13.1 provides a great overview of archiving in PCS 7, explaining its purpose, functionality, and the different options available.
Okay, so we're building our own historical archive of plant data. What are the key considerations when setting up an archiving system?
We need to think about where we want to store that data,
Okay.
how long we want to keep it,
Right.
and how we're going to protect it from loss or corruption.
Okay.
PCS 7 offers two main approaches:
Right.
archiving on the operator station itself
Okay.
and archiving on a process historian.
So it's like choosing between storing those important documents in a filing cabinet in your house versus having a dedicated library that stores a vast collection of historical records.
Perfect analogy. Archiving on the operator station is like that filing cabinet.
Yeah.
It's convenient and readily accessible,
Right.
but it has limited capacity.
Okay.
Archiving on a process historian is like that dedicated library. It can store massive amounts of data and offers advanced analysis and reporting capabilities. We'll discuss the advantages and limitations of each approach,
Okay.
helping you choose the best option for your needs.
Okay. I'm starting to see the different considerations for archiving, but how do we actually configure those archives? Where do we find those settings?
Section 13.3 walks us through the specifics of configuring archives on an OS server,
Right.
providing those step-by-step instructions to get us up and running. Picture 13.1 shows you where to find those archive configuration settings.
What kind of things can we configure?
So we can create archives,
Okay.
define their properties, set up data retention policies, and even configure backup options. It's all about making sure those archives are properly configured to
Right.
capture and store the data we need.
And speaking of backups, those seem critical for protecting that valuable data. What options do we have for backing up our archives?
That's covered in Section 13.4 backup configuration.
Okay.
Think of this as creating copies of those important documents you've stored in your filing cabinet,
Right.
ensuring that you don't lose valuable information.
Okay.
We can choose from local backups,
Okay.
where the data is stored on the same server as the archive,
Right.
or network-based backups, where the data is backed up to a separate location on the network.
So it's like having a backup copy of those important files stored on an external hard drive or in the cloud.
Exactly. And just like those backup systems can be configured to run automatically,
Right.
we can set up backup schedules for our archives,
Yeah.
ensuring that our data is regularly backed up and protected.
Okay, so we've got our archives configured and our backups in place. Is there anything else we need to know about managing this archival process?
So PCS 7 provides a handy tool called the tag logging editor to simplify the process.
Okay.
Section 13.5 walks us through using this editor,
All right.
explaining how to configure archives,
Uh-huh.
define tag logging parameters, and manage the overall archiving process. Picture 13.4 provides a clear visual of the tag logging editor.
So it's like having a centralized control panel for all things archiving.
Exactly. The tag logging editor streamlines those archive management tasks,
Right.
providing a single location to configure settings, monitor status, and make adjustments as needed.
This is starting to sound like a data historian's dream come true.
It is. And if you're working with a process historian,
Yeah.
that powerful external archiving system,
Right.
Section 13.10, will guide you through integrating it with your operator station.
So we can connect our operator station to that dedicated data library, leveraging its advanced capabilities for storing and analyzing those massive data sets.
Precisely, we'll explore the steps involved in setting up those data connections, defining archiving parameters, and managing the overall interaction between your operator station and the process historian.
Okay, so we've archived all this valuable data,
Mm-hmm.
but how do we actually access and analyze it? What tools does PCS 7 provide for turning that raw data into actionable insights?
That's where Section 13.11 comes in, use of the report designer. Think of the report designer as a powerful tool that lets you create those customized reports, extracting valuable insights from your archived data.
Right.
You can define report layouts, select data sources, add calculations, and even customize the appearance to create professional-looking reports.
So it's like having a built-in data analysis team ready to generate those insightful reports that can drive informed decision-making.
Exactly. And in addition to the report designer, PCS 7 offers the online trend control, another powerful tool for visualizing and analyzing data. Section 13.13 dives into the world of this dynamic trend display,
Right.
explaining how to create interactive trend charts.
Trend charts, tell me more about those.
Think of the online trend control as a live interactive graph
Okay.
that shows you how process variables have changed over time.
Right.
We can connect it to tags, define the time range to display and customize the appearance to create those insightful visualizations that reveal trends, patterns, and potential anomalies within our process data.
So it's like having a time machine for our data, allowing us to rewind and see how those process variables have behaved over time.
Precisely. And for those situations where we want to focus on specific functions or calculations.
Yep.
PCS 7 offers the Function Trend Control Section 13.14, explores this specialized trend display.
So if the online trend control is like a general-purpose time machine, the function trend control is like a specialized one that focuses on those key performance indicators that we want to track closely.
Exactly. And just like the online trend control, we can configure the function trend control to display trends over a specific time range, customize its appearance, and connect it to those specific tags or calculations that we're interested in monitoring.
Okay, we've covered a lot of ground with archiving, reporting, and trend analysis.
Yeah.
What's next on our agenda?
Let's move on to Chapter 14, Time Synchronization.
Okay.
Think of time synchronization as making sure all the clocks in your house are set to the same time.
Right.
Ensuring consistency and accuracy across all your devices in the world of automation, this is critical for ensuring that all components are working in harmony.
So no more disagreements about what time it really is. Everyone's on the same page.
Exactly. And in PCS 7, there are two primary ways to achieve this.
Okay.
Synchronization via the system bus
Right.
and synchronization via a domain controller.
Okay, let's break those down. What's the difference between those two approaches?
So synchronization via the system bus uses dedicated communication protocols to keep all the devices on that system bus synchronized, like a group of friends coordinating their watches before a race.
Yep.
Synchronization via a domain controller is like having a central timekeeper, a master clock that everyone refers to.
Right. Section 14.1 provides a great overview of time synchronization in PCS 7, explaining its importance and the different approaches available.
Exactly.
So we've got those two main options. How do we actually go about configuring time synchronization in PCS 7?
So if you're using the system bus approach,
Okay.
Section 14.1.2 guides you through setting up time synchronization using either a communications processor or a network adapter.
So we can choose the method that best fits our system architecture.
Exactly. And if you're working within a domain,
Okay.
Section 14.1.4 provides detailed instructions for setting up time synchronization via a domain controller.
All right.
You'll learn how to connect to the domain controller, configure the necessary settings, and ensure that your operator station and all associated components are receiving those accurate time updates.
It sounds like PCS 7 gives us the flexibility to choose the synchronization method that best fits our needs and ensures that everything is running in sync.
Exactly. And once we've got our time synchronization sorted out, we can move on to Chapter 15, Life Beat Monitoring.
Okay.
This is like having a doctor constantly checking the pulse of your system, making sure everything is functioning properly.
So it's like a continuous health check for our operator station and automation systems.
Precisely. Section 15.1 introduces the concept of life beat monitoring,
All right.
explaining its purpose, functionality, and the benefits it offers. We'll explore how it uses those periodic signals to verify that devices are responding and functioning as expected.
So it's like those regular checkups we have with our doctor, ensuring that everything is running smoothly and catching any potential issues early on.
Exactly. And just like a doctor might use different tools and techniques to assess our health,
Right.
life beat monitoring uses different methods to check the status of our system components.
And if it detects a problem, it alerts us so we can take action.
Exactly. We'll even discuss how life beat monitoring is displayed in process mode,
Okay.
providing those visual cues that alert operators to any potential issues,
Right.
and offering valuable diagnostic information.
So it's like having a built-in early warning system for our operator station that sounds incredibly valuable for preventing downtime and ensuring smooth operation.
Absolutely. And to set up this life beat monitoring, we'll dive into the configuration process in Section 15.2. You'll learn how to define those monitoring cycles, configure those alert thresholds, and set up those notification options to make sure we're staying informed and in control.
Okay, so we've got our time synchronization in place and our life beat monitoring system keeping a watchful eye on our system's health. What's next on our agenda?
So let's talk about those larger, more complex systems that utilize multiple operator stations.
Right.
Chapter 16 explores how to work with process pictures with tags from different OS servers.
All right.
It's like connecting the electrical systems of multiple houses together,
Okay.
ensuring that they can share power and information seamlessly.
So if one operator station goes down, the others can still access and control those critical processes.
Exactly. Section 16.1 introduces the concept of interconnecting tags from different OS servers,
Okay.
explaining why it's necessary and the challenges involved.
Challenges? Tell me more about those.
So when you're dealing with multiple servers,
Yeah?
you need to make sure that they can all communicate effectively. and that the data is consistent across all systems. It's like making sure that all the clocks in those interconnected houses are synchronized and showing the same time.
It makes a lot of sense.
Yeah.
So how do we go about interconnecting those tags from different servers?
So PCS 7 offers various approaches for interconnecting tags, each with its own, pros and cons.
Right.
We'll explore those different approaches.
Right.
Helping you choose the best one for your specific system architecture and to illustrate how it all works in practice.
Sure.
Section 16.2 provides a step-by-step example configuration for tag connections.
So we can see a real-world example of how to set up those connections and ensure that data is flowing smoothly between those different operator stations.
Exactly. You'll learn how to configure those necessary settings, connect those tags from different servers, and ensure that those tags are accessible from any operator station within your system.
It sounds like PCS 7 makes it surprisingly straightforward to manage those complex multi-server environments.
It does. And once we've got those inter-server connections established, we can move on to our final chapter, Chapter 17, Server Data. This is all about making sure your operator station is always up to date and running smoothly.
So we're talking about those software updates and data synchronization tasks that keep everything running at peak performance.
Exactly. Section 17.1 focuses on downloading server data, which is like getting those software updates for your computer or smartphone. These updates provide new features, bug fixes, and performance improvements, keeping your system running at its best.
So it's essential to keep our operator station updated with the latest and greatest software.
Absolutely. And to make sure everything is connected properly, we'll dive into Section 17.2, which covers determining the default servers for OS clients.
So we're making sure that those client workstations are connecting to the correct servers for different functions like alarm management, user archives, and screen compositions.
Exactly. It's like making sure that each house in our interconnected neighborhood is wired to the correct utilities for water, electricity, and gas.
I like it.
We'll walk you through the process of assigning those default servers, ensuring that your client workstations are properly configured to access the necessary resources.
And with that, we've reached the end of our PCS 7 operator station configuration deep dive.
It's been quite a journey.
It has. We've covered a lot of ground, from those foundational hardware settings to those advanced techniques for customizing the operator experience.
We've explored all 17 chapters of the configuration manual.
We have.
Uncovering those hidden gems and practical tips that can transform.
All right, ready to dive into WinCC v8.0. We've got a whole stack of docs here, installation notes, release notes, and guides for connectivity pack, data monitor, web navigator, you name it, even web UX. So
it sounds like a lot to cover.
It is, but hey, that's what these deep dives are for, right? To give everyone a solid understanding of how to install, configure, and really get the most out of WinCC v8.0.
So it's like a training session then?
Yeah, exactly. Like, think of it as a workshop where we equip you with the tools and knowledge to tackle WinCC v8.0 head on.
I like that. Hands-on learning.
Exactly. It's not just about clicking through menus. It's about understanding the system, making informed choices during installation and configuration.
And that's where the real value lies, right? Knowing not just what to do, but why you're doing it.
Absolutely. So we're going to go deep, exploring those nuances and best practices that can mean the difference between a smooth WinCC implementation and a frustrating one.
Smooth implementation. I'm all for that.
Me too. No one wants to be stuck troubleshooting for hours on end. So to make sure that doesn't happen, let's jump right in. First up, Chapter 1, WinCC installation notes. It's the foundation we're going to build on.
Like a blueprint for a successful project, huh?
Exactly. And just like with any good blueprint, we need to start with the right prep work. So before we even think about installing WinCC v8.0, what are the absolute must-have prerequisites?
Okay, first things first, administrator rights. It's one of those things that people often assume they have, but in industrial settings especially, IT policies can be pretty strict, so double check those administrator privileges before you even start. Otherwise, you might hit a wall right out of the gate.
Yeah, the classic, do I really have admin rights?
Yeah.
Always good to be sure.
Absolutely. And another thing that can cause unexpected issues, your computer name. Watch out for special characters.
Special characters in the computer name.
Seriously. They can sometimes interfere with the installation process. Stick with simple alphanumeric names to be safe.
No funky symbols allowed.
Yeah.
Got it.
Right. And one more thing. Windows security policies, you'll need to tweak those a bit to allow the installation of unsigned drivers and files.
Unsigned drivers. That always raises a bit of a red flag for me. Security-wise, why do we need to allow those?
Good question. It's a trade-off between security and the flexibility that WinCC needs to talk to all sorts of specialized industrial hardware.
Makes sense.
Yeah.
Not all drivers go through those formal signing processes.
Exactly. So a bit of flexibility is needed there.
Okay, so we've triple-checked our admin rights, sanitized our computer name, and adjusted those security policies. Ready to move on to the actual installation.
Let's do it. Pop in that WinCC DVD or run the setup executable if you downloaded it. You'll be guided by a setup wizard, pretty straightforward. Choose your languages, pick the installation type, and select the components you need.
Sounds easy enough.
Yeah.
What if we need to add a component later on, though? Like, say, the connectivity pack wasn't part of our initial install. Are we out of luck?
Not at all. WinCC is flexible that way. You can add those supplementary components like connectivity pack, data monitor, even web navigator, anytime after the initial installation.
Frio, that's a relief. Flexibility is key.
It is. But even the smoothest installations can hit a snag now and then, right?
True enough. What are some common installation issues people might bump into? And more importantly, how do we fix them?
Well, we already talked about one, those pesky administrator rights. Always double check those. Another common one is an active uninstall shield process.
Yes, those can be tricky.
Make sure to close that before starting your WinCC installation. And sometimes the Microsoft message queuing services might be missing. You'll need to install those from your Windows media. Oh, and don't forget about your monitor resolution. Make sure it meets the minimum requirements.
Okay, let's recap. Check those admin rights. Close any rogue uninstall shield processes, ensure message queuing is good to go, and verify our monitor resolution. Got it. We've conquered Chapter 1, the WinCC installation notes. Now on to Chapter 2, the WinCC release notes, where we gather those essential operational insights.
Shifting from construction to operation, huh?
You got it. We've built our system. Now we need to keep it running smoothly and securely. What's the first gem of wisdom we encounter in these release notes?
Security. It's always a top priority. The release notes emphasize disabling the plug-and-play services.
Plug and play. But isn't that supposed to make things easier?
It is, but in an industrial environment, sometimes security trumps convenience. Disabling plug-and-play adds a layer of protection, preventing unauthorized devices from automatically connecting and potentially causing trouble.
So it's a conscious choice prioritizing security.
Exactly. And speaking of security, defining appropriate access rights in the operating system is critical. Create user accounts with specific roles and permissions, limiting access to only what's absolutely necessary. The principle of least privilege.
Right. Only give access to what's needed. It's a fundamental security principle, applies to both IT and OT systems.
Absolutely. And remember, permissions aren't just about who can access what, but also what actions they can perform. Can they modify configurations? Start or stop processes. These are all things to consider when defining user roles.
It's all about layers of defense, minimizing the risk of unauthorized changes, whether intentional or accidental.
Exactly. And don't underestimate the importance of documentation. Clearly document your user accounts, roles, permissions. It's crucial for accountability and troubleshooting.
Documentation, the unsung hero of security. Okay, security is top of mind. What other operational pearls of wisdom do we find in these release notes?
Resource management. It's key to a stable and responsive WinCC system. The release notes caution against running resource-intensive applications concurrently with WinCC.
So no marathon gaming sessions while your critical processes are running on WinCC.
Right. Resource contention can lead to all sorts of issues, slow response times, system instability, you name it. Make sure WinCC has the resources it needs and avoid overloading the system with other demanding applications.
Prioritize those critical processes. Any other resource management tips?
They suggest disabling screensavers. They might seem harmless, but they can actually consume processor cycles and memory that WinCC could be using.
Sneaky screensavers, always lurking in the background, stealing resources. Anything else we should be mindful of?
Yes. Be careful with network drives and connections. While they can be convenient, they can also introduce delays and potential points of failure.
So if speed and reliability are paramount, stick with local storage.
Exactly. Choose the right storage solution based on your specific needs.
All right, we've covered security and resource management. What else does Chapter 2 illuminate?
Licensing. It might not be the most exciting topic, but understanding the different WinCC license models is essential. RT basic licenses, server licenses, client licenses, each one tailored to specific scenarios.
Licensing the fine print of the software world. Why is it so important to get this right?
Imagine you've got your WinCC system all set up, everything's working perfectly, and then boom, you need to add another client, but your current license doesn't allow it. Suddenly, you're stuck, potentially facing downtime or scrambling to reconfigure.
Ouch. That's a scenario we want to avoid at all costs.
Absolutely. Careful planning and choosing the right licensing model up front can save a lot of headaches later on.
So no skimping on the licensing homework. Great advice.
And remember, if you have any doubts, reach out to Siemens or a qualified distributor. They can help you determine the best licensing model for your specific needs.
Expert advice is always a good investment. So Chapter 2, the WinCC release notes, has given us some valuable insights into security, resource optimization, and the importance of understanding those licensing models.
Laying the groundwork for a smooth-running WinCC system.
Exactly. Now on to Chapter 3, WinCC Connectivity Pack Installation Notes. This is where we learn to connect WinCC to the outside world, right? Like PLCs and other automation equipment.
You got it. Connectivity Pack is the bridge between your WinCC system and a whole universe of industrial automation devices. It's like a universal translator, enabling communication between all sorts of different protocols and systems.
So not just connecting to a single type of PLC, but creating a network of communication that spans all sorts of devices.
Exactly. Profibus, Profinet, Modbus, OPC, you name it, Connectivity Pack supports a wide range of communication standards.
It's like the United Nations of industrial protocols, bringing everyone together. So how do we go about installing this communication powerhouse?
First, we set up the Connectivity Pack server. You'll find the installation package on your WinCC DVD or in your downloaded files. Just select the right one and follow the on-screen instructions.
Okay, pretty standard so far. What about on the client side? Do we need to install something separate on every machine that needs to talk to the server?
Here's a time saver. If WinCC v8.0 is already installed on a client machine, you don't need a separate installation for the Connectivity Pack client. It's already included.
Oh, that's handy. One less installation to worry about. So we've got the server set up, clients are ready to connect. What else do we need to consider?
Two key things: licensing and user access. You'll need a valid Connectivity Pack license, of course, and make sure all your users are part of the SIMATIC HMI Windows user group. That grants them the necessary permissions to use Connectivity Pack.
Got it. Valid license, proper user group, always important. We've laid the groundwork for communication between WinCC and our automation devices. On to Chapter 4, WinCC Connectivity Pack Release Notes, where we delve into those little details and potential gotchas.
Think of it as the fine print of the Connectivity Pack user manual.
I'm ready for the fine print. What jumps out at you in these release notes?
There's a limitation with the WinCC OLEDB provider that's worth noting. As of WinCC v7.2, the import function via the WinCC OLEDB provider doesn't work in MS Office Excel.
Interesting. So if we're trying to import data from Excel into WinCC using the OLED provider, we're out of luck.
Right. That functionality is no longer supported. It's good to be aware of that if you're working with Excel data.
So what are our options if we absolutely need to get data from Excel into WinCC? What are the alternatives?
The release notes recommend a few different data exchange methods. If you're using .NET-based applications, ADO.NET is a great choice.
ADO.NET for .NET applications.
Okay.
Okay. What if we're dealing with C++ applications? Any suggestions there?
Yeah, for C++ ACK, you can use OLEDB or ODBC. They're good options for connecting to databases, including data in Excel files.
But even though the WinCC OLEDB provider has this Excel quirk, we've got some workaround.
Always good to have a plan B, right?
Exactly. Okay, Chapter 4, the WinCC Connectivity Pack Release Notes, has given us a heads up about that Excel import issue and pointed us towards those alternative data exchange methods.
Another chapter down, and our knowledge of Connectivity Pack is growing.
Now into Chapter 5, WinCC Data Monitor Installation Notes. Data Monitor, that's all about harnessing the power of data, right?
Yeah.
Collecting, visualizing, and analyzing process information.
You got it. Data Monitor is like a powerful lens that allows you to zoom in on your process data, uncover patterns, and gain insights that you might not see just by looking at raw data.
Turning raw data into actionable intelligence. I like it. Where do we even begin with Data Monitor? What's the first thing to understand?
The architecture. Data Monitor is made up of two main components: the Data Monitor server and the Data Monitor client. The server is responsible for data acquisition and storage, acting like a central hub for all your process information. The client, on the other hand, provides the tools for accessing and analyzing that data.
So it's a server-client setup, like we saw with Connectivity Pack. The server gathers and stores the data, and the client lets users interact with it.
Exactly. And that means it's designed for flexibility and scalability. You can have multiple clients connected to a single server, so engineers and operators in different locations can access and analyze the same process data.
It's like having a window into the heart of your process no matter where you are. But I'm guessing data monitor can be a bit resource hungry, especially if you're dealing with a lot of data. What are the hardware and software requirements?
You're right. Data monitor can be demanding, especially if you're collecting data from multiple sources or storing large amounts of historical data. The chapter goes into detail about hardware and software specs for both the server and client.
So we need to choose our hardware carefully, making sure it can handle the load. What are some of the key factors that influence those choices?
Well, the number of clients you expect to have is a big one. More clients mean more processing power and memory needed on the server. The amount of data you anticipate collecting and archiving also plays a role. If you're collecting data at high frequencies or storing long-term historical data, you'll need ample storage capacity and processing power.
So it's a balancing act between functionality, performance, and cost.
Exactly. And don't forget about future growth. Build in some headroom so your data monitor system can handle increasing demands as your needs change.
Future-proofing, always a good idea. Okay, so we've assessed our needs, chosen our hardware. Now it's time for the installation. Is it as straightforward as the previous components?
The process is similar. You'll install the data monitor server. First, remember, you'll need those administrator privileges for this one. Then you'll install the data monitor client on each machine that needs to access and analyze the data.
Okay, so administrator rights for the server install, client installations on the analysis machines. We're getting pretty good at these installations.
Practice makes perfect, right?
Absolutely. Now on to Chapter 6, WinCC Data Monitor Release Notes. Time to uncover those operational nuances and potential issues.
Think of it as the heads-up section.
Okay, give me the heads up. What's the first thing that grabs your attention in these release notes?
Security, once again, takes center stage. The release notes strongly recommend configuring the data monitor server to use only HTTPS connections.
HTTPS, the Secure Communication Protocol. But why the emphasis on HTTPS for data monitor specifically?
Remember, data monitor is handling sensitive process data. HTTPS encrypts the communication, making it much harder for unauthorized people to intercept or tamper with that data as it travels across the network.
So it's not just about protecting data at rest, it's also about protecting it in transit.
Exactly. It's like creating a secure tunnel for your data. And the release notes even suggest using SSL certificates on the data monitor clients for an extra layer of security.
SSL certificates on the clients too, double the protection.
Right. Siemens takes data security very seriously, and for good reason. As industrial systems become more interconnected, security becomes even more critical.
It's not just about external threats, it's also about controlling access within your own organization, making sure only authorized people have access to sensitive process information.
Exactly. HTTPS and SSL certificates are key tools for achieving that level of security.
Okay, HTTPS for data monitor check. What other operational considerations should we be aware of?
The release notes caution against running SQL queries that return massive amounts of data.
SQL queries, those are the commands we use to retrieve data from the data monitor database, right?
Yeah.
Why should we be careful with them?
Think of it this way. If you run a query that pulls millions of data points from the archive, that's a huge amount of information for the server to process.
Right, it's like drinking from a fire hose.
Yeah.
Too much data all at once.
Exactly. It can lead to slow response times, system instability, even data loss in extreme cases. Be mindful of the queries you're running, make sure they're optimized for performance.
Keep those queries lean and mean. Any other tips?
Time synchronization. It's a small detail, but it's important, especially when you're working with archive data.
Time synchronization. Why does that matter so much?
Let's say you're analyzing historical data, trying to pinpoint exactly when a particular event happened, but the clocks on your data monitor server and client machines are out of sync. Suddenly, your timestamps are unreliable, making it difficult to accurately reconstruct the sequence of events.
Ah, that makes sense. Time synchronization is crucial for maintaining data integrity and ensuring accurate analysis, especially when working with historical data.
Exactly. The release notes recommend ensuring that the local times on your beta monitor server and client machines are synchronized using a reliable time source like a network time server.
So HTTPS for secure communication, careful querying to avoid overload, and synchronized clocks for data integrity. We're covering all the bases for running data monitor effectively.
We're on the right track.
Now let's move on to Chapter 7, WinCC Web Navigator installation notes. Web Navigator, that's all about remote control, right? Accessing our WinCC system from anywhere with an internet connection.
That's right. It's like having a virtual control room at your fingertips. You can monitor and interact with your WinCC system from virtually any device with a web browser, whether you're at your desk, on the factory floor, or even on the other side of the world.
Remote access definitely changes the game in industrial automation. But before we get too carried away, let's talk about the technical side. How does Web Navigator work? What's the architecture like?
It's similar to Data Monitor, a server-client architecture. You have the Web Navigator server, which runs on your WinCC system, and the Web Navigator client, which runs on the remote machine that's trying to connect.
So, install the server on the WinCC system, and anyone who needs remote access installs the client software on their machine. Simple enough.
Exactly. And here's the good news about licensing. The Web Navigator client itself doesn't require a license. You only need licenses for the server, and those determine how many clients can connect concurrently.
Oh, that simplifies things. No need to track individual client licenses. Any other prerequisites we need to be aware of before we can enjoy the benefits of remote access?
Of course, hardware and software compatibility are essential. The chapter lays out the specific requirements for both the server and client. On the client side, you'll need a compatible web browser that supports HTML5. The release notes emphasize the importance of having the latest cumulative security updates for Internet Explorer.
Okay, check those requirements, keep your browser up to date, and we should be good to go. We're ready to control our WinCC system from afar.
Hold on just a second. Before we dive into remote access, let's take a quick look at Chapter 8, the WinCC Web Navigator release notes.
Ah, yes, the fine print. Always a good idea to check that. What are some of the key things to watch out for?
You guessed it, HTTPS makes another appearance. The release notes emphasize the importance of using HTTPS for secure communication, recommending digital certificates for both the server and client.
HTTPS. It's the security mantra of our WinCC journey. And for good reason, especially with remote access. We don't want anyone snooping on our data or, even worse, taking control of our system.
Exactly. HTTPS is a must-have.
What other nuggets of wisdom can we extract from these release notes?
Troubleshooting tips are always helpful. The chapter addresses some common issues users might encounter with the Web Navigator client, offering advice on how to resolve them. You might have problems displaying process pictures in WinCC VRT on Windows Server operating systems, or you might run into issues with ActiveX controls.
ActiveX controls, those can be a bit tricky sometimes.
They can be. But the release notes provide guidance on configuring them correctly in the Web Navigator environment. It might involve tweaking security settings in the browser or installing specific ActiveX components on the client machine.
So careful configuration and attention to detail are key when working with ActiveX controls.
Absolutely. And if you do get stuck, the Siemens support website and forums are great resources. You can find solutions and connect with other users who might have faced similar issues.
Okay, we've got security, troubleshooting, and ActiveX controls covered. Anything else that stands out from this chapter?
Yes. The release notes have a section explaining how certain ODK functions might work differently or might not be available in the Web Navigator client compared to the standard WinCC runtime. Specifically, functions related to the split-screen manager.
So there are some functional differences between the standard runtime and the web client, particularly with those advanced ODK features.
Right. It's mainly because they're operating in different environments. The standard WinCC runtime has full access to the system resources, while the Web Navigator client runs within the limitations of a web browser.
So it's important to be aware of those differences, especially when working with ODK. We might need to adjust our approach when operating within the Web Navigator environment.
It's all part of understanding the nuances of Web Navigator and how it interacts with the broader WinCC ecosystem.
All right, Chapter 8, the WinCC Web Navigator release notes, has given us some valuable insights into security, troubleshooting, and those functional differences with ODK in the web client environment. We're well equipped to start exploring the world of remote access.
It's time to take control from anywhere.
And that brings us to Chapter 9, WinCC Web UX. Sounds like a modern take on the classic WinCC interface.
You're right on the mark. Web UX is all about bringing the power and flexibility of web technologies to the WinCC world, creating a more modern, intuitive, and accessible user experience.
Modern and intuitive. I like the sound of that. But before we get carried away, let's talk about the practical aspects. Where do we start with Web UX? What are the initial things to consider?
Licensing is always a good starting point. And here's the good news. The basic WebUX package, which includes the WinCC WebUX Monitor license, is already included in your WinCC installation. You don't need to buy anything extra to get started with the basic functionality.
Fantastic. We can start exploring WebUX without any licensing hurdles. But I'm guessing there are different levels of functionality within WebUX, right? Different user roles, access levels, and how do licenses play into that?
You're absolutely right. There are different roles and access levels, and those are governed by licenses. You have the monitor role, which lets users view data and screens, but they can't make any changes. Then there's the operate role, which gives additional permissions to control and modify the process. And finally, we have the web navigator role, which, as we've already discussed, enables remote access.
So it's a tiered system tailored to different user needs. The basic monitor functionality is included out of the box, but if we need more advanced capabilities like control access or remote access, we'll need additional licenses.
Exactly. It's a flexible system, so you can customize the user experience and access levels to fit your specific requirements and security policies.
Okay, licensing is clear. What about system requirements for WebUX? Anything out of the ordinary?
The chapter outlines the hardware and software specs for WebUX. Compatibility with different Windows operating systems is important, and like with Web Navigator, you need a web browser that supports HTML5. The release notes actually highlight the Chrome browser as being optimal for a WebUX display.
Chrome it is then. Any other important points to keep in mind when setting up WebUX?
You know what's coming. HTTPS is back. WebUX only supports HTTPS connections, so all communication between the client and server is encrypted and secure.
HTTPS, our trusty security companion. But seriously, security is paramount, especially with web-based technologies.
Absolutely. And WebUX takes it seriously. It enforces HTTPS and provides robust mechanisms for user management and access control.
So how do we manage users and permissions in WebUX?
It's all handled through the User Administrator tool, which we've already touched on. You can define user roles, assign licenses, and configure access levels. You can grant or deny access to specific screens, functions, even individual tags.
Wow, that's granular control, making sure that each user has access to exactly what they need and nothing more.
Exactly. It's all about creating a secure and controlled environment for your process, data, and operations.
Okay, Chapter 9 has given us a great overview of WebUX, its licensing, system requirements, the emphasis on HTTPS, and those powerful user management features.
We're getting a good grasp of this modern and flexible addition to the WinCC world.
Now, on to our final chapter for this deep dive, Chapter 10, Service and Support. This is where we find the lifeline for WinCC users, right?
Precisely. Every system, no matter how well designed, can run into issues. Chapter 10 points us to the resources we need to get things back on track.
So if we hit a snag, where do we turn first?
The chapter outlines several support channels. There are the SIMATIC hotlines, you can call them directly, or submit a support request through the Siemens website. And for faster, more personalized support, there's the Siemens Industry Service Card.
Phone support, online support, a dedicated service card for premium support. It seems like Siemens has a range of options to choose from.
They do. And don't forget about the wealth of self-help resources available online. Siemens has a fantastic support portal called cPortal.
cPortal. Tell me more about that.
It's a treasure trove of information. FAQs, application examples, firmware updates, service packs, technical documentation, it's all there.
Sounds like a must bookmark for any WinCC user.
It is. But sometimes those self-help resources aren't enough. If you encounter a tricky issue that you can't solve on your own, you'll need to submit a formal support request.
Okay, what's the process for that?
It's all laid out in the chapter. You go to the support request form on cPortal, fill in all the necessary details, and submit it. Be as specific as possible about the problem you're having. Include any error messages, log files, or screenshots that might be helpful.
So the more information you provide, the better.
Exactly. The support team can diagnose the issue and find a solution much more efficiently if they have all the details.
Okay, clear and detailed support requests are key. Any other tips for a smooth support experience?
Yes. Gather as much diagnostic information as you can beforehand. Things like log files, screenshots, or even using the SIMATIC Assessment Suite data collector.
Welcome back. We've covered a lot of ground, installations, operations, those are all important. But now it's time to really get our hands dirty, dive into the actual configuration of WinCC v8.0.
Time to put all that knowledge into practice.
Exactly. So what's the first thing we tackle in this configuration adventure?
Tags. They're the heart and soul of any SCADA system.
Okay, tags, those digital representations of all our real-world variables. But where do we actually create those tags in WinCC?
The tag management editor in WinCC Explorer, that's your go-to place. You create, modify, organize, manage. It all happens there. Think of it as your tag headquarters.
Tag management, got it.
Yeah.
So we opened up this editor. We're ready to create a new tag. What's the process like?
It's pretty straightforward. Right-click in the tag management window, select New Tag, and you'll see a dialog box where you define all the tag's properties, name, data type, address, and which communication channel it'll use to talk to the PLC or other devices.
So it's like filling out a form, a digital birth certificate for our tag.
Exactly. Let's walk through an example. Suppose we want to keep an eye on the temperature of a reactor vessel. How would we create a tag for that?
Reactor temperature, that sounds like a pretty important variable to monitor. What would be a good name for this tag?
We want names that are clear, concise, easy to understand. So something like reactor temperature would work well. It's descriptive, tells you right away what the tag represents.
Reactor temperature makes sense. What about the data type? What kind of information will this tag be holding?
Well, temperature is typically a floating point number, right? Allows for decimals, gives us more precision. So we'd select floating point number 32-bit IEE 754.
Floating point. Okay, now for the address. This is where it gets a bit more technical, right? How do we specify where that temperature sensor actually lives in our automation system?
It depends on how your PLC is configured and where the sensor is connected. But let's say it's wired to an input module in the PLC, and its data is stored in data block DB100, word 2. So our tag address would be db100.dw2.
db100.dw2. Okay, that's very specific, like the tag's GPS coordinates within the PLC.
Exactly. And finally, the connection. This links the tag to the communication channel that'll carry its data between WinCC and the PLC. If we're using Profinet, we select the appropriate Profinet connection from the list.
Profinet connection, check. So we've given our reactor temperature tag a name, a type, an address in the PLC, and connected it to the communication channel. Anything else?
We could add some optional stuff like a description to provide more context, units of measurement, or even alarm limits if we want WinCC to alert us if the temperature goes out of bounds. But for now, let's keep it simple and save our tag.
Sounds good. Tag created, configured, and saved. One down, potentially hundreds more to go. Any tips on how to keep things organized when you're dealing with a lot of tags?
Organization is key, especially in large projects. WinCC lets you create folders within the tag management editor to group related tags together, just like you use folders on your computer to organize files.
So instead of one giant list of tags, we can create a nice hierarchy, separate folders for different areas of the plant, different types of equipment, that sort of thing.
Exactly. And it's also helpful to establish consistent tag naming conventions. Use prefixes to indicate data types or locations makes things much easier to read and understand. So, for example, all your temperature tags could start with temp, level tags with level, and so on.
Tag taxonomy. It's all about making our lives easier down the road, especially when it comes to troubleshooting or modifying the system. Okay, tags are under control, created, configured, organized, following naming conventions. What's next on our configuration to-do list?
Communication channels. Remember how we specified the Profinet connection when we created that reactor temperature tag? Now it's time to actually set up that channel, establish that virtual pathway for data to flow between WinCC and the PLC.
Right, the Profinet connection was like a placeholder, and now we need to make it real. Where do we go to configure these channels?
The channel configuration editor, also in WinCC Explorer, it's your communication central where you set up connections to all those external devices.
Channel configuration, okay. So we're in the editor, ready to set up our Profinet channel. What are the steps?
First, we need to add the right driver. Select Add New Driver and choose SIMATIC S7 Protocol Suite from the list. This driver is like a language interpreter, allowing WinCC to communicate with a wide range of Siemens PLCs, including those using Profinet.
SIMATIC S7 Protocol Suite, it sounds like it covers a lot of ground.
It does. Once the driver is added, we create a new connection. Right-click on the driver, select New Connection, and a dialog box will pop up where we configure all the specifics of our Profinet connection.
New connection, dialog box. What kind of information do we need to provide here?
First, we give our connection a name, something descriptive like PN2PLC1, and then we select the network interface that WinCC will use to communicate with the PLC. You'll need to choose the right network card or adapter from the list of available options.
Connection name, network interface. Those are the essentials, right? Anything else we might need to specify?
It depends on your specific network configuration and the PLC you're connecting to. You might need to enter the PLC's IP address or the Profinet subnet, Think of it like adding the street name and house number to our connections address.
So we're not just connecting to Profinet in general. We're connecting to a specific PLC on a specific network. Got it. We've named our connection, chosen the network interface, added those extra network details if necessary. What happens next?
Once you confirm those settings, the Profinet connection will appear in your channel configuration editor, all ready to handle communication between WinCC and the PLC. Data highway is open.
The data highway is open. We're bringing the real world into our WinCC system. But now we need to make sense of that data, visualize it in a way that's meaningful and actionable. This is where those fancy graphics and process screens come into play, right?
Absolutely. Visualizing data is a crucial part of any SCADA system. It's about transforming those raw numbers and signals into something that operators and engineers can quickly grasp and act on. WinCC has a powerful tool for creating these dynamic displays called Graphics Designer.
Graphics Designer, now that sounds like a place where we can get creative. What kind of tools and features can we expect to find there?
Imagine a digital artist's studio, but instead of paintbrushes and canvases, you have tools for drawing shapes, adding text, importing images, and embedding WinCC controls like buttons, input fields, trend displays, all that good stuff.
So we're building a digital dashboard for our process, complete with gauges, graphs, and controls for interacting with the system.
Exactly. It's all about creating a visual representation of your process, bringing it to life on the screen.
Okay, but how do we actually connect those visual elements, those gauges and graphs, to the real-time data from our tags? How do we make them dynamic, reflecting those changes happening in the process?
That's where the magic of dynamic linking comes in. Within Graphics Designer, you can link properties of those visual elements to the values of your WinCC tags. For example, you could link the text property of a display field to our reactor temperature tag, so that the field dynamically shows the current temperature as it changes.
So as the temperature sensor in the reactor vessel sends its data to the PLC, and the PLC communicates that data to WinCC, our screen updates instantly, showing us the current temperature. It's like a live feed from the process.
Exactly. And dynamic linking isn't limited to just text fields. You can link tag values to colors, positions, visibility, almost any property of a visual element. It's all about creating those dynamic, interactive displays.
Wow, the possibilities are endless. We could create animated valves that open and close, color-coded tanks that change based on the fill level, even flashing alarms that grab the operator's attention when something needs immediate action.
You got it. Your imagination is the limit.
But with great power comes great responsibility. Any tips for designing effective process screens that are both informative and easy to use? We don't want to create a confusing mess of flashing lights and blinking numbers.
Absolutely. The key is clarity and purpose. Always keep your audience in mind. Are these screens for operators who need a quick overview, or for engineers who might need more detailed information? Design your screens accordingly. Use clear labels, consistent color schemes, and incorporate visual cues like alarms and trend displays to highlight what's important.
So, form follows function. Make it clear, make it meaningful.
Exactly. Any other tips or tricks for Graphics Designer?
Sure, always looking for those time-saving techniques.
Well, one powerful feature is the use of faceplates. Think of them as reusable templates for common process elements. Let's say you have multiple pumps in your system. You can create one pump faceplate with all the standard controls and indicators. Then you just reuse that faceplate for each pump, simply linking it to the specific tags for that instance.
So faceplates are like building blocks for our screens. Save us time, ensure consistency.
Exactly. It's a great way to streamline the design process.
Faceplates, check. Dynamic screens linked to live data, reusable templates. We're making progress. What's next on our configuration adventure?
Let's talk about alarms. They're like the nervous system of our WinC system, letting operators know when something's not right.
Alarms, those digital sirens, making sure we don't miss those critical events. Where do we go to configure these alarms?
The alarm logging editor, it's Alarm Central. Here you define what triggers alarms, how they're displayed, logged, and you can even set up notifications so operators get alerts via email or text messages.
Alarm logging, got it. So we open up this editor, ready to create some alarms. How do we set up an alarm for our reactor temperature, for instance? Say, to let us know if it goes above a certain limit.
Easy. Right-click in the alarm logging editor, select New Alarm, and you'll get a dialog box where you configure the alarm's properties. You give it a clear description, specify the trigger tag, our reactor temperature in this case, and define the trigger condition. For a high-temperature alarm, we'd choose limit value exceeded and set the threatened temperature.
Okay, so if the reactor temperature goes above that limit, the alarm is triggered. What happens then?
You can decide how the alarm is displayed to the operator, maybe a pop-up window, a flashing icon, or a change in color on the process screen. You can also set its priority, which determines how prominently it's displayed and how urgent it is. And to really make it stand out, you can assign a unique sound to the alarm.
Ah, so it's not just about seeing the alarm, it's about hearing it too. Multisensory alerting.
Exactly. The more senses we engage, the more effective those alarms will be.
Alarms are configured. We're monitoring that reactor temperature, alerting operators if things get too hot, even using sound to enhance visibility. Any other best practices when it comes to alarm management?
Testing is crucial. Make sure those alarms are actually working as expected and that your notification systems are reliable. And, as always, documentation is key. Document your alarm configurations, trigger conditions, alarm classes, response procedures. It's all important.
Testing and documentation, those are our friends. Okay, we've covered tags, communication graphics, and alarms. We're well on our way to a fully configured WinCC v8.0 system. What other essential configurations should we consider?
Let's talk about historical data. Archiving, as it's often called. It's all about storing process data over time so you can analyze trends, generate reports, troubleshoot past events, that sort of thing. WinCC has a robust archiving system that we can configure to meet our specific needs.
Archiving, it's like a time machine for our process data.
I like it. Where do we go to configure this in WinCC?
The tag logging editor in WinCC Explorer. Think of it as the library where we store all our historical process data.
Tag logging. Makes sense. So we open up this editor, ready to start archiving our valuable reactor temperature data. What's the first step? We create a new archive. Right-click in the editor, select New Archive, and a dialog box will appear. We give our archive a name, something descriptive like Reactor Temperature Archive, and configure all its properties, the archive types, storage location, logging mode, and so on.
Name, type, location mode. Okay, Let's break those down. What are our choices for archive type?
WinCC offers a few different types, depending on what you need. Process Value Archive is good for storing raw process values at regular intervals. Alarm Archive is designed for, well, alarm events. You can even create custom archive types using scripting if you need something more specialized.
So different archive types for different data needs. Nice. What about the storage location? Where does this historical data actually live?
You have a couple of options. You can store archives locally on the WinCC server's hard drive, or if you're working with a distributed system or want centralized storage, you can use a network share or even a dedicated database server.
Local or network storage, we choose what fits our system architecture best. And the logging mode, what does that control?
Logging mode determines how data is written to the archive. Cyclical logging writes data at regular intervals, like taking snapshots of the process. Event-driven logging only writes data when the tag value changes or a specific event occurs.
So cyclical logging gives us a continuous record, while event-driven logging focuses on those important changes in events. We choose based on our needs and how much data we want to capture. Okay, So we've configured our archive. It has a name, a type, a storage location, a logging mode. Anything else to do before our reactor temperature data starts flowing into that archive and being preserved for all eternity?
Almost there. We need to tell WinCC which tags to include in the archive. In the Archive Properties dialog, there's a Tag Assignment tab. We select our reactor temperature tag and add it to the archive, like adding a book to our data library.
Tag assign, check. Is that it? Are we archiving yet?
Last step, we need to activate the archive. Back in the tag logging editor, select the archive and click Activate, and that flips the switch, starts the archiving process.
Activated, data is flowing, history is being recorded. Any other best practices when it comes to archiving?
Don't forget about data retention policies. How long do you actually need to keep this data? WinCC lets you configure these policies so older data gets automatically deleted.
Data retention, right? Important point. We need to strike that balance between keeping valuable historical data and not drowning in an ocean of information.
Exactly. Retention policies help you keep things manageable.
So archiving is set up, data is flowing, and we have our data retention policies in place. Anything else we need to consider before we wrap up this part of our WinCC v8.0 deep dive?
One more crucial aspect, user management and access control. WinCC allows you to create user roles, assign permissions, and control who can access what, making sure sensitive information is protected and only authorized people can make changes to the system.
User management, right? Security is always important. It's great that WinCC has these security features built in. Where do we go to configure all that?
The User Administrator tool in WinCC Explorer, that's your command center for managing users and permissions.
User Administrator. Okay, so we open up that tool, Ready to create a new user. What's the process?
Select New User to create a new account. You'll need a username, a password, and maybe some additional info like the user's full name or email address. It's basically creating a digital ID for each person who'll be using the system.
New user created. Now, how do we control what they can actually see and do within WinCC?
WinCC uses a role-based access control model. You assign users to specific roles, and each role has a defined set of permissions. For example, you might have roles like operator, engineer, or administrator, each with different levels of access and control.
So it's not about assigning permissions directly to individuals. It's about grouping those permissions into roles and then assigning users to those roles.
Yeah.
Makes things much more manageable, especially in larger systems.
Exactly. And within the user administrator, you can fine-tune those permissions even further. You can grant or deny access to specific functions, editors, even individual tags if necessary.
Wow, so we can get really granular with the control. Each user has access to exactly what they need and nothing more. It's all about finding that sweet spot between functionality and security. Okay, so we've created our new user, assigned them to a role, and fine-tuned their permissions. Anything else we need to do in terms of user management?
Regular review is a good practice. Make sure inactive accounts are disabled, permissions are up to date as roles change, and that your password policies are strong, complex passwords, regular changes, all that good stuff.
Right, security isn't a one-time thing, it's an ongoing process. We need to stay vigilant to ensure the integrity and security of our WinCC system.
Well said. A secure system is a reliable system.
Absolutely. And with that insightful discussion on user management, I think we've reached the end of part 2 of our WinCC v8.0 deep dive. We've covered tags, communication, graphics, alarms, archiving, and even user management. It's been quite a journey.
We've configured our system, established communication, created dynamic displays, and implemented robust security measures. We're well on our way to building a powerful and reliable WinCC system.
I'm feeling pretty confident, but there's always more to learn, right?
Absolutely. In part 3, we'll explore some of those more advanced features of WinCC v8.0.
Stay tuned, everyone. There's more WinCC adventure to come.
Ah.
Welcome back to the deep dive. We've tackled installations, configurations, all those core components. Now it's time to unleash the real power, those advanced features of WinCC v8.0, the ones that can really elevate your automation game.
It's like we've mastered the basics, and now we're ready for those expert-level moves.
Exactly. So, where do we begin this advanced WinCC adventure?
Let's start with scripting. It's where things get really interesting. WinCC has powerful scripting capabilities using VBScript. You can automate tasks, create custom functions, and extend the functionality of your system way beyond those standard features.
Scripting. It's like unlocking a secret level in WinCC. But where do we even start with that? Is that like learning a whole new language?
It might seem that way at first, but VBScript is pretty straightforward, especially if you've done any programming before. The core of WinCC scripting is the global script editor. Think of it as your coding playground, where you write VBScript code to interact with tags, objects, and events within the WinCC environment.
Global script editor. Okay, so we open up this editor, ready to write some code. Do we just start typing away from scratch?
You could, but WinCC makes it even easier. There are predefined events that you can hook your scripts into. Things like a screen opening, a button being clicked, a tag value changing. Those events act like triggers, starting your code to perform specific actions.
So it's not just about writing code in a vacuum, it's about connecting that code to the things happening in our WinCC system.
Exactly. For instance, you could write a script that runs when the operator clicks a button on a process screen. That script could read data from a bunch of tags, crunch some numbers, and then update other tags, or even control external devices based on those calculations.
So we're not just passively displaying data, we're actively interacting with it, controlling the physical world based on what's happening within our WinCC system. That's pretty powerful.
It is. Scripting opens up a whole world of possibilities for automation and customization.
But VBScript, isn't that a bit old school? Are there any more modern scripting options in WinCC?
You make a good point. While VBScript is deeply integrated with WinCC, there's a growing trend toward using C# and .NET for scripting in industrial automation. WinCC does offer some integration with .NET through its Open Development Kit, or ODK for short.
ODK, that sounds pretty high-tech. What exactly can we do with ODK and .NET?
Think of ODK as the ultimate toolkit for customizing and extending WinCC. It lets you create custom controls, extensions, even entire applications that fit right into the WinCC environment. You're leveraging the power of .NET to build solutions tailored to your specific needs.
Custom controls, extensions, whole applications. We're talking serious customization here. But ODK sounds a bit intimidating. Is it only for expert programmers?
While ODK does require some programming knowledge, specifically in C# and .NET, there are tons of resources out there to get you started. Siemens has great documentation and example projects, plus the .NET community is huge, so there's a lot of online support available.
That's good to know. So if we need those really customized solutions, ODK is the way to go. But for more straightforward scripting, VB Script in the global script editor is a great starting point.
Exactly. Pick the right tool for the job.
Okay, shifting gears a bit, let's talk about reporting. WinCC can generate reports, right? But how powerful are those capabilities? Can we create custom reports, or are we stuck with predefined formats?
The WinCC reporting engine is actually very versatile. You have a lot of control over the layout, content, data sources, all of that. You can design reports from scratch, or use templates, add text fields, tables, charts, images, even custom calculations. It's all about presenting information in a clear and understandable way.
So we can really create professional-looking reports that tell a story, not just dump raw data onto a page.
Exactly, turning data into information that drives action.
Where do we go in WinCC to unleash this reporting power?
The Report Designer, it's your reporting hub. You can find it in WinCC Explorer. It's got a user-friendly interface for designing reports, similar to the Graphics Designer.
Report Designer. So we open it up, ready to create a report. What's the first step?
Choose your data source. Your reports can pull data from a variety of places: WinCC archives, SQL databases, even external files like spreadsheets or CSV files.
So we're not limited to just data from within WinCC. We can bring in data from other sources as well.
Exactly. Lots of flexibility there. Once you've got your data source, you can start adding elements to your report using a drag-and-drop interface. Text fields, data tables, charts, images, even those custom calculations. It's all about building a visual representation of your data.
A digital canvas for data storytelling. And do we have to manually generate these reports every time?
Nope. WinCC lets you schedule reports, so they run automatically at certain times or intervals. You can even have the system email those reports to specific people, making sure the right information gets to the right people at the right time.
Automated reporting, that's a huge time saver. Okay, we've got the data, layout, elements, scheduling, distribution. It seems like we've covered everything for creating effective reports. Any final tips?
Keep it clear, keep it accurate. Design reports that are easy to understand, with clear labels, consistent formatting, and the right visualizations. Choose charts and graphs that tell the story effectively. And always test your reports to make sure they're accurate and providing the insights you need.
Clear, accurate, and insightful. That's the goal.
Precisely. Reports should be valuable tools that drive decision-making, not just data dumps.
Okay, we've explored scripting, ODK, reporting. That's a lot of advanced features. Anything else we should cover before we wrap up our WinCC v8.0 journey?
One more important concept: redundancy. It's all about building fault tolerance into your system, making sure things keep running even if something fails.
Redundancy. It's about keeping those mission-critical processes going no matter what. How does WinCC handle that?
WinCC offers robust redundancy options. You can configure redundant servers, networks, even clients, to minimize downtime and ensure that your system can gracefully handle any failures.
So if one server crashes, the other one takes over seamlessly and we don't skip a beat.
Exactly. It's like having an insurance policy for your automation system.
How do we go about configuring redundancy in WinCC?
It depends on your specific system setup and how much redundancy you need, but generally you'll use the redundancy editor in WinCC to configure those redundant components, typically two servers that mirror each other. You define how they communicate and stay synchronized.
Redundancy editor, yet another tool in the WinCC toolbox. Okay, so we have these redundant servers, networks, clients, all working together to keep things running smoothly. Any other redundancy tips?
Testing, testing, testing. Redundancy setups can be complex, so thoroughly test your configuration to make sure those failover mechanisms work as expected and that the data synchronization is seamless. And, of course, document everything carefully, failover procedures, recovery steps, make sure the operators know what to do if something goes wrong.
Thorough testing and clear documentation, essential for any critical system.
Absolutely. Redundancy is key to ensuring reliability and minimizing downtime, especially in those industrial environments where 24/7 operation is crucial.
Well said. And with that insightful discussion on redundancy, I think we've reached the end of our epic WinCC v8.0 deep dive.
We've covered so much ground. From the basics of installation and configuration to those advanced features that really unlock the power of WinCC. We've talked about scripting, ODK, reporting, and redundancy. It's been quite a journey.
It really has. I feel like we've gone from WinCC newbies to seasoned explorers.
We've learned a lot, that's for sure. But the learning never really stops, does it? The world of industrial automation is always changing, so stay curious, keep exploring, and who knows, maybe one day you'll be the expert guiding others through these fascinating systems.
That's a great message to end on. To our listeners, we hope you've enjoyed this deep dive into WinCC v8.0. It's a powerful system with a lot to offer. Until next time, keep exploring, and thanks for joining us on the Deep Dives. Hey everybody, and welcome to the Deep Dive. We're getting right into it today, diving into WinCC v8.0.
It's like we're handing you the keys to this awesome automation system, and we'll help you become a total pro.
Awesome. Okay, so where do we even begin? What's the plan for this WinCC deep dive?
We'll be going through 6 main chapters, kind of like your roadmap to mastering WinCC.
6 chapters, okay. And those are...
Getting started, WinCC documentation, migration, diagnostics, licensing, and finally, performance data.
Okay, 6 chapters, got it. Can we get a sneak peek of what each one's all about?
Sure. Chapter 1, getting started, that's your foundation, where you get familiar with the WinCC environment, learn how it all looks, and start playing with the tools.
Makes sense. And then what about Chapter 2, WinCC documentation, is that right?
Yeah, that's the one. Chapter 2 is all about becoming best friends with the WinCC documentation, learning how to find anything you need and all that info.
No more getting lost in the documentation, that's for sure.
Yeah.
So what about Chapter 3? That's migration, right?
Exactly. Chapter 3 is your guide to upgrading from an older version of WinCC, making the switch smoothly and avoiding any problems.
Okay, so we've covered getting started, WinCC documentation, and migration. What's next?
Chapter 4, Diagnostics. That's where we turn you into a WinCC detective.
Ooh, a detective. I like it.
You'll learn how to diagnose and fix anything that might go wrong, from communication errors to problems with your scripts.
All right, so we're going to be troubleshooting pros. What about the last 2 chapters, licensing and performance data?
Right. Chapter 5, licensing, all about understanding how WinCC licenses work. We'll clear up any confusion about different types, how to manage them, and how to troubleshoot if anything acts up.
Sounds good. And our final chapter.
Chapter 6, performance data. This is where we unlock the secrets to making your WinCC system run like a supercharged race car, top speed and efficiency.
Nice. So we've got our 6 chapters, getting started, WinCC documentation, migration, diagnostics, licensing, and performance data. 6 chapters, and we're WinCC masters. Let's jump right in. Where do we start?
Let's start with Chapter 1, getting started. This is where your WinCC journey begins.
Works for me. So what's first on the agenda for our WinCC 101?
First up, we'll tackle Section 1.1, understanding the key parts of the WinCC v8.0 environment.
Okay, so we're getting introduced to all the players in the WinCC world. Who are they, these key components?
You'll meet the WinCC Explorer, that's your command center for managing projects. Then there's the graphics designer. Think of that as your art studio for making visuals. And finally, the tag management tool that keeps all your tags organized.
So it's like having a project manager, a graphic designer, and a data whiz all in one.
Exactly. They all work together in the WinCC world.
I'm starting to get the picture. What's next in this getting started chapter?
Section 1.2, and that's all about project creation, the art of building a WinCC project from scratch.
Okay, time to put on our builder hats. What are the steps for creating a project?
You'll learn how to create a new WinCC project, how to set it up just the way you like, and how to connect it to your automation devices like your PLCs, HMIs, and all that.
So basically, laying the foundation, setting the rules, and opening up communication. What comes after that foundation is set.
Then, in Section 1.3, you get to bring your process to life by creating your first process picture. This is like your canvas, where you paint a visual picture of your automation system.
Cool, so we're going from blueprints to a 3D model. How do we actually create these process pictures?
It starts by adding objects to your picture, think tanks, valves, pumps, pipes, all the physical parts of your process. Then you link these objects to tags, which are like variables that hold the data from your devices.
So we're connecting what we see to the actual data points.
You got it. And the final step, you configure the properties of these objects, stuff like color, size, how they move, all that good stuff, to make your visual picture come alive.
So we're basically building a digital twin of the whole system. This is pretty awesome. Before we move on, any key takeaways from this getting started chapter?
For sure. Remember, WinCC v8.0 is designed to be user-friendly. Don't be intimidated, just dive in and explore.
I like that. No need to be scared. What else should we keep in mind?
Creating a WinCC project is a step-by-step process. First, you set up the project, then you build your process pictures, and finally, you connect everything using those tags.
Got it. So methodical, step by step. Any other nuggets of wisdom?
And finally, creating your first process picture is easier than you might think. WinCC has tons of pre-built objects and tools to help you. Don't be afraid to play around and have fun.
Okay, I'm feeling ready to tackle this, but I'm sure our listeners have some questions too. What are some common FAQs about getting started with WinCC?
One question that pops up a lot is, what if I'm totally new to this whole automation world? Am I going to be lost? And the answer is absolutely not. WinCC is designed for everyone, even beginners. We start with the basics and build from there.
That's great to hear. What are some other common questions?
Another one is, what makes WinCC v8.0 so special compared to older versions or other automation software?
Okay, yeah. What makes WinCC v8.0 stand out from the crowd?
Well, first, it's super powerful. It can handle really complex tasks, controlling tons of tags, managing sophisticated visuals, the whole 9 yards.
So power is one of its superpowers. What else?
Second, it's incredibly flexible. You can customize it to fit your needs perfectly, like tailoring the look and feel, or even creating your own scripts and functions.
Okay, adaptable and customizable. Yeah. I like it. Anything else that makes WinCC v8.0 stand out?
And third, it's just designed to be easy to use. The interface is intuitive, everything is well organized, and the documentation is really helpful.
So it's powerful, flexible, and user-friendly. Sounds like a winning combination. All right, so we've covered Chapter 1, Getting Started, and I'm feeling pretty good about the basics. What's next on our WinCC adventure?
Let's move on to Chapter 2, WinCC documentation. Time to unlock the secrets of finding the info you need right when you need it.
Sounds good to me. Let's conquer the documentation. What's our first stop on this info quest?
We'll start in Section 2.1 by understanding how the WinCC information system is structured, basically. Learning to navigate this huge library of WinCC knowledge.
Okay, so we're getting a map of the territory. What are the main sections of this information library?
You'll learn about the different kinds of documentation, from detailed manuals to quick reference guides. We'll also explore how it's all organized so you can quickly find what you need.
No more getting lost in the documentation jungle. What else will we uncover in this chapter?
Section 2.2 introduces you to 2 amazing tools for instant help: tooltips and the status bar.
Ooh, those sound intriguing. Tell me more about tooltips and the status bar.
Tooltips, think of them as pop-up windows that appear when you hover over something in WinCC. They give you a quick explanation, saving you a trip to the manual.
Like little mini guides that magically appear. I like it. And what about the status bar?
The status bar, you'll find it at the bottom of the WinCC window, gives you context about what you're doing. It's like having a helpful friend whispering tips in your ear.
So tooltips for quick answers and the status bar for guidance. A dynamic duo. What else is coming up in this documentation chapter?
In Section 2.3, we unlock the power of direct help, sometimes called the What's This feature.
What's this? Sounds mysterious. What's so special about it?
Imagine having a personal WinCC expert on call. Click the What's This button, then click anything in WinCC, and boom, a window pops up with all the details.
Okay, so it's like an interactive encyclopedia of all things WinCC. Awesome. What's the last stop on our documentation journey?
And finally, Section 2.4, get ready to become a WinCC search master.
Time to level up those search skills.
Right.
What are the secrets to finding exactly what you need in all that documentation?
We'll cover everything from basic keyword searches to more advanced tricks like using Boolean operators, wildcards, and filters. You'll learn how to refine your searches to zero in on exactly what you're looking for.
No more sifting through pages of irrelevant results. That's a game changer. Okay, before we move on, any key takeaways from this documentation deep dive?
Absolutely. First off, remember, the WinCC documentation is your best friend. Use it. Don't be shy.
Embrace the documentation. Got it.
Yeah.
What else?
Second, those built-in help features, like tooltips, the status bar, and direct help, they're there to save you time and headaches. Use them.
Okay, leverage those helpers. Any other pearls of wisdom?
And finally, becoming a master searcher will make your life so much easier. Learn those advanced search techniques, and you'll be able to find anything in the WinCC documentation.
Okay, I'm feeling ready to conquer the documentation challenge.
Yeah.
I'm sure our listeners have some questions, though. What are some common FAQs about WinCC documentation?
One that comes up a lot is, what if I just can't find the answer I need in the documentation? Where do I go for help?
Yeah, what happens when we hit a dead end? Where can we turn?
Luckily, Siemens has great online support. There's a knowledge base packed with FAQs, tutorials, examples, all that good stuff. You can also connect with other WinCC users in forums and groups.
So we've got a whole community to back us up. That's good to know. Any other common questions that come up?
Another frequent one is the documentation available in different languages?
A very good question, especially in today's global world. What's the answer?
Definitely. Siemens knows how important it is to have documentation in lots of languages. You can access it in tons of different languages, so you can work in the one that's most comfortable for you.
That's fantastic. Okay, we've navigated the world of WinCC documentation. I feel much more confident finding what I need. What's next on our WinCC roadmap?
Let's move on to Chapter 3, Migration. Time to upgrade from an older version of WinCC to the shiny new v8.0.
Migration, here we come. What's the first step on this upgrade adventure?
We start in Section 3.1 with understanding the key concepts of WinCC migration, kind of like getting oriented before we set off.
Okay, so we're getting our bearings. What are the key things to understand about WinCC migration?
We'll look at different migration scenarios. Are you coming from WinCC v7.5, v7.4, maybe even an earlier version? Each one has its own things to consider. We'll also talk about why upgrading is a good idea, all the benefits you get with WinCC v8.0.
So we're mapping out the route and highlighting the rewards. What else should we keep in mind before we embark on this migration journey?
And we'll also touch on potential challenges you might run into. It's not always smooth sailing, but it's good to be prepared. By knowing the pitfalls, you can avoid them, or at least be ready to handle them.
Okay, so being realistic about the potential bumps in the road. But ultimately, we're aiming for a smooth transition, right?
Absolutely. The goal is to make it as seamless as possible. And to do that, we need to understand how WinCC v8.0 is different from the older versions. That's what we'll cover in Section 3.2.
Right. Comparing the old and the new. What are some key differences we need to be aware of?
We'll focus on the big changes, the new features and functions that v8.0 brings to the table. We'll also point out any incompatibilities, any places where your existing project might need some adjustments to work perfectly with the new version.
So checking out the new toys and making sure our old tools are compatible. This is getting exciting. What's next on the migration checklist?
Section 3.3 is all about preparation. Think of it as packing your bags and making sure you've got everything you need before you set off on your migration adventure.
Okay, so getting our migration toolkit ready, what are the essentials we need to pack?
First things first, we got to check the system requirements for WinCC v8.0. Make sure your computer can handle the upgrade, both the hardware and the software.
Right, making sure our computer's up to the task. What else should we do to prepare?
Next up, super important, back up your existing project data. This is crucial. You don't want to lose any of your hard work during the migration.
Always good advice. Backups are a lifesaver. What other prep steps are there?
We'll also walk you through any pre-migration tasks like updating drivers or installing any required software.
Okay, so getting everything in order before we make the big switch. So now we're ready to actually move our data, right? Where do we start?
Section 3.4, this is where the action happens. We'll get into the nitty-gritty of migrating your SQL Server databases, the heart of your WinCC system. It's where all your project data and history are stored.
Okay, so moving the data warehouse. What are the key steps in migrating these SQL Server databases?
We'll take you through upgrading your existing databases to a version that works with WinCC v8.0. We'll cover different methods like in-place upgrades or detaching and attaching databases.
Okay, making sure our data foundation is rock solid for the new version. What about the WinCC project itself? How does that move over?
That's what we tackle in Section 3.5. Get ready to meet the WinCC Project Migrator tool.
The Project Migrator tool sounds promising. What's that all about?
Think of it as your moving truck for your WinCC project. This handy tool will help you transfer your entire project, everything. Your pictures, scripts, tags, settings, all of it, from your old WinCC to the new v8.0 environment.
Okay, so it's a smooth and seamless transfer.
Nice.
Anything else we need to migrate besides the databases and the project?
In Section 3.6, we focus on migrating your S7 projects. Those are the programs running on your Siemens PLCs, the brains of your automation system.
Right, got to bring the brains along for the ride. What needs to happen to migrate these S7 projects?
We'll guide you through upgrading them so they're compatible with WinCC v8.0. Might involve updating communication settings, tweaking data structures, or even making changes to the program logic.
Got it. Making sure the brains in the control center can talk to each other. What about situations where you have a bunch of people working on the same WinCC project?
That's where Section 3.7 comes in. We'll delve into migrating multi-user projects.
Multi-user projects. Sounds tricky. What are the challenges with migrating those types of projects?
When you've got multiple people involved, you have to make sure everyone's changes are merged properly and that the project stays consistent throughout the whole migration. We'll explore the best ways to handle those situations.
So it's like coordinating a move for the whole team. What happens after we've migrated the databases, the project itself, the S7 projects, and tackled any multi-user complexities? Are we done then?
Almost there. Section 3.8 is about post-migration steps, kind of like unpacking and setting up your new workspace, making sure everything is in the right place.
Okay, adding the finishing touches to our migration, what are some of those essential post-migration tasks?
One important thing is updating the system messages and alarm logging. This ensures that your alarms are categorized and displayed correctly in WinCC v8.0. We'll also cover any data conversions that are needed to make sure everything's compatible with the new features, stuff like WinCC Web UX.
So fine-tuning the alarm system and making sure our data plays well with the new features. What if we've got a more complex system that needs to stay up and running during the upgrade?
That's what Section 3.9 is all about. Upgrading a redundant system while it's still operating.
A redundant system, what exactly does that mean?
Think of it as a backup system that can jump in if the main system has a problem. This ensures things keep running smoothly, even if there's a hardware or software hiccup.
That's super important for critical systems. So how do we upgrade a redundant system without causing any interruptions?
It involves a carefully planned series of steps. We'll walk you through the whole process, from upgrading the standby server to switching over to the new upgraded system.
Okay, so it's a delicate dance to keep the music playing without missing a beat. Before we move on, any key takeaways from this deep dive into WinCC migration?
Definitely. Remember, migrating to WinCC v8.0 is a well-defined process. Follow the steps, and you can avoid a lot of common problems.
Okay, so a methodical approach is key. What else should we keep in mind?
Second, preparation is everything. Take the time to check those system requirements, back up your data, and do any pre-migration tasks. It'll save you time and stress later on.
Got it. Preparation prevents panic. Any other words of wisdom for a smooth migration?
And lastly, don't be afraid to ask for help. Siemens has great support resources, and there are tons of online communities where you can connect with other WinCC users and get assistance if you need it.
Okay, I'm feeling a lot more confident about tackling this migration, but I'm sure our listeners have some questions too. What are some common FAQs about WinCC migration?
One that comes up often is, what if I hit an error during the migration? What do I do?
That's a good question. Errors can be scary. What are our options if we hit a roadblock?
Don't panic. First thing, check the WinCC migration logs. They have detailed error messages. They often give you clues about what went wrong and how to fix it. If you can't figure it out on your own, the WinCC documentation is your friend, or you can reach out to Siemens support.
Okay, so there are resources to help us troubleshoot. What about other common questions?
Another one is, what are the biggest changes between WinCC v8.0 and older versions that might affect my project after migration?
Yeah, how do we know if our old project will play nicely with the new version?
WinCC v8.0 has some big improvements, like in graphics, scripting, and data handling. For example, if you're migrating from an older version, your project data will be converted to Unicode. You might need to adjust your scripts and visuals to make sure everything's compatible.
So good to be aware of those potential compatibility issues.
Yeah.
Any other advice for a seamless migration?
Absolutely. Take some time to get familiar with the new features and functions in WinCC v8.0 before you start migrating. That way you can anticipate any potential problems and plan accordingly.
Okay, great advice. So we've covered getting started, mastering the documentation, and navigating the migration process. I'm starting to feel like a WinCC pro, but we still have 3 more chapters to conquer, right?
You're right about that. We still have diagnostics, licensing, and performance data coming up. And believe me, they're packed with even more valuable info and practical tips.
Okay, I'm ready for the next challenge. But for now, let's give our listeners a chance to process all this information. We'll be back soon with the next part of our WinCC deep dive.
Sounds good. Join us next time as we dive into Chapter 4. Where we'll make you a troubleshooting pro. We'll uncover the secrets of diagnostics, explore all the powerful tools at your disposal, and show you how to solve those pesky WinCC mysteries that might pop up along the way.
Until then, keep exploring, keep learning, and keep automating. All right, welcome back to the deep dive, everyone. We're picking up right where we left off, continuing our journey to becoming WinCC v8.0 masters.
That's right. We've covered getting started, explored the WinCC documentation, and even tackled the migration process. Now it's time to put on our detective hats and dive into Chapter 4, Diagnostics.
I'm ready to solve some WinCC mysteries. What kinds of cases will we be cracking in this chapter?
We're going to give you the skills and the tools to diagnose and solve any problem that might pop up in your WinCC system. Anything from communication errors to glitches in your scripts.
Okay, so we're becoming WinCC troubleshooters.
Yep.
Where do we start?
Our first stop is section 4.1 overview, Diagnostics in WinCC. It's like getting familiar with your detective's toolkit.
Okay, opening up the toolbox. What kind of tools are we talking about here?
We'll start with the WinCC diagnostic files. They're like the clues at a crime scene, giving you valuable info about how your system is behaving.
Interesting. What kind of information can we find in these diagnostic files?
These files contain logs, traces, all sorts of forensic data that can help you understand what's going on behind the scenes in your WinCC system. You can analyze them to retrace the steps that led to a problem, see if there are any patterns, and even get insights into potential bottlenecks or areas you can improve.
So we're examining the evidence to figure out what happened. What else is in our diagnostic toolkit?
We've also got some powerful online support resources from Siemens, like a team of expert analysts who are ready to help you crack the case.
Okay, so we've got backup. Tell me more about these online support options.
Siemens has a whole suite of resources, including a knowledge base with FAQs, tutorials, application examples, you name it. You can also connect with other WinCC users in online forums and discussion groups, get advice from the WinCC community.
That's awesome. We can learn from others who face similar challenges. What if we need more specialized tools for specific problems, though?
That's where the built-in diagnostic features of WinCC come into play. Section 4.1 gives us a tour of these features. We'll cover everything from how to analyze communication channels to how to examine what your scripts and actions are doing.
Okay, so we're getting into the more advanced forensic techniques. What are some of the key features we should know about?
You'll find tools for analyzing tags. Those are the variables that hold all the data in your system. You can track their values over time, see how they're changing, and spot any weird behavior. There are tools for looking at system events, too. They're like timestamps that record everything happening in WinCC. And for those working with redundant systems, there are special tools to help you diagnose problems in those more complex setups.
This is starting to sound like a real detective agency. We've got our files, our online support team, and a whole arsenal of specialized tools. What are some of the toughest cases we might encounter as WinCC detectives?
One of the most common problems, and often the most frustrating, are communication errors. This is when WinCC can't talk to your PLCs or other devices properly. Luckily, WinCC has several tools to help you figure out what's going wrong.
Okay, so communication breakdowns happen. What tools can we use to get things talking smoothly again?
Your go-to tool is going to be the WinCC channel diagnosis. Think of it like a communication interceptor. You can listen in on the conversations between WinCC and your PLCs.
I like that analogy. So we can see the messages going back and forth, spot any errors, and figure out where the communication is breaking down. What other tools can help us with communication problems?
You can also use the tag logger to keep track of the values of tags being exchanged between WinCC and your PLCs. That can show you if the data is being sent correctly and if there are any hiccups or delays.
Okay, so channel diagnosis for real-time monitoring and tag logger for a historical view. That's a powerful combo. What if the problem isn't with communication, but with the WinCC system itself, specifically the scripts that are controlling how our application works?
That's where our debugging tools come in. WinCC has some great debugging features that allow you to go through your scripts line by line, check the values of variables, and find exactly where those errors are hiding.
Okay, so we can really dissect our scripts and track down those pesky bugs that are causing problems. What are some of the key debugging tools we should be familiar with?
One of your best friends is going to be the AT-Diag tool. Think of it like your script interpreter. It helps you understand the logic and flow of your code.
So APDIAC can help us decipher what our scripts are actually doing. How does it work, though?
You can set breakpoints in your code. It's like hitting the pause button at certain points. Then you can walk through the code line by line, look at the variables, and see how your application changes as each line runs.
So we're slowing down the action, zooming in on the details, and watching how each instruction affects the system. Very cool. What other tools are good for debugging?
The output window is another useful one. It shows you the messages from your scripts while they're running. That can help you understand what your code is doing and spot errors or unexpected behavior.
So it's like a running commentary on our scripts.
Yeah.
What about situations where we're not dealing with specific errors, but more like performance issues? Things like slow screen updates or sluggish response times.
That's where performance monitoring steps in. WinCC has tools that let you track key performance indicators like CPU usage, memory, and network traffic. By keeping an eye on these, you can spot potential bottlenecks and make things run more smoothly.
Okay, so we're taking the pulse of our WinCC system to make sure everything is healthy. What are our go-to tools for performance monitoring?
One of the most useful is the performance monitor. It shows you real-time graphs and charts of how your system resources are being used.
So we can see at a glance if our CPU is overloaded, if we're running low on memory, or if our network is getting clogged up. What other tools are helpful for analyzing performance?
WinCC also has something called performance tags. These special tags give you insights into specific parts of your system's performance. For example, there are tags that track the number of messages being processed every second, how long it takes for database queries to run, and how many clients are connected to the server.
Wow, that's a lot of data. What do we do with all this performance information, though? How can we actually use it to improve our WinCC system?
The key is to analyze the data, look for patterns, and then take specific actions to address any bottlenecks or areas that need improvement.
So we're playing detective again, but this time we're on the trail of performance issues. What are some common ways to optimize performance?
If your CPU is always running high, you might need to optimize your scripts, reduce the number of objects in your pictures, or even upgrade your hardware. If memory is a problem, you might need to change your archiving settings, optimize how your data is structured, or get more RAM for your system. And if your network is slowing things down, you might need to divide it up, fine-tune your communication protocols, or even think about upgrading your network infrastructure.
Okay, so performance optimization is all about finding those bottlenecks, understanding what's causing them, and then taking the right steps to make our WinCC system run smoothly and efficiently. Before we move on, let's answer some questions that our listeners might have about WinCC diagnostics.
Sure thing. What are they wondering about?
One question that often pops up is, what are the most common problems I might encounter in my WinCC system?
That's a good question, and unfortunately, the answer is there are quite a few possibilities. Communication errors between WinCC and PLCs are definitely up there, as are scripting errors that can cause your application to act up. And then we've got performance issues, which can be particularly tricky to solve.
So it's just like a real detective agency, all sorts of different cases to solve. You've already given us a great overview of the tools and techniques we can use, though. Any other advice for our aspiring WinCC detectives out there?
One of the most important things is to be systematic. When a problem pops up, don't just start trying random things and hoping for the best. Take a step back, gather as much information as you can, and then use the right diagnostic tools to narrow things down and find the root cause.
Okay, so be methodical and use a process of elimination. Any other tips for troubleshooting effectively?
Another good practice is to keep track of what you find. Write down the errors you see, the steps you take to solve them, and the solutions that work. This helps you solve the problem now, and it also creates a knowledge base you can use later if a similar problem pops up again.
That's great advice. A good troubleshooting log can save you a lot of headache down the road. Okay, we've covered a lot of ground in Chapter 4 Diagnostics. I'm feeling much more confident about tackling any WinCC mystery that comes my way. What's next on our agenda?
Let's shift gears and move on to Chapter 5 licensing. We're going to demystify the sometimes confusing world of WinCC licenses and make sure you have the right access to unlock the full potential of this powerful software.
Licensing. Here we come. This is one area that's always felt a bit murky to me. What are the essential things we need to understand about WinCC licensing?
First and foremost, software has value. The folks who develop these amazing tools deserve to be paid for their hard work, and licensing agreements help make sure that happens. They help ensure ongoing innovation and improvement.
Okay, so it's about respecting intellectual property and supporting the development of WinCC. What else is important to understand?
We'll get into the details of how WinCC licensing works, looking at the different types of licenses, how they function, and what you can do with them.
Okay, time to unravel the mysteries of WinCC licensing. What are some key types of licenses we should be aware of?
One of the main differences is between runtime licenses and runtime and configuration licenses. Runtime licenses let you run WinCC in runtime mode, so you can see your process visualizations and interact with your system. But if you want to actually develop, modify, or configure WinCC projects, you'll need a runtime and configuration license. That gives you full access to the runtime environment and the configuration tools.
So it's like having different levels of access to a building. A runtime license gets you in the door, but a runtime and configuration license gives you the keys to every room.
Exactly. Another important thing to know about is power tags. These are like the currency in the WinCC world. They determine how many tags you can use in your project, and different licenses come with different numbers of power tags.
Okay, so power tags are basically our budget for tags. We need enough to cover all the tags we want to use. What happens if we run out?
If you go over the limit set by your license, WinCC will switch to a limited functionality mode, which is not fun. You can avoid that by buying a Power Pack license upgrade, which gives you more power tags.
Got it. So planning our power tag usage is important. What else do we need to know about managing WinCC licenses?
To help you keep everything organized, Siemens has this great tool called the Automation License Manager. It's your control center for everything related to licenses. You can install, transfer, remove, and monitor your licenses from there.
Okay, so the Automation License Manager is our one-stop shop for managing licenses. What are some of the things we can do with it?
You can install new licenses, move licenses between computers, deactivate licenses you don't need anymore, and even generate reports to see how you're using your licenses. It's a really powerful tool for making sure you're always in compliance with your licensing agreements.
That's fantastic. We have the knowledge and the tools to manage our licenses effectively. But what happens when things go wrong? What if we run into a licensing problem, like a missing license key or an activation error?
Time to put on our detective hats again. WinCC has several diagnostic tools and resources to help you pinpoint the source of licensing problems and get things back on track.
Okay, so we're becoming licensing detectives now. What are some of the key tools we should know?
The WinCC license analysis tool is a good one. It gives you a detailed overview of your current licensing situation, including the types of licenses you have, how many power tags you're using, and any potential conflicts.
So it's like a health check for our licenses, making sure everything's in order. What else can we use to troubleshoot licensing issues?
Another helpful resource is the Automation License Manager's diagnostic log. It keeps track of everything that happens with your licenses, like installations, activations, and deactivations. Looking through this log can often help you figure out what caused an error and how to fix it.
So it's like a trail of breadcrumbs leading us to the source of the problem. What if we've tried everything and we still can't solve the issue?
Don't worry. Siemens has great support for licensing issues. You can contact their support team directly or check their online knowledge base, which has tons of info about common licensing problems and solutions.
That's good to know. We have backup if we need it. Okay, we've explored the world of WinCC licensing, from the basics to the practical tools. I'm feeling much more confident about navigating this complex landscape. What's next on our WinCC journey?
Now let's turn our attention to Chapter 6, Performance Data. We're going to dive into the world of performance optimization, learning how to monitor, analyze, and fine-tune your WinCC system to make it run like a well-oiled machine.
Performance optimization? Let's do it. I'm excited to make our WinCC systems run as smoothly and efficiently as possible. Where do we start this performance tuning adventure?
We'll start in Section 6.1 by understanding the basic principles of performance data in WinCC. We'll look at the different factors that can affect performance, everything from the hardware and software you're using to how complex your WinCC project is.
Okay, so getting a big picture view of the performance landscape, what are some of the key factors we should keep in mind?
One of the most important factors is the processing power of your computer. A faster CPU will generally mean smoother graphics, faster script execution, and quicker response times. The amount of RAM you have also plays a big role, especially if you're working with large projects or lots of data. And your hard drive speed can affect performance too, especially when you're loading or saving projects or accessing archive data.
Okay, so the hardware is the foundation. What about the software side of things?
On the software side, the complexity of your WinCC project can have a big impact. The more objects you have in your pictures, the more complex your scripts, and the more data you're archiving, the more resources your system will need to handle it all.
So it's a balancing act. We need to find the right balance between functionality and performance. What are some other things that can affect performance?
Your network can also play a big role, especially if you have a distributed WinCC system where multiple clients are connecting to a server. The speed and reliability of your network can affect data transfer rates, response times, and the overall responsiveness of the system.
Right. So we need a network that can keep up with our WinCC system. Now that we know what can affect performance, how do we actually monitor and analyze how well our WinCC system is doing?
Now for the fun part. WinCC has a bunch of performance monitoring tools that let you track key indicators, identify bottlenecks, and get insights into how your system is behaving.
I'm ready to be a performance analyst. What are some of the key tools I should know about?
One of your main tools is the Performance Monitor, which gives you real-time graphs and charts showing how your system resources are being used. You can see your CPU usage, memory consumption, disk activity, and network traffic all in one place.
So it's like a dashboard for our WinCC system, giving us a clear picture of how it's running. What other tools are good for performance analysis?
Another powerful tool is the tag logger. You can use it to track the values of specific tags over time, which is super helpful for spotting performance issues related to data processing or archiving. You could log things like the time it takes for a script to run, the response time for a database query, or how many messages are being processed each second.
Okay, so we could really zoom in on specific areas and get detailed performance data. But what do we do with all this information? How can we use it to actually improve our WinCC system's performance?
It's all about analysis. Look for patterns in the data and then take specific actions to fix any bottlenecks or areas that need improvement.
Okay, so we're back to being detectives, but this time we're investigating performance. What are some common techniques for optimization?
If your CPU usage is always high, you might need to optimize your scripts, reduce the number of objects in your process pictures, or even consider upgrading your hardware. If memory usage is a concern, you might need to adjust your archiving settings, optimize your data structures, or add more RAM to your system. And if your network is causing slowdowns, you might need to segment your network, optimize your communication protocols, or even think about upgrading your network infrastructure.
So performance optimization is a multifaceted process. It involves identifying bottlenecks, figuring out what's causing them, and then taking the right steps to make our WinCC system as efficient as possible. Can you give us some examples of how we might optimize specific parts of the WinCC system?
Sure. Let's start with the graphics system, which is responsible for displaying your process visualizations. One way to improve graphics performance is to reduce the number of objects in your pictures. If you have tons of objects, especially animated ones or objects with complex properties, it can take a lot of processing power to display them all.
Okay, so decluttering our pictures can make a big difference. What are some other tips for making the graphics run smoothly?
Another technique is to use efficient graphics formats. WinCC supports a lot of different formats, but some are better than others. For example, vector graphics are usually more efficient than bitmap images. They have smaller file sizes and render faster.
Got it. So choosing the right graphics format is key. What about scripting performance? How can we make our scripts run faster and more efficiently?
One of the best ways to optimize your scripts is to avoid unnecessary calculations or data manipulations. For example, if you're reading the value of a tag over and over again inside a loop, it's much more efficient to read it once outside the loop, store it in a variable, and then use that variable inside the loop.
Makes sense. Avoiding redundant operations can save a lot of processing time. Any other scripting optimization tips?
Another technique is to use the right data types for your variables. For example, if you're working with integers, use the integer data type instead of the floating point data type. Integer operations are generally faster, so that can improve performance.
Okay, choosing the right data types can speed things up. What about the message system? How can we make sure it handles alarms, events, and notifications efficiently?
One important thing is to set the right alarm priorities. Not all alarms are equally urgent. Some are critical and need immediate attention, while others are less important. By assigning priorities, you can make sure that critical alarms are always front and center, and less important alarms don't clog up the system.
Right, prioritizing alarms can really streamline things. What about archiving performance? How do we optimize how processed data is stored and retrieved?
One way is to set the right archiving cycle for each tag. You don't need to archive everything at the same rate. For example, a temperature sensor that changes slowly might only need to be archived every few minutes, but a flow meter that changes rapidly might need to be archived every few seconds.
So we can tailor the archiving to how our process actually works, which can save space and make retrieval faster. Any other archiving optimization tips?
Data compression is another great technique. WinCC supports several data compression algorithms that can shrink your archives, making storage more efficient and speeding up retrieval.
Okay, data compression can be a big help, especially when we have lots of data. What about user archives? Those are the ones where we can store our own custom data structures, right? How can we optimize those?
One key thing with user archives is the data structure itself. Choose a structure that works well for the kinds of operations you'll be doing. For example, if you're often searching for specific records, using a data structure that supports fast searching, like a binary tree, can make a huge difference in performance.
So the data structure can make or break the efficiency of our user archives. What about reports? Those are essential for analyzing data and making decisions. How can we make them run faster?
One way is to limit how much data the report has to pull. The more data, the longer it takes to generate. Try to focus on the specific data points you need and leave out anything unnecessary.
Okay, so be selective and choose the right data for the report. Any other tips for optimizing reports?
Another trick is to use pre-filtered data sets. If you're often making reports based on the same criteria, you can create a pre-filtered set that only includes the data that meets those criteria. This can drastically reduce the amount of data that needs to be processed when generating the report, making it much faster.
Okay, so pre-filtering data can really speed up report generation. What about scripting performance? How do we choose the right scripting language for our WinCC applications?
WinCC supports two main languages, VBS and ANSIC. VBS is generally easier to learn, but ANSIC is faster, especially for heavy calculations or data manipulation. If speed is your top priority, go with ANSIC for your important scripts.
So there's a trade-off between ease of use and performance. Choose the language that best fits your needs. Now, communication is crucial for any automation system. How can we make sure communication between WinCC and our devices is as efficient as possible?
Choosing the right communication protocol is essential. WinCC supports lots of protocols like Profibus, Profinet, and TCP/IP. Each one has pros and cons. The best choice depends on your specific application, things like the type of devices you're using, the distances involved, and the data transfer rates you need.
Right, so choose the protocol that fits the job. What else can we do to optimize communication?
Network configuration is another big one. Make sure your network is set up correctly for WinCC communication. This includes using the right network switches, configuring quality of service settings, and minimizing latency.
So a well-tuned network can make a big difference. Any other advice for ensuring smooth communication with our devices?
One thing that often gets overlooked is driver optimization. WinCC uses drivers to talk to different types of devices, and those drivers can affect performance. Make sure you're using the latest drivers for your devices and consider tweaking the driver settings to get the best performance for your application.
Okay, so keeping our drivers updated and tweaking their settings can really help. Wow, we've covered a lot in Chapter 6 Performance Data. I feel like I could teach a class on WinCC performance now. Any final thoughts before we wrap up this chapter?
One thing to remember is that performance optimization is a continuous process. It's not something you do once and then forget about. As your WinCC system grows and changes, you'll need to revisit your optimization strategies and adjust them as needed.
Okay, so performance tuning requires ongoing attention. Any other words of wisdom for our listeners?
Don't be afraid to experiment. Try different techniques, see what works, and have fun with it. Performance optimization can be challenging, but it's also very rewarding.
That's great advice. Okay, we've explored 6 chapters of WinCC v8.0, from the basics to advanced performance optimization. I'm feeling confident about tackling any challenge that comes my way.
That's great to hear. And remember, if you ever hit a snag or need some help, the WinCC community is there for you. There are forums, user groups, and tech support to help you through any tough spots.
It's comforting to know we have that support. Well, I think we've covered a ton of ground in this deep dive, and I'm sure our listeners are eager to put their new WinCC knowledge into practice.
The best way to learn is by doing. Build some projects, play around with the features, and don't be afraid to make mistakes. That's how you become a true WinCC expert.
Time to fire up WinCC and get creative. But before we wrap up, is there anything we could leave our listeners with to think about as they continue their WinCC journey?
Let's challenge them to think about how they can use everything they've learned to solve real-world problems in their industries or areas of expertise.
I like it. So to all our listeners out there, we challenge you to take this knowledge and apply it to your own unique challenges. How can WinCC v8.0 help you improve your processes, make your systems better, and boost your efficiency? We're excited to see what you come up with. And we're back for the final part of our WinCC v8.0 deep dive, ready to put all this knowledge into action.
Absolutely. We've covered a lot of ground, from getting started in documentation to migration, diagnostics, licensing, and even performance optimization.
It's been quite a journey. I feel like I could build a WinCC system from scratch now. But for this last part, let's do something a little different. Instead of just reviewing everything, let's apply it to a real-world situation.
Sounds good. Time to see how WinCC v8.0 can solve real automation challenges.
Okay, picture this. We have to design a WinCC system for a cutting-edge factory. Robots zooming around, conveyor belts humming, machines producing products at lightning speed.
Wow, sounds like a fun challenge. Where do we even begin?
First things first, we need to understand the processes we're going to be monitoring and controlling. What are the key variables we need to keep an eye on? What are the important set points and alarms? What data do we need to log and analyze?
Right, we have to know the process inside and out before we can design the right WinCC solution.
Exactly. Once we have a clear picture of the process, then we can start thinking about the system architecture. Do we need a simple single-user system, a client-server system, or maybe even a redundant system for high availability?
That's a big decision. The architecture we choose affects everything: how we design the WinCC project, how we set up the network, even how we handle licensing.
Okay, let's say we decide to go with a client-server architecture. We'll have a main WinCC server managing the project and the data, and multiple client workstations where operators can monitor and control the process.
That's a very common setup, very versatile. It gives you centralized control with distributed access, which often makes sense for larger facilities.
So now we need to figure out the hardware and software. What kind of server do we need? How much RAM and storage space? Which operating system and WinCC version will we use?
All important questions. We have to choose hardware and software that can handle what we're throwing at it. For example, if we're dealing with a high-speed process with tons of tags, we'll need a powerful server with lots of processing power, memory, and storage.
Okay, let's assume we've figured out the hardware and software. Time to actually build the WinCC project. Where do we start?
We start by creating the process pictures. Those are the visuals that represent our process. We'll use the graphics designer to create dynamic and informative displays showing operators the real-time status of everything, including key variables, alarms, and trends.
So we're creating the interface that operators will use to interact with the system. What are the important things to remember when we're designing these pictures?
Clarity and organization are key. We want to make it easy for operators to see what's going on and make the right decisions. We'll use clear labels, simple symbols, and consistent colors to make the pictures easy to understand.
So it's all about usability, making things user-friendly. What else should we consider?
We also have to think about navigation and interaction. How will operators move between different pictures? How will they control things on the screen? Will they use buttons, menus, other input devices?
Right, we're designing the whole experience, making it easy to navigate and control the process. So what comes after we've created our process pictures?
Then we need to connect those pictures to the real-world data coming from our devices. We'll use the tag management tool to create tags for each variable we want to track and control, and then we'll link those tags to the objects in our pictures.
Okay, so we're connecting our virtual WinCC project to the physical world. How do we make sure communication between WinCC and the devices is reliable and fast?
That's where all that knowledge about communication protocols and optimization techniques comes in handy. We'll pick the right protocol for our application, make sure our network is configured for optimal performance, and use the latest and greatest drivers for our devices.
So we're putting our communication skills to the test. Communication is key, but it's not the only thing that affects performance. What else do we need to consider to make sure a WinCC system runs like a well-oiled machine?
Scripting performance is another big one. If our scripts are slow or inefficient, they can bog down the entire system. We'll use everything we know about scripting, best practices, and optimization to make sure those scripts are lean and fast.
Okay, time to write some high-performance code. What about alarm handling? How can we make sure those critical alarms get noticed?
We'll configure the message system so that alarms are prioritized based on how severe they are. And we'll set up different ways to notify operators, like pop-up messages, sounds, even emails or text messages, to make sure they're alerted quickly to any critical events.
So we're building a comprehensive alarm system, responsive and reliable. What about data logging and analysis? How do we capture and use process data to get insights and improve performance?
We'll configure WinCC's archiving system to log the data we need at the intervals we need. Then we can use WinCC's reporting tools or even other data analysis software to create trends, charts, and reports. That helps us understand how our process is behaving, find areas we can improve, and make smart decisions.
So turning data into actionable insights. Wow, we've covered a lot in this real-world scenario. We talked about the system architecture, hardware, software, creating the pictures, connecting to our devices, optimizing performance, and setting up alarm handling and data logging. What's next?
Time to test and commission the system. We need to thoroughly test everything to make sure it's working as expected, and we'll train the operators on how to use the WinCC interface.
Okay, so putting our system through its paces and making sure it's ready for the real world. Any last words of advice for our listeners as they start working on their own WinCC projects?
Remember, building a great WinCC system is a team effort. Work together, talk to experts, and don't hesitate to ask for help when you need it. And most importantly, have fun. WinCC is a powerful tool that can help you do some pretty amazing things in the world of automation.
Couldn't have said it better myself. Well, that brings us to the end of our WinCC v8.0 deep dive. It's been a fantastic journey. I hope you all enjoyed it.
Absolutely. It's been a pleasure sharing our knowledge and experience with you. We're confident that you're now well-equipped to tackle any WinCC challenge that comes your way.
And to our listeners, thank you for joining us. Keep exploring, keep learning, and keep pushing the limits of what's possible with WinCC v8.0.
Until next time, happy automating.
Welcome to the Deep Dive. Today, we're going to be taking a deep dive into the world of PCS 7 operator stations.
Oh, very cool.
It's like stepping into the control room of a sophisticated industrial process and learning how to use the tools that keep everything running smoothly.
Exactly. Think of it as like a hands-on training session where we'll guide you through all the ins and outs of how to operate this powerful system.
And to make this training as effective as possible, we've structured it just like you would experience it in a real classroom setting. So we're going to start with a clear overview of the topics we'll cover. We'll then, of course, dive into each topic in detail. And we'll wrap up with key takeaways and those frequently asked questions that always pop up during real training sessions.
It's like a personalized PCS 7 boot camp right here in your headphones.
Okay, let's get started by taking a look at the table of contents of our training manual, just to give you a roadmap of what we're going to be exploring today. First up is cybersecurity information. This section emphasizes the importance of having really robust cybersecurity measures in place for your PCS 7 system. It's a reminder that while Siemens provides the building blocks for security, it's ultimately the customer's responsibility to build and maintain that secure fortress around their system.
You're right. It's like having a state-of-the-art security system in your home. The manufacturer provides the hardware and the software, but it's up to you to set the alarm, lock the doors, and really stay vigilant.
Next, we have industrial security. This section takes a closer look at security, but within the larger SIMATIC PCS 7 system. So it's about understanding that the operator station is just one piece of a much larger puzzle, and security needs to be addressed at every level. We'll be exploring those specific security measures and best practices that are relevant to the entire system.
Think of it this way. You wouldn't just secure the front door of your house and leave the back door wide open.
Right.
You need a comprehensive approach to security that covers all the bases, all potential entry points.
Then we move on to the preface. Now, you might be thinking, why are we covering the preface?
Right.
Well, it actually provides valuable information about the purpose of the training, who it's designed for, and where to find additional resources. So it's like getting a lay of the land before we embark on our journey.
Exactly. Like reading the introduction to a book before diving into the story, it helps set the stage, gives you context.
After that, we dive into the PCS 7 OS process mode user interface. So this is where we roll up our sleeves and get hands-on. We'll explore how information is displayed on the interface, how to navigate different areas, and the essential functions that you'll be using day in and day out.
It's like getting behind the wheel of a car for the first time. You need to know where the steering wheel is, the pedals, the dashboard before you can start driving.
And then we have a section on additional documentation. Think of this as your resource library, pointing you to more in-depth materials on specific topics if you want to dig deeper.
Like having a comprehensive encyclopedia at your fingertips, ready to answer any specific questions you might have along the way.
Next, we'll cover system operator inputs. Here, we're going to learn about actions you take that affect the system itself, but not the actual process it's controlling. So it's understanding the difference between like adjusting the thermostat in your house, which is a system input, and actually turning on the furnace, which is a process input.
And this distinction is important because it helps prevent any accidental disruptions. Imagine accidentally shutting down a piece of critical equipment because you thought you were just adjusting a system setting.
After that, we'll explore the functions of the PCS 7 OS in process mode. So this is where we unlock the power of the operator station.
Yeah.
We'll delve into its capabilities, how it visualizes the process, displays critical information, allows you to input commands, and importantly, how it alerts you to any potential issues.
It's like learning to speak the language of the process and understand the tools that you have to keep everything running smoothly.
Our next stop is the graphic system display and operation of process pictures. We'll explore how the system uses graphics to represent complex processes, making it easy to understand what's going on at a glance. We'll break down the information that's displayed, the symbols that are used, and how you interact with the system through these visuals.
It's like learning to read a map. Once you understand the symbols and conventions, you can quickly navigate even the most complex terrain.
Next, we have trend system analysis of processes. Get ready to put on your data detective hat because we're going to dive into analyzing trends, visualizing how process values change over time, and using powerful tools to manipulate data, zoom in, and uncover those hidden patterns.
It's like having a time machine for your process data, allowing you to see how things have changed, identify potential issues, and really make proactive decisions.
Then we'll delve into the message system diagnostics for processes. This is all about understanding the different types of messages that the system generates, how to interpret them, how to prioritize them, and take appropriate actions.
It's like having a direct line of communication with your process, receiving real-time feedback on its health and its status.
Next up is the logging system documenting the process. Here, we'll explore how the system automatically keeps records of what's happening, providing a valuable trail of events that you can use for analysis, troubleshooting, and optimization.
Like having a detailed logbook for your process, tracking everything from routine operations to those unexpected events.
After that, we'll look at the archive system displaying archives. Think of this as the long-term memory of the system, storing historical process values messages, reports for future analysis, and reporting.
It's like having a vast archive of process data ready to be mined for insights and used to improve future operations.
And finally, we'll wrap up our training journey with a diagnostic system determining the plant status. This is where we meet the PCS 7 maintenance station. A really powerful tool for diagnosing issues, performing preventive maintenance, and keeping your plant in tip-top shape.
It's like having a virtual toolbox filled with diagnostic instruments that allow you to monitor the health of your system and address those potential problems before they become major headaches.
So there you have it, a comprehensive roadmap of our PCS 7 operator station training. Now let's jump right in and start with Chapter 1, Cybersecurity Information.
Sounds good. An excellent place to start. Cybersecurity is really paramount in today's interconnected world, and industrial control systems are no exception.
This chapter really hammers home the point that while Siemens provides products with built-in security features, you are ultimately responsible for creating and maintaining a complete security strategy.
Think of it this way. Siemens equips its products with the latest locks and security systems. But you're the one who decides where to install those locks, how to set the alarm, who has the keys.
Picture this.
Yeah.
You're responsible for a critical industrial process. You've got the latest PCS 7 system, but you haven't taken the time to configure the security features properly. What could happen?
Well, you could be leaving your entire process vulnerable to cyber attacks, which could lead to production downtime, financial losses, and even safety risks. It's like leaving your front door unlocked and hoping that no one walks in.
Exactly. So what are some key takeaways from this chapter?
I would say, first and foremost, understanding that cybersecurity is a shared responsibility. Siemens provides the tools, but you need to use them effectively. Secondly, having a comprehensive security concept is essential. And that means identifying potential threats, assessing your vulnerabilities, and implementing appropriate security measures. And finally, staying vigilant and really staying up to date on the latest security threats and best practices.
Okay, here's a question we often hear during training. My plant has a firewall, so we're good on cybersecurity, right?
Not necessarily. A firewall is just one layer of security. You really need a multi-layered approach that includes things like strong passwords, access controls, network segmentation, and regular security audits.
And don't forget about training your personnel.
Right.
Human error is often the weakest link in any security system. Make sure your operators are aware of potential threats and best practices for staying safe. Okay, let's move on to Chapter 2, Industrial Security. This section takes a broader look at security, focusing on that SIMATIC PCS 7 system as a whole.
It's a reminder that the operator station is just one piece of that complex system, and security needs to be addressed at every level, from the field devices to the network infrastructure.
This chapter talks about defense in depth, which sounds pretty intense.
It does.
What does that actually mean in practical terms?
So it's about having multiple layers of security, so that if one layer fails, the others are there to back it up. Think of it like a castle with multiple walls, moats, and guard towers. It's much harder to breach a castle with multiple layers of defense than one with just a single wall.
So it's not enough to just have a firewall.
Exactly. You need a combination of preventative measures, like firewalls and intrusion detection systems, detective measures like security monitoring and logging, and corrective measures like incident response plans.
This chapter also talks about the importance of physical security.
Absolutely. You can have the most sophisticated cybersecurity measures in the world, but if someone can just walk into your plant and unplug a critical piece of equipment, it doesn't really matter.
So make sure your facility is secure, your equipment is protected, and your personnel are trained to be aware of any potential physical security threats. Here's another question that we often hear. What are some common industrial security threats that I should be aware of?
Well, there's a wide range of threats out there. From external hackers who are trying to steal data or disrupt operations to disgruntled employees who might be trying to sabotage the system, you also need to be aware of unintentional threats like operator error or equipment malfunction.
And don't forget about natural disasters.
Right.
A flood, fire, earthquake could really wreak havoc on your system if you're not prepared.
Absolutely.
Okay, let's move on to Chapter 3, Preface.
All right, this chapter is all about setting the stage for your training, providing you with that valuable context and resources.
So this chapter tells us that this training is designed for operators who are responsible for controlling and monitoring processes using PCS 7. It's also a reminder that having access to the right documentation is essential.
It's like having a toolbox filled with all the right tools for the job. You wouldn't try to fix a leaky faucet with a hammer, would you?
So where can you find this valuable documentation?
Well, there are a few key resources, including online help manuals and technical information resources on the Siemens website. You can also access support forums and contact Siemens directly for assistance.
It's like having a team of experts on call ready to answer your questions and help you troubleshoot any issues that you might encounter. Now, let's move on to Chapter 4, PCS 7 OS Process Mode User Interface. This is where we finally get to see what this operator station looks like and how it works.
It's like stepping into the cockpit of a spaceship.
This chapter explains that the user interface has three main areas: the overview area, the work area, and the button area. Let's take a look at Figure 4.1.
Okay. Think of the overview area as your dashboard, giving you a constant snapshot of the entire plant's status.
And the work area is where the magic happens. This is where you'll see process pictures, message lists, and other really important information.
And the button area is your toolkit, providing quick access to those essential functions and commands.
This chapter also talks about the cursor, which changes shape depending on what you're doing. For example, you'll see a control cursor when you can perform an action.
It's like the system is giving you visual cues, guiding you through the interface.
And don't forget about the tooltips. When you hover your mouse over an icon, a tooltip will pop up with a brief explanation.
It's like having a little helper whispering in your ear, explaining what each button does.
Now let's delve into that overview area in a bit more detail.
The command center of your operator station.
Right. It's divided into sections that represent different areas of the plant. And each section has an area selection button that you can click to display the corresponding process picture in the work area. Let's take a look at Figure 4.2.
And remember, those group displays we mentioned earlier, they provide a visual indication of the alarm status for each area.
And of course, you have that all-important message line. This displays the most recent unacknowledged message that really needs your attention.
It's like a news ticker for your process, keeping you informed of any critical events.
Speaking of messages, the overview area also has a dedicated message acknowledgement button that you can click to acknowledge the message that's currently displayed in the message line.
It's like hitting the clear button on your alarm clock.
Another really useful feature is the loop in alarm function. If you click this button while a message is displayed, it'll take you directly to the process picture that's associated with that message.
It's like having a GPS that takes you straight to the source of the problem.
And if you need even more information about the message, you can click on the highest priority messages icon to open a list of all active messages with the highest priority.
Think of it as your prioritized to-do list for managing process alarms.
The overview area also displays the name of the operator station you're currently using.
So you always know which command center you're operating from.
And you can even take a snapshot of the entire screen by clicking the Print Screen Content icon.
Handy for documentation or sharing information with colleagues.
Finally, we have the password and switch user buttons.
These are essential for managing user access and ensuring the security of your system.
Now let's shift our focus to the button area. This is where you'll find those two sets of buttons that we mentioned earlier.
Your trusty toolkit for navigating the operator station and accessing its various functions.
So the first button set is what you'll see when you first log in. Now, did you know that you can actually customize these button sets for each plant?
That's right. It allows for greater flexibility in tailoring the interface to meet your specific needs.
Let's take a look at Figure 4.4 for an example of the first button set.
One of the most important buttons in this set is the one that lets you switch to the second button set.
Think of it like switching from your everyday toolkit to a specialized set of tools for specific tasks.
You'll also find buttons for accessing the message system, displaying picture information, taking screen dumps, and accessing plant configuration information.
Essential functions for monitoring your process, troubleshooting issues, and ensuring the smooth operation of your plant.
And of course, you have the password button for logging in and out.
Security first.
Always.
Now let's take a closer look at that second button set. You can see an example in Figure 4 to 5.
Time to break out the advanced tools.
This set includes buttons for accessing the PCS7 process tag browser, changing the language, opening the BATCH control center, and the root control center, and configuring trend groups.
Powerful functions for managing process data, customizing your interface, and controlling those specific aspects of your industrial process.
And you can also create new users and assign permissions right from this button set.
Very important for maintaining a secure and well-managed system.
And finally, we have the Exit Runtime button. Always remember to exit the system properly when you're finished.
Leaving the cockpit in good order.
This chapter also covers different types of windows that you might see popping up in the work area. You've got pre-configured process windows that contain process pictures, faceplates, or operator controls.
These are your windows into the inner workings of your process.
Then you have pre-configured system windows that might display warnings or instructions.
Think of these as messages from the system itself, keeping you informed and guiding you along the way.
And finally, there are pre-configured system dialog boxes that pop up for specific functions like selecting pictures or generating reports.
These are your interactive tools for performing specific actions within the system.
Okay, that wraps up our deep dive into Chapter 4, PCS7 OS Process Mode User Interface. What are some key takeaways for our listeners?
First, understanding the layout of the interface, the different areas, and how to navigate between them. Second, knowing what the different cursor shapes mean and how to use those tooltips. And finally, being familiar with the functions of the buttons in both button sets.
We get a lot of questions about the tooltips during training. Some people find them helpful, others find them annoying. What are your thoughts on tooltips?
I think they can be very helpful, especially for new users who are still learning the interface. They provide quick and easy access to explanations of the different functions and icons. However, I can see how they might become annoying for experienced users who already know the interface well. The good news is that you can actually disable tooltips if you find them distracting.
Okay, let's move on to Chapter 5, Additional Documentation.
Your one-stop shop for diving deeper into specific aspects of PCS7.
This chapter provides a handy table that lists various resources, like online help manuals, configuration guides. For example, you can find detailed information about engineering the system, configuring the operator station, and even working with faceplates.
It's like having a library at your fingertips, ready to answer any questions you might have about PCS7.
Now let's move on to Chapter 6, System Operator Inputs.
This is where we learn how to interact with the system itself without directly affecting the industrial process.
Exactly. This chapter kicks off by defining what system operator inputs are. Actions that affect the operator station internally, but don't have any direct impact on the actual process being controlled.
It's like adjusting the settings on your car radio. You're not changing the engine's performance, but you are customizing your experience.
And then it provides a helpful table that lists all the different types of system operator inputs you can perform, like logging in, logging off, switching users, exiting process mode.
It's like a cheat sheet for mastering the basic commands of your operator station.
And speaking of logging in, this chapter actually walks you through the process of logging on to process control, using either a password or a smart card.
Multiple ways to access your control center.
And remember those tooltips we talked about earlier?
Yeah.
This chapter reminds us that they're available for function icons in both the overview and button areas, providing quick explanations when you need them.
It's like having a built-in glossary of terms always ready to clarify any confusion.
And for those times when you need a bit more information about a specific picture, you can use the Picture Information button to display a dialog box with details about the picture that's currently displayed in the work area.
It's like reading the label on a complex piece of equipment, getting all the essential details.
Now let's talk about the PCS7 Process Tag Browser.
Okay.
This handy tool allows you to view the states of advanced process library process tags in a table format.
It's like having a spreadsheet that shows you the real-time status of your process variables.
And you can even filter the displayed states by selecting specific areas of the plant or choosing the states you want to see.
It's like having a search function that lets you quickly find the information you need.
You can also use the browser to open faceplates, update the states of the process tags, and even print the table.
A versatile tool for managing and analyzing your process data.
Now remember those server status displays in the overview area. This chapter goes into detail about what those different colors and states actually mean.
It's like learning to read the warning lights on your car dashboard.
For example, green means everything is running smoothly, while red indicates a fault. And a flashing red means the fault hasn't been acknowledged yet.
Important visual cues to help you quickly assess the health of your system.
And if you're working with a redundant system, you'll also see an icon for the status of the archive synchronization. This lets you know whether the archives on the two servers are properly synced.
Ensuring data consistency across your redundant setup is crucial.
Now let's talk about acknowledging messages.
Okay.
This chapter reminds us that you can acknowledge messages in two ways, either in process pictures using the Acknowledge Fault button, or in the message system itself.
Multiple ways to silence the alarms.
And for those situations where you need to silence an external signaling device, like a horn or a light, you can use the Acknowledge Signaling Device function.
Sometimes you need to hit the mute button on those persistent alarms.
This chapter also provides a helpful overview of user hierarchies and permissions in PCS 7. It explains the different default authorization levels and how you can use the user administrator to create new users and assign specific permissions.
It's like setting up the access levels for different personnel in your plant.
And if you're working in a domain environment, this chapter even explains how to assign rights for domain users using SIMATIC Logon.
Integrating your operator station with your domain security infrastructure is essential for maintaining a secure and well-managed system.
Now let's talk about plant configuration monitoring. This chapter explains how you can use the Plant Configuration button to display a picture of the plant configuration that's been set up in the LifeBeat monitoring editor.
It's like having a live map of your entire plant showing the status of all the key components.
And if there's a fault, you'll see that component visually marked in the picture.
It's like having a flashing red light highlighting any problem areas in your plant.
In the unlikely event that the user interface of an OS client malfunctions, this chapter provides guidance on how to react. Typically, this involves restarting the computer, but it emphasizes that the logged-on user needs to have the necessary authorization to trigger a restart.
It's like having a contingency plan for when your control center needs a reboot.
This chapter also covers how to open the BAT-TCH control center if you have SIMATIC BAT-CH installed. You can use this to control and monitor batch processes within your plant.
It's like having a dedicated control panel for managing your batch operations.
And if you have the SIMATIC Route Control client software package installed, you can use the Root Control Center button to open that application as well.
It's like having a traffic control system for managing the flow of materials and products within your plant.
And for those times when you need to switch languages on the fly, this chapter explains how to use the Change Language button to select a different language for the user interface.
It's like having a universal translator built into your operator station.
Now, let's talk about print jobs. This chapter explains how you can use the Reports button to display information about print jobs, such as their status and output device.
It's like having a print queue manager that lets you monitor and manage your print jobs.
And if you need to see a preview of a report before printing it, you can use the Display Print Preview function.
It's like having a proofreader for your reports catching any errors before they go to print.
Finally, this chapter wraps up with a helpful section on displaying and configuring trend groups in the work area.
Remember those trend graphs we talked about earlier? This is where you learn how to customize and display them in your operator station.
And you can even filter the trend groups by tag name or tag comment, which is a really handy feature for finding the specific data you need.
It's like having a powerful search engine for your trend data.
Okay, let's wrap up Chapter 6. What are some key takeaways?
Understanding the difference between system operator inputs and process inputs is crucial to avoid accidental disruptions. Knowing how to acknowledge messages and external signaling devices is essential for managing alarms and ensuring a smooth operation. And finally, being familiar with user hierarchies and permissions is critical for maintaining a secure and well-managed system.
And here's a question we get a lot during training. What happens if I accidentally trigger a system restart without the proper authorization?
Well, best case scenario, the system will simply deny the restart. Worst case scenario, you could potentially disrupt the process or even cause damage to the equipment. That's why it's so important to understand user permissions and make sure that only authorized personnel have access to critical functions.
All right, on to Chapter 7, Functions of the PCS 7 OS in Process Mode.
Time to explore the capabilities of our operator station.
This chapter gives us a great overview of all the different functions you can perform with the PCS7 operator station. It highlights the key areas, including the graphic system for displaying process pictures, the trend system for analyzing trends, the message system for managing alarms, the reporting system for generating reports, and the archiving system for storing data.
Think of it as a user manual that outlines all the features and functionalities of your operator station.
And it also emphasizes the importance of user permissions. Different operators can have different levels of access, which ensures the security and integrity of the system.
It's like having different security clearances for personnel in your plant, ensuring that only authorized individuals can access sensitive information or controls.
Now let's move on to Chapter 8, Graphic System Display and Operation of Process Pictures.
Time to dive into the visual world of process control.
This chapter explains how process information is displayed visually through process pictures, trends, and message pictures. And these process pictures are really the heart of the operator station. They provide a visual representation of your plant and allow you to monitor and control your processes.
It's like having a virtual model of your plant right there on your screen.
And you can use these process pictures to do all sorts of things, like change set points, open and close valves, and acknowledge alarms.
It's like having a remote control for your entire plant.
This chapter also explains how process pictures are organized hierarchically, which helps you navigate through the system and find the information you need.
It's like having a map of your plant with different levels of detail, so you can zoom in and out as needed.
Now let's talk about the different elements that you might see in a process picture. You've got static elements, like pipes and tanks, that don't change.
These are the fixed components of your plant, providing the basic infrastructure.
And then you have dynamic elements, like valves and motors, that can change state depending on the process conditions.
These are the moving parts of your plant carrying out the actual work.
And these elements are represented by all sorts of different symbols and graphics, like trend curves, status displays, and bar graphs.
It's like learning a new visual language, understanding the symbols and their meaning.
Now let's talk about process controls. These are the tools that you use to actually interact with the process, like changing set points or opening and closing valves. And these controls can be either analog or digital.
Analog controls are like dimmer switches, allowing for fine-grained adjustments. Digital controls are like light switches, either on or off.
And to activate a process control, you typically need to click on the corresponding element in the process picture. For example, if you want to open a valve, you'd click on the valve symbol.
It's like pointing and clicking your way through the process.
This chapter also talks about the importance of the message line. This displays the most recent message, such as a warning or an alarm, and it's always visible in the overview area of the operator station.
It's like having a dedicated hotline for critical process information.
And of course, we can't forget about those area selection buttons. These allow you to quickly navigate between different areas of the plant.
It's like having a fast travel system for your virtual plant tour.
This chapter also explains how to acknowledge messages using the dedicated button in the overview area.
It's like hitting the clear button on your alarm clocks.
And if you need to see a list of all messages, including acknowledged ones, you can click the extended message line button.
It's like checking your call history for all incoming messages, even the ones you've already dealt with.
This chapter also introduces the concept of message keys. These are visual indicators that can be configured to represent different types of messages, such as alarms, warnings, or operator prompts.
It's like having a color-coded system for classifying messages, helping you quickly prioritize them.
Now let's talk about navigating between plant areas. This chapter explains how to use those area selection buttons to display different process pictures in the work area.
It's like switching channels on your TV, each channel representing a different area of your plant.
And if an area has a problem, its corresponding area selection button will change color to indicate the alarm status.
It's like having a warning light that tells you which part of your plant needs attention.
Now let's talk about the Picture Tree Navigator. This handy tool allows you to browse through the hierarchy of process pictures and select the one you want to display.
It's like having a file explorer for your process pictures, allowing you to navigate through the folders and files.
And you can also use the Picture Left, Picture Up, Detailed Picture, and Picture Right buttons to navigate through the picture hierarchy as well.
It's like having arrow keys for navigating your visual plant model.
This chapter also explains how to use the group displays to quickly identify the source of an alarm. If a group display is flashing, you can click on it to display the process picture associated with the alarm.
It's like having a heat map that highlights the problem areas in your plant.
This chapter also explains how to work with the loop-in alarm function. which automatically displays the process picture or faceplate related to a message displayed in the message line.
It's like having a detective that automatically takes you to the scene of the crime.
And if there are any messages with the highest priority, priority 16, you'll see a dedicated highest priority messages icon in the overview area.
It's like having a flashing red light that tells you there's a critical issue that needs your immediate attention.
Okay. It's time for a quick knowledge check.
All right.
Imagine you're in the control room and you see a group display flashing red. What does that tell you, and what should you do next?
A flashing red group display indicates that there's an unacknowledged alarm in that area of the plant. So the first step would be to click on that flashing group display to navigate to the relevant process picture. From there, you can investigate the alarm further and take the appropriate action.
That's right. You got it. Now let's dive into the button area in a bit more detail.
Time to explore our toolkit.
This chapter reminds us that there are 2 button sets, and you can switch between them using dedicated buttons.
It's like having 2 toolboxes, one for general tasks and one for those specialized tasks.
And one of the most important buttons in the first button set is the one that displays the incoming alarm list.
It's like checking your inbox for any new messages.
This chapter also explains how to disable and enable messages using the disable messages and enable messages buttons.
It's like having a mute button for your alarm system.
And for those times when you need to quickly find a specific picture based on a process tag, you can use the picture via process tag button.
It's like having a search function for your process pictures.
This chapter also covers the picture via name function, which lets you select a picture from a list of all available pictures in the project.
It's like browsing through a catalog of process pictures. Host speaker.
And for those times when you need to quickly jump back to the previously displayed picture, you can use the previous picture and next picture buttons.
It's like having back and forward buttons for your virtual plant tour.
This chapter also explains how to save and recall screen compositions. A screen composition is basically a snapshot of the current layout of the work area, including all the open windows and pictures.
It's like saving your workspace so you can quickly restore it later.
And you can delete a screen composition using the Delete Screen Composition button.
It's like cleaning up your workspace, deleting old saved layouts.
Now let's talk about operator controls in process pictures.
Time to actually interact with our process.
This chapter reminds us that you can use process controls to adjust automation system values, such as set points, valve positions, and limits.
It's like having a set of knobs and dials for fine-tuning your process.
And these process controls can be accessed either directly in the process picture or by opening a faceplate. A faceplate is basically a specialized window that provides more detailed information and controls for a particular process element.
It's like opening the hood of your car to access the engine controls.
This chapter also explains how to work with block icons and faceplates. A block icon is a graphical representation of a process element in the process picture, and you can click on it to open the corresponding faceplate.
It's like clicking on a shortcut to open a specific program on your computer.
And these faceplates come in different operating modes, like standard view, extended view, and diagnostic view.
Different views for different purposes, just like having different maps for navigating a city.
This chapter also highlights that standardized operator control and display bar that you'll find in most faceplates. This bar provides quick access to common functions like acknowledging messages, locking messages, and changing views.
It's like having a universal remote control for your faceplates.
And speaking of messages, this chapter explains how to acknowledge messages directly from a faceplate using the Acknowledge button.
It's like silencing the alarm clock without leaving your bed.
Now let's talk about performing operator process control actions.
Time to take control.
This chapter explains how to perform both digital and analog value operations. Digital value operations are like switching a light switch, on or off, while analog value operations are more like adjusting a dimmer switch.
Digital, on or off. Analog. A spectrum of possibilities.
This chapter also explains how to use the comment function in a faceplate to document any operator actions or observations.
It's like leaving notes for yourself or other operators explaining why certain actions were taken.
And finally, this chapter wraps up with a discussion of configuring the PCS 7 message system. This involves setting up message classes, defining message text, and configuring message routing.
It's like setting up the rules and procedures for how messages are handled in your plant.
Let's pause here for a moment and think about why documenting your actions in a faceplate is so important. What are some scenarios where this could be really valuable?
Well, imagine there's an issue with the process, and you need to troubleshoot what happened.
Mhm.
Having a record of who made what changes and when can be really valuable in identifying the root cause of the problem. It can also be helpful for training purposes, allowing new operators to see how more experienced operators handle different situations.
And it can help prevent those whoops moments where someone accidentally makes a change and then forgets what they did.
Exactly.
All right, on to Chapter 9, Trend System Analysis of Processes.
Time to delve into the world of data analysis.
This chapter explains how to use the trend system to visualize and analyze how process values change over time.
It's like watching a movie of your process data, seeing how it unfolds over time.
And you can use trend graphs to do all sorts of things like identify trends, spot anomalies, and compare different process variables.
It's like having a powerful tool for understanding the behavior of your process.
This chapter also explains how to control trend groups, which are collections of trend curves that are displayed together. You can use trend controls to manipulate the time frame, zoom in and out, and even calculate statistical values.
It's like having a control panel for your trend graphs, giving you the power to manipulate and analyze the data.
Now, let's talk about the different types of trends. You've got archive tags, which are process values that have been stored in the archive.
It's like looking back in time to see how your process performed in the past.
And then you have online tags, which are real-time process values that are being updated continuously.
It's like watching a live feed of your process data, seeing how it's changing in real time.
And you can even combine archive tags and online tags in the same trend group, which allows you to see how current trends compare to historical data.
It's like having a time machine for your process data, allowing you to compare the past, present, and future.
This chapter also explains how to work with stored trend groups, which are trend groups that have been saved for later use. You can retrieve, delete, or rename these stored trend groups.
It's like having a library of trend groups that you can access whenever you need them.
Now let's talk about creating new trend groups.
Time to build our own data visualizations.
This chapter explains how to use the Load Configure Trend Groups button to open the Trends Online dialog box. And this is where you can create new trend groups.
It's like opening a blank canvas for your trend data.
And you can choose to create trend groups with either archive tags or online tags. If you're using archive tags, you'll need to specify the archives and the time period you want to view. If you're using online tags, you'll need to assign tags to the trends that you want to display.
It's like choosing the ingredients for your data recipe.
And once you've created your trend group, you can customize its appearance by changing the colors, the line styles, and the axis scales.
It's like decorating your data cake.
So you've got all this data at your fingertips. How do you actually use it to improve your process?
That's the million-dollar question. Trend analysis can be used for a wide range of purposes, from identifying bottlenecks in your process to optimizing your control parameters. For example, you could use trend analysis to track the temperature of a reactor over time. If you notice that the temperature is consistently exceeding a certain threshold, you might need to adjust your control settings or investigate whether there's a problem with the reactor itself.
Trend analysis can also be used to predict future performance.
Exactly. By analyzing historical data, you can identify patterns and trends that can help you forecast future behavior. This can be invaluable for things like preventative maintenance and inventory management.
Okay, let's move on to Chapter 10, Message System Diagnostics for Processes.
Time to learn how to speak the language of alarms.
This chapter dives into the message system, which is a critical part of the PCS7 operator station. It's responsible for managing all those messages that are related to the process, including alarms, warnings, and operator prompts.
It's like the nervous system of your plant, transmitting information about its health and its status.
And this chapter starts by giving us a great overview of the message system's functions and features. It explains how messages are generated, how they're routed, and how they're displayed to the operator.
It's like a behind-the-scenes look at how your plant communicates its needs and concerns.
And then it delves into the structure and states of messages, explaining the different components of a message and the various states it can go through.
It's like dissecting a message to understand its anatomy.
This chapter also covers the different message lists that are available in PCS7, such as the incoming alarm list, the acknowledged alarm list, the outgoing alarm list, and the history list. Each list provides a different view of the messages, helping you to prioritize and manage them effectively.
It's like having different folders for organizing your messages.
And then we get into the meat of the message system, message and system behavior.
This is where we learn the rules of engagement for dealing with alarms and other critical messages.
This chapter explains how the system handles repeated, unacknowledged messages. ensuring that you're always aware of persistent issues.
It's like having a reminder system that won't let you ignore those nagging problems.
And if you're working with a system that includes a reference OS, this chapter explains how messages from the reference OS are handled.
It's like coordinating communication between different departments in your plant.
This chapter also covers system messages, which are messages that are generated by the SIMATIC PCS7 system itself, rather than by the process.
It's like getting status updates from the operating system of your plant.
And then we get to the heart of message management, acknowledging messages. This chapter explains how to acknowledge messages in both process pictures and message lists.
It's like signing for a package. You're acknowledging that you've received the message and are taking responsibility for dealing with it.
And it also explains the concept of message priority. Messages with a higher priority are displayed more prominently and may require a higher level of authorization to acknowledge.
It's like having a triage system for your messages, ensuring that the most critical ones are addressed first.
Now let's talk about the different types of messages. You've got process control messages, which are generated by the process control system.
These are the messages that tell you what's happening with the actual process that you're controlling.
And then you have PLC, process control messages, which are generated by the programmable logic controllers that are controlling the process equipment.
These messages provide more detailed information about the status of the individual pieces of equipment in your plant.
And finally, you have operator message classes, which are user-defined messages that can be used to communicate specific information or instructions to the operator.
It's like having a custom messaging system tailored to the specific needs of your plant. It's like having a custom messaging system tailored to the specific needs of your plant.
This chapter also explains how to handle those system messages that are related to errors in system components.
It's like troubleshooting your computer. You need to know how to interpret those error messages so you can diagnose and fix the problem.
Now let's move on to the button set of the message system.
Our toolkit for managing messages.
This chapter explains the functions of the various buttons in the message system button set, which include functions for acknowledging messages, filtering messages, sorting messages, and even displaying additional information about messages.
It's like having a Swiss Army knife for message management.
And then we get into some of the more advanced features of the message system, such as user-defined message filters.
This is where you can really customize the message system to meet your specific needs.
User-defined message filters allow you to create your own criteria for filtering messages. For example, you could create a filter that only displays messages from a specific area of the plant, or messages with a certain priority level.
It's like having a personalized news feed that only shows you the information that you're interested in.
This chapter also explains how to activate and deactivate user-defined message filters.
It's like turning your personalized news feed on or off.
And then we get into the concept of message hiding.
Sometimes you need to declutter your inbox.
Message hiding allows you to temporarily hide messages from the message list. This can be really useful if you're dealing with a high volume of messages and you just need to focus on the most critical ones.
It's like hitting the snooze button on your alarm clock.
This chapter explains the different options for hiding messages, including automatic hiding and manual hiding.
Automatic hiding is like setting up a rule that automatically hides certain types of messages. Manual hiding is like choosing to hide a specific message.
This chapter also covers the concept of alarm shelving.
This is a more advanced form of message hiding that allows you to suppress alarms for a specified period of time.
Alarm shelving can be useful if you know that an alarm is going to be triggered by a planned event, such as maintenance or testing.
It's like setting a Do Not Disturb sign on your door.
This chapter also explains how hidden messages are displayed in the faceplate and group displays.
It's like checking your voicemail for any missed messages.
And finally, this chapter wraps up with a discussion of sorting messages. You can sort messages alphabetically or according to different message blocks, such as the date, time, priority, source, event status, and type.
It's like organizing your emails by sender, subject, or date.
Let's pause here and consider a real-world scenario. Imagine you're an operator in a really busy control room, and alarms are going off left and right. How could you use the message system's features to effectively manage this situation?
Well, the first thing I would do is prioritize the messages based on their severity. You can use the message priority feature to make sure those critical alarms are displayed prominently and demand your immediate attention. And you might also want to use filters to focus on specific areas of the plant or even types of alarms. For example, if you know there's ongoing maintenance in a particular area, you could filter out alarms from that area to avoid distraction.
And what about those less critical alarms that you don't need to address immediately, but you don't want to completely ignore either?
That's where message hiding or alarm shelving can be helpful. You can temporarily hide those messages just to reduce clutter and focus on those more pressing issues. And if you know that certain alarms are going to be triggered by a planned event like a batch startup, you could use alarm shelving to suppress those alarms for a specific time period.
So the message system is really about giving you the tools to manage that flow of information and ensure that you're really focusing on the right things at the right time.
Exactly. It's about taking control of the situation rather than letting the alarms control you.
Right on to Chapter 11. Logging system documenting the process.
Time to learn about the record-keeping side of things.
This chapter explains how the logging system automatically documents those events and messages, creating that permanent record of what happened during the process.
It's like having a black box recorder for your plant, capturing every detail of its operation.
This chapter explains the functions and features of the logging system, including the different types of logs that can be generated and how to configure the logging system to meet your specific needs.
It's like setting up a surveillance system for your plant, recording all those important events.
Why is having a logging system so important? It seems like it might just create a lot of data to sift through.
You're right, it does generate a lot of data, but that data can be incredibly valuable for a number of reasons. First, it provides a historical record of what happened, which can be helpful for troubleshooting problems, identifying trends, and even optimizing your process. Secondly, it can be used for auditing and compliance purposes. It provides evidence that you're operating within those required parameters. And third, it can be used for security purposes, helping you detect and investigate any potential security breaches.
So it's not just about collecting data for the sake of collecting data. It's about having a record that you can use to improve your process, ensure compliance, and even enhance security.
Exactly.
Now let's move on to Chapter 12, Archive System Displaying Archives.
Time to explore those historical records of our process.
This chapter explains how the archive system stores those process values, messages, and reports for long-term analysis and reporting.
It's like having a library of process data preserving that valuable information for future reference.
And this chapter starts by outlining the functions and capabilities of the archive system.
It's like reading the welcome brochure for your data library.
And then it goes into detail about how archiving works with the operator station.
It's like learning how to check out books from the library.
This chapter explains how to display trend graphs and message lists from the archive.
It's like browsing through the shelves of your data library, finding the specific information you need.
And then it covers how archiving works with the process historian and information server. These are more advanced archiving systems that provide greater scalability and performance for large-scale process data storage.
It's like having a climate-controlled vault for your most valuable data.
This chapter also explains how to access and display archive data from the process historian using those various tools, like the Process Historian Management Console, the Information Server web application, and even add-ins for Microsoft Office products.
It's like having different ways to access the information in your data vault.
And finally, this chapter covers exporting data from the archives, which can be useful for further analysis or reporting.
It's like making copies of important documents from your data vault.
So we've got the logging system for short-term data storage and the archive system for long-term storage. What are some scenarios where you might need to access that archive data?
Well, imagine you're trying to optimize a process, and you need to analyze historical data to see how the process has performed over time. Or maybe you're investigating a problem that occurred in the past, and you need to review the logs and the archive data to see what happened. Or you're generating reports for regulatory compliance, and you need to pull data from the archives.
So the archive system really is a treasure trove of information that can be used for a wide range of purposes.
Exactly. It's like having a historical record of your process, which can be invaluable for improving efficiency, ensuring compliance, and making better decisions.
All right, on to our final chapter, Chapter 13, Diagnostic System, Determining the Plant Status.
Time for our checkup.
This chapter introduces the PCS 7 maintenance station, a really powerful tool for diagnosing and maintaining your plant.
It's like having a dedicated team of technicians on call ready to troubleshoot any issues that arise.
This chapter explains the purpose of the PCS 7 maintenance station, highlighting its key features and capabilities.
It's like getting a tour of the maintenance workshop.
It explains how the maintenance station provides a uniform visualization for all those PCS 7 components, using icons to indicate their status and health.
It's like having a dashboard for your entire plant, showing the status of every component at a glance.
And it explains how the maintenance station allows for differentiated access permissions, ensuring that only authorized personnel can access sensitive information or controls.
It's like having different security clearances for different areas of the maintenance workshop.
This chapter also explains how to use the maintenance station to evaluate the status of individual system components, configure field devices, log events, and generate diagnostic screens.
It's like having a comprehensive toolkit for managing and maintaining your plant.
And it explains how to use the loop in HW's infig and loop in PDM functions to switch from faceplates to the hardware configuration tool or the process device manager.
It's like having a direct link to the engineering tools from the operator station.
This chapter also covers displaying field device information on the maintenance station, which requires that a maintenance project be assigned on the engineering station and that the SIMATIC PDM asset service be running.
It's like having access to the technical specifications of every device in your plant.
This chapter also explains how the maintenance station uses icons in the overview area to indicate the status of different plant areas.
It's like having a color-coded map of your plant, showing which areas are healthy and which areas need attention.
So the maintenance station really is a one-stop shop for everything related to plant maintenance.
Exactly. It's a powerful tool that can help you keep your plant running smoothly and efficiently.
Now let's flip over to the index.
Our roadmap to all the key terms and concepts we've covered in this training.
The index is organized alphabetically and provides page references for each entry, making it easy to find the information that you need.
It's like having a GPS for navigating through the vast world of PCS 7 knowledge.
Okay, let's step back for a moment and think about the bigger picture. We've covered a lot of ground today, from the user interface to the diagnostic system. What are some key takeaways for our listeners?
Well, I think the most important takeaway is that the PCS 7 operator station is a really powerful tool that can be used to effectively monitor, control, and maintain your plant. It provides you with a wealth of information and tools to help you optimize your process, ensure safety, and really improve efficiency. But it's also important to remember that the operator station is just a tool. It's the operator's knowledge, skills, and judgment that ultimately determine the success of the operation.
So it's not just about understanding the technology, it's about understanding how to use that technology effectively.
Exactly. It's about having the right mindset, the right skills, and the right tools to be successful.
All right, now for a challenge.
Okay.
Imagine you're training a new operator on the PCS 7 operator station. What are 3 key pieces of advice you'd give them to help them succeed?
First, I'd tell them to take their time and really familiarize themselves with the interface. Don't be afraid to experiment, explore the different features. Second, I'd encourage them to ask questions and seek help when they need it. There are plenty of resources available from online help to experienced operators. And finally, I'd tell them to stay curious and never stop learning. The world of industrial automation is constantly evolving, and there's always something new to discover.
Great advice. Well, that wraps up our deep dive into the world of PCS 7 operator stations.
It's been a pleasure exploring this with you.
It has been a very informative journey, and we hope that you've gained some valuable insights and knowledge that you can apply to your own work. If you have any questions or comments, please feel free to leave them below. And be sure to join us next time for another deep dive into the world of industrial automation.
Until then, keep learning and keep exploring.
Welcome to the Deep Dive. Today, we're going to be diving into the world of industrial data.
That's right.
With the SIMATIC Process Historian.
Yeah.
It's kind of like the ultimate record keeper for your entire plant.
Yeah, it's like building a high-tech, super secure library for all your industrial data. And then having an amazing librarian who can instantly pull any piece of information you need going back years.
Okay. I love that analogy. You had me at librarian.
That's great.
So we're going to be essentially creating a training guide, walking you through how to set this system up, keep it secure, and make sure it stays up to date. Think of it as a deep dive into the installation manual, but with a lot more personality, hopefully.
Yeah, that's right. We're going to make this as painless as possible and even fun as possible. And by the end of this, you'll be able to confidently install and maintain the SIMATIC Process Historian.
Perfect. Now, before we get our hands dirty with the actual installation, let's just take a look at the table of contents for today's training session. We'll start with cybersecurity. Information always a critical topic, especially in the world of industrial automation.
Absolutely. Cybersecurity is paramount. This chapter emphasizes the importance of staying updated with the latest security measures to protect your systems from ever-evolving cyber threats.
Right. Then we'll move on to industrial security, zooming out a bit to look at the bigger picture of safeguarding your entire plant environment, not just your data, but also your personnel and equipment.
Absolutely. This section dives into the concept of defense in depth, a multi-layered security approach that protects your plant like a fortress.
I love that visual. Okay, next up, we'll get practical with system requirements. This is like checking if you have all the right tools and ingredients before you start baking a cake.
Absolutely. We'll make sure you have the necessary hardware, software, and licenses in place before even thinking about installing the Process Historian.
Right, because starting an installation only to realize you're missing something crucial is never fun.
Never fun.
Then we'll roll up our sleeves and dive into the installation chapter itself, walking you through the step-by-step process.
This section will cover various systems like PCS, Neo-PCS7, and WinCC, along with instructions for setting up combined or redundant configurations, just in case one system isn't enough.
Always good to have a backup, right?
Yeah.
And finally, we'll wrap up with installation of the upgrade, because in the world of technology, staying up to date is key.
Absolutely crucial step upgrades often bring enhanced features, bug fixes, improved security, so staying updated is essential.
And this chapter will guide you through that upgrade process, ensuring you're always running the latest and greatest version of the Process Historian with all the latest features and security enhancements.
It's like renovating our data library, keeping it modern and efficient for years to come.
Perfect. So there's our roadmap. Now let's dive deeper into each chapter, starting with
Chapter 1, Cybersecurity Information.
Here's where it gets really interesting, because this chapter emphasizes something I think a lot of people overlook: the shared responsibility of cybersecurity.
It's so important. Yes, Siemens equips their products with security functions, but it's ultimately the customer's responsibility to create and maintain a comprehensive cybersecurity strategy for their specific environment.
Right. Siemens provides the tools, but you're the architect of your own security fortress, so to speak.
That's a great way to put it. It's like buying a state-of-the-art safe. The safe itself is secure, but if you leave the combination lying around or install it in a flimsy wall, it's not going to be very effective, is it?
Definitely not. You have to think about the whole picture. And speaking of things that are often overlooked, Siemens is very adamant about keeping your systems updated. They hammer this point home throughout the manual.
And for good reason. I've actually seen companies neglect updates and end up with vulnerabilities that could have shut down their entire production line. One case involved a legacy system running an outdated version of the Process Historian.
Oh no, what happened?
Well, luckily, we caught it in time during a routine security audit. But this system had a known vulnerability that, if exploited, could have allowed an attacker to remotely access and control critical processes. We're talking potential for production, downtime, financial losses, and even safety hazards.
Oh, wow. That's scary. So what kind of vulnerability was it? Was it something super technical and obscure?
Actually, it was a fairly common type of vulnerability, a buffer overflow. Basically, the software didn't properly check the size of incoming data, which could have allowed an attacker to overwrite memory and execute malicious code.
Yikes. So just by delaying an update, they were leaving the door wide open for a potentially catastrophic cyber attack.
Exactly. And this is not an isolated incident. The outdated software is a prime target for attackers because known vulnerabilities often have publicly available exploits that anyone can use.
Oh, wow. So it's like leaving a blueprint for how to break into your system just sitting out in the open.
Exactly. And it's not just about major software versions. Siemens also emphasizes the importance of applying all security updates and patches as soon as they're available. These updates often address newly discovered vulnerabilities, patching those holes in your security armor before attackers can exploit them.
So it's a continuous process. You can't just update once and think you're good to go. It's about staying vigilant and making sure you're always running the latest and most secure version of the software.
Absolutely. Think of it like regularly changing the locks on your doors. New threats emerge all the time, so you need to keep your defenses up to date.
Okay, so the key takeaway from Chapter 1 is cybersecurity is a shared responsibility, and staying updated is crucial for protecting your system from evolving threats. It's like a constant game of cat and mouse, and you always have to be one step ahead.
Well said. Now let's move on to Chapter 2.
Chapter 2, Industrial Security.
Here's where we zoom out a bit and look at the bigger picture.
Right, we've talked about the why of security, but now let's get more specific. Chapter 2 really dives into the nuts and bolts of protecting your entire plant environment.
Exactly. It's not just about data security anymore. Industrial security encompasses protecting your entire plant, including your personnel equipment and processes, from a variety of threats, including cyber attacks, human error, and even natural disasters.
It's like a holistic approach to security, recognizing that a cyber attack can have real-world consequences far beyond just data loss.
Absolutely. Think about it. A cyber attack on a critical infrastructure system like a power plant or a water treatment facility could have devastating effects on public safety and the environment.
Right. It's not just about protecting data anymore. It's about protecting people's lives and livelihoods.
Exactly. And that's where the concept of defense in depth comes in.
So this is where the castle analogy comes back, right? Multiple layers of defense to make it much harder for attackers to reach their target.
Precisely. Think of it like this. Instead of just having one lock on your door, you have multiple locks, security cameras, motion sensors, and maybe even a guard dog.
You mentioned consistent passwords across systems. Doesn't that contradict best practices for strong, unique passwords for each system?
That's a great question. While it's generally good practice to have unique passwords for different systems to limit the impact of a potential breach in the specific case of the process, historian Siemens actually recommends using the same password across all related systems.
Really? Why is that?
Well, it boils down to the way the process historian interacts with other components, especially the SQL server. Using the same password ensures seamless communication and functionality between these components. Think of it as a necessary trade-off to ensure that all the pieces of the puzzle fit together perfectly.
Okay, so in this case, the priority is on smooth system operation, and consistent passwords are necessary to achieve that.
Exactly. And Siemens emphasizes that you should still choose a strong and complex password, even if it's used across multiple systems. This mitigates the risk of unauthorized access while still ensuring the smooth functioning of the process historian and its related components. It's a balance between security and functionality tailored to the specific requirements of this system.
Interesting. It's a good reminder that security isn't always about following generic best practices blindly, but about understanding the nuances of the specific system you're working with.
Absolutely. Context is everything in security. And speaking of context, let's look at some of the key elements of a defense-in-depth strategy.
Okay, so beyond strong passwords, what else does this defense-in-depth approach involve?
Well, it starts with physical security. This means securing the physical location where your process historian and related systems are housed. Think access control systems, surveillance cameras, and even basic measures like locked doors and windows. Picture number 1 shows a typical setup.
Right. It's about preventing unauthorized physical access to your critical infrastructure.
Exactly. Then you have network security. This involves protecting your network from intrusions and attacks. Think firewalls, intrusion detection systems, and secure network configurations. This is like building a moat around your castle, making it much harder for attackers to even get close. Picture number 2 illustrates a typical network configuration.
So you're essentially creating a secure perimeter around your systems.
Precisely. And finally, you have system integrity. This involves ensuring that your systems are hardened against attacks and that only authorized users have access to them. Think strong passwords, regular security updates, and robust access control mechanisms. This is like fortifying your castle walls and making sure the guards are vigilant. Picture number 3 gives you a schematic overview of the system architecture.
Okay, so physical security, network security, and system integrity. 3 layers of defense working together to create a robust security posture.
Exactly. It's about having a comprehensive approach to security, addressing potential threats at multiple levels. And remember, this is not a one-time effort. Security is an ongoing process that requires constant vigilance, adaptation, and improvement.
Right. You can't just set it and forget it.
Yeah.
You have to stay up to date on the latest threats and vulnerabilities and continually adapt your security measures accordingly.
Absolutely. The threat landscape is constantly evolving, so your security posture needs to evolve with it.
Okay, so Chapter 2 highlights the importance of a holistic approach to industrial security, using the defense-in-depth strategy to protect your entire plant environment from a wide range of threats.
Well said. Now, before we jump into the actual installation, let's make sure we have everything we need.
Right, let's move on to Chapter 3.
Chapter 3, System Requirements.
This is where we check our pantry and make sure we have all the ingredients before we start baking our delicious process historian cake, right?
Exactly. A successful installation starts with ensuring that our system meets the necessary requirements.
So what are the key ingredients we need to check?
We need to look at 3 main things: hardware, software, and licensing.
Okay, let's start with hardware. What kind of machine are we talking about here?
The manual provides detailed tables outlining the hardware specifications for different process historian configurations. It covers things like processor speed, RAM, hard drive space, and network interface requirements.
So it's like checking the recipe to see how much flour, sugar, and butter we need for our cake.
Exactly. And just like with a recipe, using the wrong ingredients or quantities can lead to a disaster.
Right. If you try to bake a cake in a tiny toaster oven, it's probably not going to end well.
Exactly. And the same applies to installing the process historian on a system that doesn't meet the minimum hardware requirements. You might run into performance issues, errors, or even system crashes.
Okay, so hardware checked. What about software? What kind of operating system and other software components do we need?
The manual also outlines the compatible operating systems for the process historian. You'll need a supported version of Windows Server. Additionally, certain software components are required, like the .NET Framework and Microsoft SQL Server. Think of these as essential tools for our baking process.
And just like you wouldn't use a rusty old whisk to bake a delicate cake, you need to make sure you have the correct versions of these software components.
Precisely outdated or incompatible versions can lead to conflicts and errors during the installation process.
Okay, so we've checked the hardware and software. What about licensing?
Ah, yes, the licenses. Just like you need a driver's license to drive a car, you need the appropriate licenses to operate the process historian and its related components.
So what kind of licenses are we talking about here?
You'll need licenses for the process historian itself, as well as licenses for the Microsoft SQL Server and any other software components you're using.
And these licenses can be purchased directly from Siemens, right?
Exactly. Siemens offers various licensing options to suit different needs and deployment scenarios.
Okay, so hardware, software, and licensing, the three essential ingredients for a successful process historian installation.
Absolutely. Now, before we move on, I want to highlight a couple of additional considerations that are often overlooked but are crucial for a smooth installation.
Okay, what are these often overlooked considerations?
Firstly, you want to ensure consistent passwords across all systems involved in the process historian setup.
So we're back to the consistent password discussion.
Exactly. While it might seem counterintuitive from a general security standpoint in the context of the process historian, using the same password for the process historian server, SQL server, and other related components is crucial for seamless communication and functionality.
Right, it's a necessary trade-off to avoid any hiccups during the installation or operation of the system.
Precisely. And remember, you should still choose a strong and complex password, even if it's used across multiple systems. This mitigates the risk of unauthorized access while still ensuring everything works together harmoniously.
Okay, consistent passwords checked. What's the other consideration?
Avoid changing the computer name after you've installed the process historian. This seemingly minor detail can actually cause major headaches down the line.
Really? Why is that?
Well, the process historian, especially its interaction with the SQL server, relies on specific names and configurations to function correctly.
Yeah.
If you change the computer name after installation, you're essentially breaking those links, which can lead to errors and unexpected behavior.
So it's like renaming a file that a program is actively using. It can cause things to break.
That's a great analogy. It's best to stick with the original computer name throughout the life cycle of your process historian system to avoid any potential complications.
Okay, so choose a good name for your computer at the beginning and stick with it.
Exactly. Think of it as giving your process historian a permanent identity.
Okay, so Chapter 3 is all about being prepared. Checking the hardware, software, and licensing requirements, and making sure we address those often overlooked considerations like consistent passwords and computer names.
Exactly. It's about laying a solid foundation for a successful installation.
Perfect. Now I'm ready to get my hands dirty. Let's move on to the main event.
Chapter 4, Installation.
This is where the rubber meets the road. Let's dive into the actual step-by-step process of installing the process historian for different Siemens systems.
That's right. We'll start with PCS Neo, then move on to PCS 7 and WinCC. We'll also touch on some specialized configurations like combined setups and redundant systems.
Okay, I'm ready. Let's start with PCS Neo. Walk me through the process.
All right, for PCS Neo, the installation process involves a few key steps. First, you need to configure the target computer in the administration console before you even begin the manual installation.
So it's a bit like setting the stage before the main act.
Exactly. The administration console is a central management point for your PCS Neo system, and configuring the target computer beforehand ensures that it's properly recognized and integrated into the system. Think of it as introducing the new kid on the block to everyone else before the party starts.
Okay, that makes sense.
Oh.
How do we go about configuring the target computer in the administration console?
The manual provides detailed instructions, but it essentially involves these steps. First, you install the AC agent on the target computer. This agent acts as a communication bridge between the target computer and the administration console. Then you add the process historian server to the console, creating a representation of it within the PCS Neo environment. Next, you create a certificate for the process historian server, ensuring secure communication within the system. After that, you connect the computer to the UMC domain, integrating it into the central management structure of PCS Neo. Then you determine the inventory data for the target computer, essentially creating an inventory of its hardware and software resources. Finally, you update the distribution of the configuration, ensuring that all the changes you've made are propagated throughout the PCS Neo system.
Wow, that's quite a few steps just to configure the target computer. Is there a diagram or illustration in the manual that shows this process visually?
Yes. Picture number 4 provides a helpful flowchart outlining these steps and their sequence. It can be really useful for visualizing the process and ensuring you don't miss any crucial steps.
Okay, so we've meticulously configured the target computer. What happens next?
Now the fun part begins installing the SIMATIC PCS Neo Process Historian Server software module. You do this through the PCS Neo setup program. It's a fairly straightforward process, guided by an installation wizard.
So it's like following a recipe step by step.
Exactly. The wizard will prompt you for various inputs like user information installation paths and confirmation of system settings, changes. Just follow the on-screen instructions and you'll be good to go.
Okay, so we've launched the PCS Neo setup. We're following the wizard.
And once the installation is complete, the system will automatically restart. After the restart, you'll be greeted by the Database Installation Wizard, which will guide you through the process of configuring the Process Historian database. This is where you specify details like the database name, storage location, and user accounts and permissions.
So it's like setting up the library shelves and cataloging system for our Process Historian library.
A great analogy. The Database Installation Wizard ensures that the Process Historian has a dedicated and properly configured database to store all those valuable process data records.
Okay, so we've successfully installed the Process Historian server software and configured the database. Are we done with the PCS Neo installation?
Almost. There are a couple of optional steps you might want to consider depending on your specific needs. For example, you can install the Process Historian client software on other machines that need to access historical data.
So it's like setting up reading desks for other users of our Process Historian library.
Exactly. The Process Historian client provides a user-friendly interface for querying, analyzing, and visualizing the historical data stored on the Process Historian server.
Okay, and what's the other optional step you mentioned?
You can also install the Process Historian web server component. This allows you to access the Process Historian data and functionality through a web browser, providing greater flexibility and accessibility for users who might not have the dedicated client software installed.
Ah, so it's like having an online catalog for our library, accessible from anywhere with an internet connection.
Precisely. The web server component extends the reach of your Process Historian data, making it available to a wider audience within your organization.
Okay, so we've covered the basic installation process for PCS Neo, including the essential steps and a couple optional components. What's next?
Let's move on to PCS 7. Installing the Process Historian for PCS 7 is a bit different, but still follows a similar step-by-step approach.
All right, walk me through it. What's the first step for PCS 7?
You'll start by launching the PCS 7 setup program from the data storage medium, typically a DVD or a network share.
So similar to PCS Neo, we're starting with a dedicated setup program for the PCS 7 environment.
Exactly. Once the setup program is launched, you'll be guided through the installation process by an installation wizard.
Ah, wizards.
Yeah.
Our trusty guides through the world of software installation.
Exactly. The PCS 7 installation wizard will prompt you for various inputs, including user information. You'll need to provide details like your name, organization, and contact information. This information is typically used for licensing and registration purposes.
Okay.
Installation type. You can choose between different installation types, such as typical, complete, or custom. The typical installation includes the most common components, while complete installs everything. Custom allows you to select specific components to install. Choosing typical is a safe bet if you're not sure what you need.
Okay.
And Process Historian Program Package. You'll specifically select the Process Historian Program Package for installation.
So far, so good. What else does the wizard ask for?
You'll also have the option to install additional components like the information server, which we'll talk about more later. And of course, you'll need to accept the license agreements for both the Process Historian and Microsoft SQL Server.
Right, licenses.
Yeah.
Always important to have the legal stuff sorted out.
Absolutely. Once you've reviewed and accepted the license agreements, the wizard will display a series of system settings changes that will be made during the installation. These changes might include things like adding users configuring network settings or modifying system services.
Okay, so it's like a preview of the changes that are about to happen. What do we do next?
The wizard will ask you to confirm that you want to proceed with these changes. Once you confirm, the installation process will begin, and the wizard will display a progress bar showing the installation status.
So it's like watching a loading bar as the files are copied and the system is configured.
Exactly. And just like with PCS Neo, you might be prompted to restart your system several times during the PCS 7 installation process. Be sure to follow these prompts to ensure a successful installation.
Got it. Don't ignore those restart prompts. So what happens after the installation is complete and the system restarts?
Just like with PCS Neo, you'll be greeted by the familiar database installation wizard, which will guide you through the process of configuring the Process Historian database for your specific needs.
Ah, the database setup. Our virtual library shelves are ready for those data records.
Exactly. The database installation wizard ensures that the Process Historian has a dedicated and properly configured database to store all those valuable process data records.
Okay, so we've covered PCS Neo and PCS 7. What about WinCC? Is the installation process similar for that system?
Yes, the installation process for WinCC is quite similar to what we've discussed for PCS Neo and PCS 7, but with a few specific nuances.
All right, walk me through it. What's the first step for WinCC?
You'll start by launching the setup program from the Process Historian/Information Server data storage medium, which is again typically a DVD or a network share.
So similar to the other systems, we're starting with a dedicated setup program for the WinCC environment.
Exactly. After launching the setup program, you'll be prompted to select your desired product language.
Ah, language selection. Important to make sure you're working in your preferred language.
Absolutely. Once you've selected your language, the installation wizard will guide you through the rest of the process.
And I'm guessing this wizard will look familiar. License agreements, component selection system settings, changes, all that good stuff.
You got it. Just like with the other installations, you'll need to accept the license agreements and select the Process Historian Server program package for installation. You'll also have the option to install additional components like the information server if needed.
Okay, so the initial steps are quite similar. What about the system settings changes? Are those specific to WinCC?
Yes, the system settings changes displayed in the wizard will be tailored to the WinCC environment. They might include things like adding users configuring DCOM settings or modifying registry entries specific to WinCC.
Okay, so it's still the same concept, a preview of the changes that will be made during the installation. What happens after we review and confirm those changes?
Once you confirm, the installation process will begin, just like with the other systems. Be prepared for potential system restarts during the installation process.
Got it. Restart prompts are par for the course in software installations. And I'm guessing that once the installation is complete, we'll encounter our old friend, the database installation wizard. Right?
You're absolutely right. The database installation wizard will appear guiding you through the configuration of the Process Historian database, ensuring that your WinCC system is ready to store and manage its historical data.
Okay, so we've covered the basic installation processes for PCS, Neo PCS 7, and WinCC. They all seem fairly similar with some minor variations depending on the specific system environment.
Exactly. And while we've gone through the core installation steps, keep in mind that the manual provides even more granular details and specific instructions for each system. It's always a good idea to have the manual handy as you work through the installation process.
Great advice. Now, before we wrap up this section on installation, I'd like to touch on some more specialized setups. The manual mentions things like combined installations and redundant configurations.
Excellent point. Let's start with combined installations.
Good.
This is where you install both the Process Historian and the information server on the same PC.
Right. We talked about this earlier when discussing system requirements. It's a good option for smaller deployments or when you want to simplify your infrastructure.
Exactly. You can choose to install them as a combined package or install them individually.
So it's like baking a cake and frosting it all in one go.
A delicious analogy. But what if you need a more robust setup, especially for larger deployments where performance and reliability are paramount?
That's where redundant configurations come in, right?
Exactly. Redundancy is all about having a backup system ready to take over if the primary system fails. In the context of the Process Historian, it means having two synchronized servers, a principal, and a mirror constantly replicating data to ensure that no information is lost. Picture number 5 shows a typical redundant setup.
So if one server goes down, the other one can immediately take over without any interruption in data collection or availability.
Precisely. It's like having an insurance policy for your industrial data, ensuring continuous operation and peace of mind.
That sounds incredibly valuable.
It is, and setting up a redundant Process Historian system isn't as complicated as you might think. The manual provides detailed instructions on how to install and configure both the principal and mirror servers, as well as a special component called the Process Historian Witness.
The witness?
Yeah.
That sounds intriguing. What role does it play in this redundant setup?
The witness is like a referee ensuring fairness and continuity in the system.
Okay, I'm intrigued. Tell me more about this witness and how it works.
The witness is a third server that acts as a tiebreaker in case of a communication failure between the principal and mirror server.
So it's like an independent observer that helps determine which server is truly alive and should be considered the active server if there's a disconnect.
Exactly. The witness constantly monitors the communication between the principal and mirror servers. If a communication failure occurs, the witness steps in to determine which server is still operational and has the most up-to-date data. It then instructs the other server to take over as the active server, ensuring a seamless transition and preventing data loss.
That's ingenious. So even if there's a communication hiccup, the witness makes sure that data collection continues uninterrupted.
Precisely. It's a critical component for robust redundancy, adding an extra layer of reliability and peace of mind.
Okay, so we've covered combined installations and redundant setups. What other specialized configurations are there?
Well, there's also the scenario of integrating the process historian with SIMATIC batch.
SIMATIC batch. That's Siemens' powerful batch control system.
Exactly. If you're using SIMATIC batch in your plant, you can seamlessly integrate it with the process historian and information server. Picture number 6 provides a visual representation of this integrated architecture.
So you can essentially capture and analyze historical data from your batch processes as well.
Precisely. This integration allows you to gain valuable insights into your batch operations, optimize recipes, track batch performance, and improve overall efficiency.
Okay, so we've covered the basics of combined installations, redundant setups, and even integration with SIMATIC batch. What else is there to know about these specialized configurations?
Well, within each of these installation types, there might be additional steps or considerations depending on your exact configuration.
Okay, so let's talk about some of these nuances. For example, let's say we're working with a combined process historian and information server setup. What are some specific things we need to keep in mind?
When installing the process historian and information server on the same machine, you need to pay attention to the installation order and component selection. The manual will guide you through the specific steps, but generally you'll install the process historian first, followed by the information server.
So it's like building the foundation of the house before putting on the roof.
A great analogy. And during the installation process, you'll have the option to select specific components for both the process historian and information server. Choose the components that align with your specific needs and intended use cases.
Right. You don't necessarily need to install every single component if you're not going to use them.
Exactly. A customized installation can save you disk space and reduce system complexity.
Okay, so installation order and component selection are key considerations for combined setups. What about redundant configurations? Any special tips for those?
When setting up a redundant process historian system, it's crucial to ensure that both the principal and mirror servers have identical hardware and software configurations.
That makes sense. You want them to be twins so they can seamlessly take over for each other.
Precisely. Any discrepancies in their configurations can lead to synchronization issues and potential data loss. So double-check those hardware specs, operating system versions, and software component installations to ensure perfect symmetry.
Okay. Identical twins it is. Any other tips for redundant setups?
When configuring the redundancy settings, pay close attention to the network adapter settings for the redundancy connection.
Right. The servers need to be able to communicate with each other reliably for the redundancy to work properly.
Exactly. The manual provides detailed instructions on how to configure the network adapters for redundancy, ensuring optimal performance and minimal latency in data replication between the servers.
Okay, network settings checked. What about the witness? Any special considerations for setting up the witness server?
When installing the witness, make sure you choose a server with sufficient resources, especially if you're dealing with a large volume of process data.
Right. The witness plays a crucial role in maintaining redundancy, so it needs to be able to handle the workload.
Exactly. Additionally, ensure that the witness server has reliable network connectivity to both the principal and mirror servers. Any communication disruptions between the witness and the other servers can compromise the redundancy functionality.
Okay, so reliable connectivity for the witness is key. What about installing the process historian with SIMATIC batch? Any special considerations for that integration?
When integrating the process historian with SIMATIC batch, you'll need to install specific components for both systems to ensure seamless data exchange and functionality.
Right. It's like making sure all the pieces of the puzzle fit together.
Exactly. The manual will guide you through the specific components required for this integration, but generally you'll need to install the process historian server and client components along with the information server and the information server BATC reports package.
Okay, so specific components are needed to bridge the gap between the process historian and SIMATIC BANCH.
Precisely. And depending on your specific setup and requirements, you might need to install additional components like the Information Server MS Office add-in package, which allows you to access and analyze process historian data from within Microsoft Office applications.
Okay, so we've covered a lot of ground on specialized installations, from combined setups and redundant configurations to integrating the process historian with SIMATIC BANCH. Any final thoughts on this topic?
Just remember, while the basic installation processes for PCS, Neo-PCS 7, and WinCC are fairly similar, these specialized configurations introduce additional considerations and complexities. It's crucial to carefully review the manual, pay attention to the specific instructions, and don't hesitate to contact Siemens support if you have any questions or encounter any issues.
Great advice. Always better to ask for help than to struggle on your own and potentially make things worse.
Exactly. Siemens has excellent support resources available, and they're there to help you succeed with your process historian installation.
Okay, so we've covered Chapter 4 in detail, exploring the step-by-step installation processes for different Siemens systems and delving into the nuances of specialized configurations.
I think it's safe to say you're well on your way to becoming a process historian installation pro.
I wouldn't go that far, but I definitely feel more confident now than I did an hour ago.
That's what we like to hear. And speaking of confidence, let's talk about ensuring your process historian stays in tip-top shape for years to come.
That's a perfect segue to Chapter 5.
Chapter 5, installation of the upgrade.
Okay, so let's say we've successfully installed the process historian. Everything is running smoothly, data is flowing in, and we're feeling pretty good about ourselves.
That's the feeling we're going for. But the world of technology never stands still, does it?
Nope. It's always evolving, and Siemens is constantly releasing updates to the process historian, adding new features, improving performance, and most importantly, addressing security vulnerabilities.
Exactly. Think of it like taking your car in for regular maintenance. You might not notice any obvious problems, but those oil changes, tune-ups, and software updates keep your car running smoothly and prevent major issues down the road.
So upgrading the process historian is like giving it a digital tune-up, making sure it stays healthy and performs at its best.
That's a great way to put it. Now, before we dive into the specific upgrade procedures, let me highlight a couple of golden rules to keep in mind.
Okay, I'm all ears for those golden rules of upgrading.
Rule number 1, always back up your existing process historian database before starting any upgrade process.
Back up your data. That's a mantra we should all repeat before doing anything remotely risky with our systems.
Absolutely. You never want to risk losing valuable historical data during an upgrade. It's always better to have a safety net in case something unexpected happens. Once you have a secure backup, you can proceed with the upgrade with much greater peace of mind.
Great advice. Okay, golden rule number 1, back up your data. What's rule number 2?
Rule number 2, be mindful of the order of updates, especially if you're also updating your PCS 7 system.
Ah, yes, we touched on this earlier. There's a specific sequence to follow when upgrading both PCS 7 and the process historian.
Precisely. You need to upgrade the process historian server to the corresponding version of the new PCS 7 version before you update the entire PCS 7 plant.
Okay, so upgrade the process historian server first, then proceed with the PCS 7 plant update. Got it. What happens if we don't follow this order?
You risk running into compatibility issues and potential errors. Think of it like trying to fit a square peg into a round hole. The components might not work together properly if they're not at the correct versions.
Okay, that makes sense. So backups and upgrade order 2 crucial things to remember before we even start the upgrade process.
Yeah, absolutely. Now let's talk about some things you should avoid doing during the upgrade process.
Okay, I'm ready for the don'ts of upgrading.
Number 1, do not change the computer names of any machines involved in the process historian system.
Ah, yes, that familiar refrain. Changing computer names can wreak havoc on the system.
Exactly. It can disrupt the connections and configurations that the process historian relies on, potentially leading to errors and even requiring you to uninstall and reinstall components.
So stick with the original computer names throughout the upgrade process. No renaming sprees allowed.
Precisely. Now, don't number 2, avoid changing the storage architecture during the upgrade.
By storage architecture, you mean things like the location of the process historian database or the paths where data is stored.
Yes, that's right. Altering these paths during an upgrade can lead to data loss or corruption. It's best to maintain the existing storage architecture and only modify it after the upgrade is complete if absolutely necessary.
So consistency is key.
Maintain computer names, maintain storage architecture.
Got it. You got it. Consistency and adherence to the instructions are crucial for a smooth upgrade process.
Okay, so we've covered the essential do's and don'ts of upgrading. What's next?
Now let's delve into the actual upgrade procedures. The manual outlines different procedures depending on the version you're upgrading from and the type of system you're using.
Right. It's not a one-size-fits-all process. We need to consider our starting point in the specific environment we're working in.
Exactly. For example, upgrading from a much older version, like 2014 SP3, might require additional steps compared to upgrading from a more recent version, like 2020 or later.
Okay, so the complexity of the upgrade process can vary depending on our starting point. Let's start with a common scenario, upgrading from a relatively recent version, like 2020. What are the key steps involved in that process?
All right, let's say you're currently running version 2020 of the Process Historian, and you want to upgrade to the latest and greatest version while retaining your existing Windows operating system.
That sounds like a pretty standard upgrade scenario. Walk me through the steps.
First, you would upgrade the Process Historian server itself. This usually involves running the setup program for the newer version and following the prompts.
So it's a familiar installation-like process guided by a setup wizard.
Exactly. The wizard will guide you through the process, ensuring that the new version of the Process Historian server is properly installed and configured.
Okay, so we upgraded the server. What happens next?
Next, you would update the Process Historian database using the Database Installation Wizard.
Ah, our old friend, the Database Installation Wizard. It seems like it pops up whenever we're making significant changes to the Process Historian.
It does. The Database Installation Wizard is a crucial tool for ensuring that the Process Historian database is compatible with the new version of the software.
So it might involve schema updates, data migrations, or other database-related tasks to ensure everything is aligned with the new version.
Exactly. The wizard handles all these technical details, making the database update process relatively painless.
Okay, so we've upgraded the server and updated the database. What about redundancy? How does that factor into the upgrade process?
If you have a redundant Process Historian setup, you need to temporarily disable the redundancy before performing the server and database upgrades. This ensures that both the principal and mirror servers are upgraded individually and correctly.
Right, it's all about that temporary break from redundancy to avoid any conflicts or inconsistencies during the upgrade process.
Exactly. Once the individual upgrades are complete, you can then reestablish the redundancy using the redundancy configuration wizard.
Okay, so temporary suspension of redundancy to ensure a clean upgrade for each server.
Got it. Now, after the server database and redundancy are handled, you would then move on to upgrading the PH-ready components on any PCS 7 OS or WinCC stations that are part of your Process Historian system.
Right. Those client components need to be updated as well to ensure they're compatible with the upgraded server and database.
Exactly. Upgrading TH-ready usually involves running the setup program for the new version and following the prompts similar to the Process Historian server upgrade process.
Okay, so it's a multi-stage process. Upgrade the server, update the database, handle redundancy, and finally upgrade the client components like PH-ready. It's all about taking a systematic approach and upgrading each piece of the puzzle in the right order.
Well said. And just like with any software upgrade, it's crucial to follow the instructions in the manual carefully and be prepared for potential system restarts along the way.
Right. Those restart prompts are our constant companions in the world of software upgrades.
They are. But by following the instructions and taking those necessary restarts, you can ensure a smooth and successful upgrade process.
Okay, so we've covered the basic upgrade process for the Process Historian, assuming we're starting for a relatively recent version.
Yeah.
But what if we're dealing with a much older version, like 2014 SP3? Does the process change significantly?
Yes, upgrading from a much older version like 2014 SP3 can be a bit more involved, potentially requiring additional steps and considerations.
Okay, let's walk through that scenario as well, just in case some of our listeners are still running those older versions.
All right, so let's say you're currently running version 2014 SP3 of the Process Historian, and you're ready to make the leap to the latest version.
A big leap indeed. What are the key steps involved in that upgrade journey?
The first step is to upgrade to version 2014 SP3 Update 6. This is an intermediate step that prepares your system for the subsequent upgrades.
So it's like laying the groundwork for the main construction project.
Exactly. Once you're at version 2014 SP3 Update 6, you would perform a full backup of your database.
Backups. We can never emphasize those enough, especially when dealing with major upgrades.
Absolutely. After the backup, you might need to consider replacing any outdated hardware.
Right. Those older systems might not meet the requirements for the latest version of the process historian.
Exactly. You'll want to make sure your hardware is up to snuff before proceeding.
Okay, so upgrade to update 6, back up the database, check the hardware. What's next?
Next, you would install the Windows Server 2022 operating system on all relevant computers.
Ah, a fresh operating system to provide a solid foundation for the latest process historian.
Precisely, Windows Server 2022 is the recommended operating system for the latest process historian versions.
Okay, so fresh operating system installed. What then?
After that, you would install the Process Historian server software itself, choosing the latest version.
So it's finally time to install the star of the show, the latest and greatest process historian.
Exactly. Once the server installation is complete, you would restore the database that you backed up earlier.
Bringing back our precious historical data into the newly upgraded system.
Precisely. And finally, you would upgrade PH-Ready on any PCS 7 OS or WinCC stations, just like in the previous upgrade scenario.
Okay, so it's a more involved process with additional steps like upgrading to an intermediate version, potentially replacing hardware, and installing a new operating system.
It is. But the manual provides clear instructions for each step, guiding you through the process and ensuring a successful upgrade even from those older versions.
That's reassuring to know.
Yeah.
Now, we've talked about upgrading the process historian server, the database, and PH-Ready. Are there any other components that might need to be upgraded?
Yes, depending on your specific setup, you might also need to upgrade the Process Historian OPC-UA server.
Right, OPC-UA. We talked about that earlier. It's that Universal Communication Protocol for Industrial Automation.
Exactly. If you're using OPC-UA to connect the Process Historian with other systems, you'll need to make sure that your OPC-UA server is also upgraded to a version that's compatible with the new Process Historian.
So it's all about maintaining compatibility across all the components involved in the process historian ecosystem.
Precisely. The manual will provide instructions on how to upgrade the OPC-UA server, and it's typically a straightforward process similar to upgrading the other components.
Okay, so we've covered the main components that might need upgrading: the process historian server, the database PH-Ready, and the OPC-UA server. Anything else we should keep in mind when it comes to upgrading?
Yes, there are a few additional tips and considerations that can help ensure a smooth upgrade process.
Okay, I'm always up for more tips and tricks. Lay 'em on me.
First, before starting the upgrade, make sure you have a solid understanding of your current system configuration. This includes knowing the exact versions of all the components you're running, the hardware specifications of your servers, and any custom configurations or settings you might have in place.
Right, it's like having a blueprint of your existing house before you start renovating.
Exactly. Knowing your starting point is crucial for planning the upgrade process and anticipating any potential challenges.
Okay, so thorough system knowledge is essential. What else should we keep in mind?
Next, allocate sufficient time for the upgrade process. Don't underestimate the time it might take, especially if you're dealing with a complex system or upgrading from a much older version.
Right, rushing an upgrade can lead to mistakes and unexpected problems.
Exactly. It's better to plan for more time than you think you'll need and have some buffer in case you encounter any unexpected issues.
Okay, so time management is crucial. Any other tips?
Yes. Test the upgraded system thoroughly before putting it back into production. This includes verifying that all components are functioning correctly, data collection is happening as expected, and any integrations with other systems are working seamlessly.
Right, testing is essential for catching any potential problems before they impact your live operations.
Exactly. It's much better to find and fix issues in a controlled testing environment than to have them pop up unexpectedly in your production system.
Okay, so thorough testing before going live is a must. Any final words of wisdom on upgrading?
Just remember, upgrading the Process Historian is a necessary task to ensure you have the latest features, security enhancements, and optimal performance. By following the instructions in the manual planning carefully and taking a systematic approach, you can make the upgrade process as smooth and painless as possible.
Great advice. I think we've covered a lot of ground on upgrading from the basic principles to specific scenarios and best practices. Now, before we move on to the next chapter, let's take a quick detour and address some frequently asked questions related to upgrading.
Excellent idea. FAQs are always helpful for clarifying common doubts and concerns.
Okay, so here's a question that often comes up. What happens if something goes wrong during the upgrade? Can we roll back to the previous version?
Unfortunately, once you've upgraded the Process Historian, you can't simply uninstall the upgrade and revert to a previous version.
Oh no. So it's a one-way street. Once you upgrade, you're committed.
That's right. That's why those backups we talked about are so crucial. If something goes wrong during the upgrade process, you can restore your system to its previous state using your backup.
Okay, so backups are our safety net in case the upgrade goes sideways.
Exactly. And to minimize the risk of things going wrong, it's always a good idea to thoroughly test the new version in a non-production environment before rolling it out to your live system.
Testing is key. Better to find and fix issues in a safe sandbox than to have them impact your critical operations.
Absolutely. Now, here's another common question. What happens to my system during the upgrade process? Will there be any downtime?
Downtime. The dreaded word in the world of industrial automation.
It is. During an upgrade, the process historian and the management console will be unavailable. This means you won't be able to access historical data or manage the system during the upgrade process.
So some downtime is unavoidable.
Unfortunately, yes. But the good news is that the duration of this downtime is typically relatively short, especially if you're upgrading from a recent version and you've planned the upgrade carefully.
Okay, so it's not like we're talking about days of downtime. More like hours or even minutes in some cases.
Exactly. And to minimize the impact of this downtime, it's always best to schedule upgrades during planned maintenance windows or other periods of low system activity.
Right, that way the downtime is less likely to disrupt critical operations.
Exactly. Now here's one final FAQ related to upgrades. What happens after the upgrade is complete? Does the system automatically come back online?
A question about the recovery process. What can we expect after the upgrade finishes?
Once the upgrade is complete and the system restarts, the applications and services will typically restart automatically, and the process historian management console will be available again.
So it's a self-healing process. We don't have to manually restart everything?
In most cases, no. The system is designed to recover gracefully after an upgrade. However, it's important to note that process data transmission might be temporarily interrupted until the new version is installed on all process historian servers and computers with PH ready.
Right. Those client components need to catch up to the upgraded server before data collection can resume fully.
Exactly. Once everything is synchronized, data transmission will resume as normal. It's just a temporary blip in the data stream.
Okay, so automatic recovery with a potential brief interruption in data collection. Got it. I think that covers the most common FAQs related to upgrading.
Excellent. Hopefully that addressed any lingering doubts or concerns our listeners might have had about the upgrade process.
Now I'm eager to move on to the next chapter, which delves into a topic that's crucial for ensuring high availability and data integrity redundant process historians.
Redundancy. It's like having an insurance policy for your industrial data, ensuring continuous operation and peace of mind, even in the face of hardware failures or other unforeseen events.
That sounds incredibly valuable. I'm ready to learn the ropes of setting up and managing a redundant process historian system.
Excellent. Let's dive into the world of redundancy and explore how it safeguards your precious industrial data.
Sounds like a fascinating journey. Let's get started.
That's right. The process historian and the information server need to be on speaking terms data-wise.
Okay, so how do we make that happen?
Well, this typically involves configuring the connection settings between the process historian and the information server, setting up user accounts and permissions, and defining data access parameters. Picture number 9 highlights the key areas for configuration.
So we're basically playing matchmaker, setting up the communication channels, and defining the rules of engagement for these two systems.
Exactly. It's all about creating a smooth and secure data pipeline between the process historian and the information server.
Now, where do we go to configure all this?
These configuration tasks can be performed through the respective management consoles for the process historian and the information server. The manuals provide detailed instructions and examples to guide you through these steps.
Okay, so we've installed both systems, configured the connection settings, and set up user accounts and permissions. Anything else we need to do before we can start using our combined system?
Yes. One final step is to configure the data sources that the information server will access from the process historian.
Right. We need to tell the information server where to find the data it needs. It's like giving it a treasure map to the process historian's data vault.
Exactly. This typically involves specifying the process historian server name, database name, and other relevant connection parameters.
So we're pointing the information server in the right direction and giving it the keys to unlock the process historian's data treasures.
That's a great way to put it. Once you've configured the data sources, the information server can start accessing and processing the historical data collected by the process historian.
Fantastic. So to recap, setting up a combined process historian and information server system involves choosing the installation scenario, installing both systems, configuring the connection settings, setting up user accounts and permissions, and finally configuring the data sources for the information server.
You got it. It's a multi-step process, but the manuals provide clear instructions and guidance, making the configuration relatively straightforward. The end result is a powerful and integrated solution for industrial data management analysis and reporting.
That sounds incredibly valuable for any organization looking to gain deeper insights from their industrial data and make more informed decisions.
Absolutely. The combined power of the process historian and the information server unlocks a world of possibilities for optimizing operations, improving efficiency, and driving innovation.
Okay, we've covered the basics of setting up a combined process historian and information server system, but what about managing it on an ongoing basis? Are there any specific tasks or considerations for maintaining this combined setup?
Yes, there are a few key aspects to keep in mind when managing a combined process historian and information server system.
I'm all ears. What are the best practices for keeping this combined system healthy and running smoothly?
First and foremost, you'll want to monitor the health and status of both systems regularly. This includes checking system logs, monitoring resource utilization, and ensuring that all services are running as expected.
So the same principles of proactive monitoring apply to the combined system, just like with any other critical system.
Exactly. The earlier you detect an issue, the easier it is to resolve it and prevent any impact on system availability or data integrity. You can use the respective management consoles for the process historian and the information server to monitor their health and performance.
Okay, so monitoring is crucial.
Mm.
What else should we do to keep our combined system in tip-top shape?
Another important aspect is performing regular backups of both the process historian and information server databases. Even though you might have redundancy in place for the process historian, it's still essential to have backups for both systems for disaster recovery purposes.
Right. Backups are essential for data protection, regardless of whether you have redundancy or not. It's like having a spare tire in your car.
Yay.
You might not need it often, but you'll be glad you have it when you do.
Exactly. Backups provide that extra layer of protection and ensure that you can restore your data in a variety of situations. The manuals provide guidance on how to perform backups for both systems.
So backups are a must. What about upgrades? How do we handle upgrades in a combined environment?
Upgrading a combined process historian and information server system requires careful planning and coordination. You'll need to upgrade both systems to compatible versions following the recommended upgrade paths and procedures.
Right. We need to ensure that both systems are running versions that can work together harmoniously like a well-rehearsed orchestra.
Exactly. The manuals for both systems will provide detailed instructions on how to perform the upgrades and any specific considerations for combined setups. It's crucial to back up your data before starting any upgrades and to test the upgraded system thoroughly before putting it back into production.
So the same principles of careful planning, testing, and adherence to documentation apply to upgrades in a combined environment.
Absolutely. By following best practices and using the provided resources, you can ensure a smooth and successful upgrade process for your combined process historian and information server system.
Okay, I think we've covered a lot of ground on combining the process historian with the information server, from the initial setup to ongoing management and upgrade considerations. It's a powerful combination that allows you to fully leverage your industrial data for analysis, reporting, and informed decision-making.
Indeed, the integration of these two systems provides a comprehensive solution for turning raw industrial data into actionable insights. By understanding the principles of combined setups and following the guidance in the manuals, you can unlock the full potential of your industrial data and drive operational excellence.
Fantastic. Now let's shift gears and talk about a specific communication protocol that plays a crucial role in modern industrial automation, OPC.
OPC-UA. It's like a universal language for industrial automation, enabling seamless communication between different devices and systems, regardless of their manufacturer or platform.
I've heard of OPC UA, but I'm not entirely sure how it works or why it's so important. Can you shed some light on that?
Absolutely. Think of OPC-UA as a universal translator for industrial automation systems. It allows different devices, machines, and software applications to communicate with each other, regardless of their brand operating system or underlying technology.
So it breaks down the communication barriers between different systems, creating a more unified and interoperable industrial environment. It's like having everyone speak Esperanto, so to speak.
Exactly. In the past, connecting different systems often required complex custom integrations and proprietary protocols. OPC UA simplifies this process by providing a standardized and secure way for systems to exchange data and information.
That sounds like a game changer for industrial automation. No more wrestling with incompatible systems or deciphering cryptic proprietary protocols.
Precisely, OPC UA promotes interoperability, reduces integration costs, and simplifies data exchange across the entire enterprise.
Okay, I'm starting to see the value of OPC UA. But how does this relate to the SIMATIC Process Historian? Can it communicate using OPC UA?
Absolutely. The process historian is fully OPC UA enabled, allowing it to seamlessly connect and exchange data with other OPC UA compliant systems.
So it can both send and receive data using this universal language of industrial automation. It's like having a multilingual process historian that can converse with a diverse range of devices and systems.
Exactly. This OPC UA capability makes the process historian a highly flexible and interoperable component in your industrial automation infrastructure.
Okay, I'm convinced OPC UA is a powerful enabler for the process historian, enhancing its connectivity and data sharing capabilities. But how do we actually set up and configure OPC UA communication with the process historian? What are the steps involved?
The manual provides detailed instructions for configuring OPC UA communication with the process historian, and we'll walk through the key concepts and considerations together.
Great, I'm ready to learn the ropes of OPC UA configuration. Let's get started.
Excellent. The first step is to ensure that you have the necessary software components installed. This typically includes the Process Historian OPC UA server software, which is often included as part of the Process Historian installation.
So we need a dedicated OPC UA server component for the process historian to act as an OPC UA server. It's like giving our process historian a special badge that identifies it as an OPC UA speaker.
Exactly. This component provides the necessary functionality for the process historian to expose its data and services via OPC UA.
Okay, so we have the OPC UA server component installed. What's next?
Once the software is in place, you'll need to configure the OPC UA server settings using the Process Historian Management Console. Picture number 10 shows the OPC UA configuration section.
Right, our old friend, the Management Console.
Yeah.
It seems like we spent a lot of time in there configuring various aspects of the process historian.
It is the central command center for the Process Historian. Within the Management Console, you'll find a dedicated section for OPC UA configuration. This is where you'll define settings like the server endpoint address security policies, user authentication, and other parameters related to OPC UA communication.
So we're essentially setting the ground rules for how the process historian will interact with other OPC UA devices and systems. It's like establishing diplomatic relations and setting up communication protocols.
That's a great analogy. You're defining the OPC UA communication framework, ensuring security, defining access control, and configuring other aspects of the data exchange process.
Okay, so we've configured the OPC UA server settings in the Management Console. Are we done? Can our process historian now start talking OPC UA with other systems?
Almost. There's one more crucial step, configuring the OPC UA client applications that will connect to the Process Historian server.
Right, we need to teach the other systems how to speak the process historian's OPC UA dialect.
Exactly. Each OPC UA client application, whether it's a data analytics tool, a visualization platform, or another system, will have its own configuration settings for connecting to OPC UA servers.
So we need to provide those client applications with the necessary connection details for the process historian's OPC UA server. It's like giving them the process historian's phone number and access code.
Precisely. This typically involves providing the server endpoint address security credentials and other relevant parameters to the client application.
Okay, so we're giving the client applications the roadmap and the key to access the process historian's data through OPC UA.
Exactly. Once the client applications are properly configured, they can establish secure OPC UA connections with the process historian and start exchanging data seamlessly.
Fantastic. So to recap, setting up OPC UA communication with the process historian involves installing the necessary software components, configuring the OPC UA server settings in the Management Console, and finally configuring the OPC UA client applications that will connect to the server.
Precisely. It's a multi-step process, but the manual provides clear instructions and guidance, and the various configuration tools make the setup relatively straightforward. The end result is a highly interoperable and connected process historian system capable of seamless data exchange with a wide range of OPC UA compliant devices and systems.
That sounds incredibly powerful. OPC UA truly unlocks the potential for integrated and data-driven industrial automation. It's like breaking down the language barriers between different nations, allowing them to collaborate and share knowledge freely.
Absolutely. By embracing OPC UA, you're creating a more unified and interoperable industrial ecosystem where data flows freely and securely between different systems, enabling greater insights, efficiency, and innovation.
Okay, we've covered the basics of setting up and configuring OPC UA communication with the process historian. But what about managing and maintaining this OPC UA connectivity on an ongoing basis? Are there any specific tasks or considerations we should be aware of?
Yes, there are a few key aspects to keep in mind when managing OPC UA communication with the process historian.
I'm all ears. What are the best practices for ensuring smooth and reliable OPC UA connectivity?
First and foremost, you'll want to monitor the health and status of your OPC UA connections regularly. This includes checking for any communication errors, monitoring data transfer rates, and ensuring that the connections are stable and reliable.
So it's all about proactive monitoring and early detection of any potential issues, just like with any other critical communication channel.
Exactly. The earlier you detect a problem, the easier it is to resolve it and prevent any disruption in data exchange or impact on other systems.
What tools or techniques can we use to monitor the health of our OPC UA connections?
Both the Process Historian Management Console and the OPC UA client applications typically provide monitoring capabilities for OPC UA connections. You can view connection status, data transfer statistics, and event logs to gain insights into the health and performance of your OPC UA communications.
So we have multiple vantage points for monitoring OPC UA connectivity, both on the server side and the client side. It's like having a network of observers keeping an eye on those communication channels.
Exactly. This multifaceted monitoring approach helps ensure comprehensive coverage and timely detection of any potential issues.
Okay, monitoring is crucial. What else should we do to keep our OPC UA connections healthy and running smoothly?
Another important aspect is maintaining good security practices for your OPC UA communications. This includes using strong passwords, implementing appropriate authentication and authorization mechanisms, and keeping your OPC UA software up to date with the latest security patches.
Right, security is paramount, especially when dealing with critical industrial data and systems. It's like protecting a valuable treasure. You need multiple layers of security to keep it safe from intruders.
Absolutely. OPC UA provides robust security features, but it's crucial to configure and manage them properly to protect your systems from unauthorized access or malicious attacks.
So it's about combining the inherent security features of OPC UA with sound security practices and policies. It's like building a fortress with strong walls, vigilant guards, and a well-defined access control system.
Exactly. By taking a holistic approach to security, you can ensure that your OPC UA communications are both reliable and protected from potential threats.
Okay, we've covered monitoring and security. Any other considerations for managing OPC UA connectivity on an ongoing basis?
Yes, one more aspect to keep in mind is scalability. As your industrial automation infrastructure grows and you connect more devices and systems using OPC UA, you might need to adjust your process historian configuration to handle the increased data volume and traffic.
So we need to think about how our OPC UA infrastructure will scale as our needs evolve. It's like planning for a growing city. You need to make sure the roads and infrastructure can handle the increasing traffic.
Precisely. This might involve upgrading hardware, optimizing server settings, or implementing load balancing techniques to distribute the OPC UA traffic across multiple servers.
It's about planning for growth and ensuring that our OPC UA infrastructure can handle the increasing demands of our connected systems. It's like building a bridge that can support not only the current traffic, but also the anticipated traffic in the future.
Exactly. By taking a proactive approach to scalability, you can avoid performance bottlenecks or data loss as your OPC UA ecosystem expands.
Okay, I think we've covered a lot of ground on managing and maintaining OPC UA communication with the process historian. From monitoring and security to scalability, we've explored many facets of ensuring smooth and reliable OPC UA connectivity.
Indeed, we've discussed the importance of proactive monitoring, sound security practices, and scalability considerations. By implementing these best practices, you can unlock the full potential of OPC UA and create a highly interoperable and data-driven industrial automation environment.
Fantastic. Well, I think that concludes our deep dive into the world of the SIMATIC Process Historian. We've covered a wide range of topics from the basics of installation and configuration to advanced features like redundancy and OPC UA communication.
Indeed, we've explored many facets of this powerful industrial data management system, gaining insights into its capabilities, best practices, and the value it brings to industrial automation.
Hopefully, you now have a much deeper understanding of the SIMATIC Process Historian and how it can help you harness the power of your industrial data.
We encourage you to explore the provided documentation further and experiment with a process historian to discover how it can transform your operations and empower you to make data-driven decisions.
And remember, this deep dive is just the beginning of your journey with the SIMATIC Process Historian. There's always more to learn and explore. It's like embarking on an exciting adventure. The more you explore, the more you discover.
As you gain experience and delve deeper into its capabilities, you'll discover new ways to leverage this powerful tool to optimize your processes, enhance efficiency, and drive innovation in your industrial environment.
That's a great point. The learning never stops. And the more you explore the process historian, the more value you'll unlock from your industrial data.
Absolutely. So keep experimenting, keep learning, and keep pushing the boundaries of what's possible with the SIMATIC Process Historian.
Well said. That's all for this deep dive. We hope you found it insightful and informative.
Until next time, keep diving deep into the world of knowledge and discovery.
All right, ready to master the SIMATIC information server. But maybe that installation manual is a little intimidating.
Yeah, it can be a bit daunting.
Well, we're here to break it down for you step by step, make this whole setup process a lot less stressful.
Think of us as your guides, your coaches, getting that information server up and running.
Love that. Okay, so let's start with a quick look at what this manual covers, kind of like getting a preview, right?
Absolutely, like a roadmap. So Chapter 1 is all about cybersecurity. That's critical, especially these days.
Super important.
Then we move on to Chapter 5. That's about system requirements. Got to make sure your hardware and software can actually handle the information server before we even start.
Good point.
And then the fun part, Chapter 6, installation of the information server. We'll go through all those details, getting the server installed and configured.
Sounds good.
And then Chapter 9, that's all about upgrading the information server. So if you've already got it running but want to move to a newer version, that's the chapter for you.
Perfect. So we've got security, system checks, the main installation, and upgrades. What else?
Well, every good training plan needs some troubleshooting tips, right? That's where the FAQ section comes in. We'll highlight some of the most common issues you might run into during your information server journey.
Great idea. I'm feeling a lot more confident now that we've got this roadmap. Let's jump into Chapter 1, cybersecurity information. Expert speaker, when we're talking about industrial data, why is cybersecurity such a big deal?
Well, in industrial environments, cybersecurity breaches, those can have really serious consequences, like disruptions to operations, even safety issues, not to mention financial damage.
Right, high stakes.
Yeah, and what's interesting about this chapter is that it goes beyond just the information server itself. It really emphasizes this idea of a holistic industrial cybersecurity concept.
So it's not just locking down the information server, it's about the entire network and everything connected to it.
Exactly. It's a system-wide approach. And Siemens, they're really big on having those strong firewalls in place, segmenting your network, keeping your software up to date. They even point to their industrial cybersecurity website if you want more information.
Great resource. Speaking of requirements, let's move on to Chapter 5. What are some things we should check before we even think about installing the information server?
Well, before you even start, got to make sure your system can handle it, Talking about RAM. Disk space, the right operating system.
It's like checking if your computer's got the horsepower before you load up a demanding game.
Exactly. And the manual actually specifies that you need at least 64 gigabytes of RAM if you're running both the process historian and the information server on the same system.
Wow, 64 gigabytes. Why so much?
Well, the information server is designed to process tons of data in real time, and it's doing some pretty complex calculations and analyses. All that takes some serious computing power, and RAM is a big part of that.
Makes sense. So besides RAM, what other system requirements are we looking at?
Your operating system is important. The information server is only compatible with certain versions of Windows Server. And of course, got to think about the software side too. You'll need a compatible version of SQL Server for the database, and you got to make sure your web browser is properly configured.
So a bunch of things to check off our list before we even get started with the installation.
Always better to be prepared.
Absolutely. All right, now for the main event, Chapter 6, installation of the information server. Let's get this server installed.
Time to get our hands dirty. Now, the first step is starting the setup. But here's the thing. There are different procedures depending on if you're working with PCS 7 or PCS Neo. If you're using PCS 7, you'll launch the setup from the PCS 7 DVD. But if you're with PCS Neo, you start it from the SIMATIC automation tool.
Okay, so first we figure out which path we're taking, PCS 7 or PCS Neo.
Right. Once you've started the setup, it'll walk you through a bunch of steps. The manual's got detailed instructions, but don't worry, we're going to highlight the key parts and point out any potential gotchas along the way.
Okay, so let's walk through those key procedures step by step. What's the first thing we do after launching the setup?
Well, the first few steps are pretty standard, like choosing your language, reading the instructions, accepting the license agreement. But here's where it gets interesting. When you get to selecting the installation content, you got to pay close attention.
What kind of options are we talking about here?
Well, you can install just the information server by itself, or you can install it with other components like IS-Ready. That's a key part for connecting to data sources like WinCC and PCS 7.
This is kind of like choosing which features you want in your car.
Exactly. You got to pick the options that make sense for your specific system, how you plan to use the information server.
Makes sense. So we've picked our installation options. What's next?
The setup will start copying files, configuring everything. Might take a few minutes, so be patient. And then once it's done, you'll need to restart your computer.
Classic IT solution. Restart your computer.
Always a good idea. Lets all the changes take effect.
All right, so we've restarted. What's the next step in getting the information server up and running?
Now we get to configure it. Setting up things like the service account, virtual directories, and security settings. It might sound a little intimidating, but the manual's got your back, and we'll be here to guide you through it.
Okay, I'm ready to dive into configuration, but I think we've covered a lot of ground already. Let's pick up where we left off next time.
Sounds good to me. We'll tackle configuration and more in the next part of our deep dive, so stay tuned.
All right, welcome back. Last time we talked cybersecurity, system requirements, and even kicked off the installation process for the SIMATIC information server. Now it's configuration time.
Right. Configuration is all about fine-tuning that information server to your specific needs, your environment.
Okay, so where do we start? The manual mentions something about Windows features being enabled automatically. What's that all about?
Yeah, so the information server needs certain Windows features to run properly. Think of it like the foundation the server is built on. Things like .NET extensibility, ASP.NET, ISAPI extensions.
Those sound pretty technical. Can you break those down a bit?
Sure. .NET extensibility, that lets developers add custom functionality, basically making the information server even more powerful.
Okay, I see.
And ASP.NET. That helps create and run web applications, which is how you interact with the information server.
Got it.
And then you've got IAPI extensions. Those handle the communication between the server and other applications.
So they're kind of like the behind-the-scenes crew, keeping everything running smoothly.
Exactly. And the good news is the information server setup, it automatically enables these features during configuration. You don't have to do it manually.
That's a relief. But what if that automatic activation doesn't work for some reason?
The manual does mention you might get a message if it fails. If that happens, you can manually enable those features through the Windows control panel, but usually the automatic process works just fine.
All right, good to know. So those Windows features are taken care of. What's next in configuration?
Next, you'll see this dialog box. It's called SIMATIC Web Configurator. This is where you configure the web server component of the information server. It's called Internet Information Services, or ISIS.
ISIN. Okay, I've heard that before, but could you give me a quick refresher? What does it actually do?
Sure. Think of ISIS like a virtual receptionist for your information server. It handles all that incoming and outgoing web traffic, making sure the right information gets to the right place. It's a big part of how you access and interact with the information server through your web browser.
Got it. So ICE is like the gatekeeper, making sure everything flows smoothly.
Exactly. And in this ISIC configuration dialog box, you'll start by giving your information server application a name. You can use the default information server or pick something a little more descriptive, whatever you like.
So we're giving our server a unique ID, basically. What else do we need to configure in this dialog box?
Next step is creating a virtual directory. Think of it as a special folder on the web server dedicated to the information server application. It's where all the files and resources for the information server live.
Like a filing cabinet labeled information server.
Exactly. And the manual recommends sticking with the default settings for that virtual directory.
If it ain't broke, don't fix it.
Right. Now, this is important. Changing the service account. Here you specify which user account the information server uses to run its services. It's a security thing.
So we're giving the information server its own login credentials.
Precisely. And those credentials, they need specific permissions. The manual is very clear on this. The user account has to be a local administrator on the computer and a system administrator on the SQL server.
Lots of admin rights. Sounds like security is a big priority.
Absolutely. In an industrial environment, you don't want just anyone messing with your data. Got to make sure the information server is running with the right level of access and control.
Okay, so service account setup. What else do we need to configure in this ISA dialog box?
That's pretty much it for this dialog box. The next step, you guessed it, restart the computer.
Restart the computer, the universal fix for everything.
You could say that. Let's those changes take effect.
All right, so we've enabled those Windows features, configured ISAs, and set up that service account. What's next on our configuration checklist?
Before we jump into the database installation, gotta talk about browser settings. The information server, it relies heavily on a web browser for configuration and management, so gotta make sure your browser is ready to work with the server.
Browser settings.
Huh.
Interesting. Why are those so important for the information server?
Well, imagine trying to access a website, but it's blocked by your browser's security settings. That's kind of what can happen if your browser isn't configured properly for the information server. You might get errors, have trouble accessing features, or even see performance issues.
So we need to make sure the browser's not getting in the way.
Exactly. Section 6.5 of the manual, it goes into all the details about the specific browser settings you need to adjust. And the first thing to remember, don't change any of these settings until after you've successfully commissioned the information server. That's key.
Got it. Commission first, settings later. So once that initial setup's done, what kind of browser settings are we tweaking?
One important setting is Enable Protected Mode. You'll need to disable this for the security zone where your information server web application is located. Protected mode, it's designed for security, but it can sometimes interfere with how the information server interacts with the browser.
Disabling security features always makes me a little nervous, but I trust you.
I get it, but in this case, it's necessary to make sure the browser and the information server can communicate properly. Don't worry, there are other security measures in place.
Okay, so we've disabled protected mode. What's next?
Next, you add the information server web page to your browser's list of trusted sites. This tells your browser, hey, this website is safe, you can trust it.
Giving it a VIP pass.
Exactly. And to do this, you'll need to find the common name of the X.509 certificate for your information server. The manual's got instructions on how to find this in the ICS Manager. Sounds technical, but it's pretty straightforward.
Taking notes. So we've disabled protected mode, added the information server to our trusted sites. Anything else?
One more. You'll want to adjust the user authentication setting. In your browser security settings, you need to select Automatic Logon with username and password. This lets you automatically log into the information server web application without having to enter your credentials every time.
The convenience of automatic login. Anything else we should know about these browser settings?
Yeah, if you're using an HTTP proxy server, there are a few extra steps. You'll need to add the information server's FQDN name to your proxy exceptions list.
Wait, FQDN, you mentioned that earlier. Can you remind me what that is again?
Sure. FQDN stands for Fully Qualified Domain Name. It's like the complete address of your information server on the network. Includes the host name and the domain name.
Okay, right. Thanks for the reminder.
Yeah.
So we're adding the FQDN to that exceptions list, so the proxy server doesn't mess with the communication between the browser and the information server.
Exactly. Like telling the proxy server, hands off this website, let it through.
Okay, that makes sense. So we've tackled the essential browser settings. What's next in our information server setup journey?
Now we're ready for the database installation. This is where the information server is going to store all its data, configurations, everything it needs.
Okay, excited to get this database set up. Where do we begin?
Section 6.6 of the manual is our guide for this. First, open your web browser and go to the information server web application. You can type in the URL you defined during configuration or use that shortcut on your desktop.
Shortcuts, always a good thing. So once we're in the web application, what's next?
You'll need to select a Microsoft SQL Server instance for the information server to use. This is where those database files will live. You've got a couple of options here.
Options are good. What are our choices?
You can enter a specific database file path. That way, you choose exactly where on your system those files are stored.
So I can pick a specific folder or drive.
Yep. Or you can enter a path to backup data. This is good if you're migrating data from an existing information server installation or restoring a backup.
So if I'm upgrading from an older version, I'd use that backup data option.
Right, and make sure that backup data is from a trusted source. Don't want to introduce any security risks.
Safety first. Okay, so we've decided how to handle the database files. What's next?
It's simple. Just confirm your selection by clicking Install or Update. The information server takes care of the rest. Might take a few minutes, so be patient.
Patience is key when it comes to databases. So the installation's done. What happens then?
You'll see a Continue button. Click that, and then you'll be prompted to add a project to your information server environment. This is where you start connecting the server to your data sources, like a process historian or a WinCC system.
Adding projects, that sounds like a whole other adventure. But I think we've covered a lot for this session. Let's come back and tackle this next step in part 3 of our deep dive. Right, welcome back to our information server deep dive. We've tackled security, those system checks, the installation, configured the web server, even got our browsers ready. Now it's time to make this server actually work for us, connect it to our data.
That's right. We're moving on to the fun part, adding projects. This is where you tell the information server where to find all those data points from your industrial processes.
So if we're sticking with our training analogy, we've warmed up, we've stretched, now we're ready to lift some heavy data.
Exactly. Section 6.7 in the manual, that's our playbook for configuring a project. So let's get started.
All right, lead the way. What's our first move?
First, you'll head over to the administration area of the web application. It's under the administration tab, kind of like the control center for your whole information server environment.
Makes sense. Administration control, what do we do in this control center?
That's where you'll find the project configuration section. You can add and manage all the projects connected to your information server.
So each project represents a different data source, like one for a production line, one for energy consumption, and so on.
Exactly. Different workouts for different muscle groups, right?
Love the analogy. So how do we actually add these projects?
Super easy. Hit that Add Project button. It launches a wizard, walks you through the whole process. First, you pick the type of data source you want to connect to.
We've mentioned a few. Can you give me a quick recap of those options?
Sure. You can choose from Process Historian, PCS Neo, WinCC, or PCS 7. Just pick the one that matches your actual setup. No mix and match.
Right. Got to pick the right workout for the right muscles. What comes after we pick the data source type?
You'll need to give it the host name or IP address of that data source. That's how the information server finds it on the network, like giving someone directions to the gym, you know.
So if my process historian is running on a server called, say, PH Server 1, I'd enter that here.
Exactly. And if you're not sure about the host name or IP address, you can usually find it in the configuration settings of your data source.
Good tip. Okay, so we've selected the data source type, we've provided the address. What's next?
Now you pick the specific projects from that data source that you want to add to the information server, kind of like browsing the class schedule at the gym and picking the ones that fit your goals.
So if my process historian has multiple projects, say for different production lines, I can choose to add just the ones I need.
You got it. You're in control. And there's a little note here for PCS Neo users. When you're entering that host name for a PCS Neo project, you got to use the FQDN that matches the PCS Neo Engineering Station certificate.
You've mentioned FQDN a few times now. Can you remind me what that stands for again?
Sure. FQDN, that's fully qualified domain name. It's the complete official address of a server on a network, like using a full postal address instead of just saying the gym down the street.
Yeah.
Using the right FQDN, make sure that PCS Neo and the information server can talk to each other without any problems.
Got it. Precise directions are key. Okay, so we've picked our projects. What do we do next?
Just hit Add. The information server sets up the connection to those projects. Boom, you're officially plugged into your data.
Awesome. Anything else we need to know about configuring these projects?
One last thing. After you add a project, you can actually fine-tune its settings within the information server. Think of it like customizing your workout routine. You can adjust the intensity, duration, focus, depending on your goals.
So what kind of settings can we tweak for these projects?
You can set things like the data update intervals. That's how often the information server grabs new data from the source. You can configure security permissions, who has access to what data. And there are other project-specific settings you can tweak to really optimize performance, get things running just the way you want.
Okay, so it's not just plug and play. We can really customize how the information server interacts with our data.
Exactly. You've got a lot of flexibility to create the perfect data analysis setup for your needs.
All right, so we've covered adding projects, fine-tuning their settings. Anything else about this section before we move on?
Just one last reminder, security, security, security. Especially with sensitive industrial data, be sure to configure those user permissions for each project carefully. Only authorized people should have access.
Excellent point. Can't be too careful with security. Now, before we wrap up our information server deep dive, let's talk about one last piece. Information server ready, or IS ready.
IS ready. Think of it as the personal trainer for getting your data in shape. It lets the information server talk to different data sources like WinCC, PCS7, even the process historian. It's like a bridge between those systems.
So IS ready is like a translator, helping the information server understand all those different data languages.
Perfect analogy. It makes sure that data exchange goes smoothly. That's crucial for creating those comprehensive reports and analyses that span across different systems.
That's a great way to put it. But when do we actually need to install IS ready?
That's where it gets a little tricky. Section 6.8 of the manual, it dives into all the different installation scenarios. Really depends on your specific setup, how you're connecting the information server to your data sources.
Can you give me some examples to illustrate these different scenarios?
Sure. Let's say you've got a combined process historian and information server installation. In that case, you only need to install IS ready on the process historian server, not on the information server itself.
So in that case, IS ready is already built in, like a pre-installed language pack?
Exactly. But in other scenarios, you might need to install it separately. For example, if you're connecting WinCC directly to the information server, you got to install IS ready on every WinCC computer, especially in a redundant setup where you've got multiple WinCC servers.
Redundancy, like having a backup workout buddy just in case.
Precisely. All about ensuring that high availability, avoiding any disruptions to your data flow.
Okay, so different scenarios, different installation requirements for IS ready. Can you walk me through the actual installation process?
The installation itself is pretty straightforward. The manual outlines 2 ways to do it. You can install it during the initial setup of the information server, which is the recommend way, or you can install it manually later on.
So we could have checked a box during that setup wizard to include IS ready right from the start.
Yep. But if you missed it, no worries, you can always install it manually. The manual's got clear instructions for both methods.
Let's walk through that manual installation just in case anyone needs to go that route.
All right, for the manual installation, first, find those IS ready installation files. They're usually in a folder labeled IS ready on your installation media.
Okay, I'll keep an eye out for that.
Once you found it, just launch the start.exe file. That kicks off the IS ready setup wizard.
We're becoming pros at these setup wizards.
You got it. And the IS ready setup wizard is very user-friendly. You'll pick your language, read some instructions, accept the license agreement. Pretty much it.
Sounds easy enough. Anything else to remember about installing IS ready?
After the installation's done, just like with other software, you'll need to restart your system. And then there's one final but super important step. Configuring IS ready.
Configuration. Gotta love configuration. What do we need to configure for IS ready?
You got to specify the user credentials and security settings for the IS ready service. Think of it like setting the security code on your gym locker. Got to make sure only authorized users have access.
Makes sense. And where do we go to configure these settings?
You'll use the IS ready configuration tool. The manual walks you through it step by step. It's a quick and easy configuration once you know where to find the tool.
Great. So we've installed IS ready, configured it. Feels like we're nearing the finish line of our information server setup marathon.
We are. But before we celebrate, there's one last resource I want to point out. The frequently asked questions, or FAQs, section of the manual.
The FAQs, always a lifesaver. What are some key takeaways from those?
The FAQs cover a lot of ground, from troubleshooting common installation issues to addressing specific scenarios you might run into. For example, one FAQ highlights that it's super important to install the process historian before the information server if you're putting them both on the same computer.
So it's like building the foundation of the gym before you start adding the equipment.
Exactly. And the FAQs also give you some guidance on what to do if you need to clean up a corrupt information server installation. It's like having a plan in place if you accidentally drop a weight on your foot at the gym. You know what steps to take to recover.
Okay, the FAQs definitely sound like an essential part of our training toolkit. Any final words of wisdom before we wrap up our deep dive?
Absolutely. The information server, it's an incredibly powerful tool, and honestly, we've only scratched the surface of what it can do. Don't be afraid to explore, experiment with different configurations, see what kind of insights you can uncover from your industrial data. And if you ever hit a snag, remember the manual and the Siemens support team are there to help.
That's great advice. Listeners, we've covered a ton of ground in this deep dive, but hopefully you now feel equipped to tackle the SIMATIC information server with confidence. Remember, the power of data is at your fingertips. And with the right tools and knowledge, you can unlock some incredible insights, optimize those industrial processes.
Happy analyzing.
That's a wrap on our deep dive into the SIMATIC information server. Until next time, keep learning, keep exploring, and keep pushing the boundaries of what's possible with industrial data. Welcome to our deep dive, everybody. Today we're tackling Siemens SIMATIC PCS7 documentation.
Oh, yeah.
Which, let's face it, might not sound like the most exciting topic.
Right.
But trust me,
It's pretty important.
it's essential when you're dealing with a system as complex as PCS7.
Yeah, you really got to know your stuff.
We're going to unearth the most important nuggets of info for you to really master this system.
And make your lives easier.
Exactly, so you can focus on keeping those plants running.
Smoothly and safely. That's the goal.
Couldn't have said it better myself.
Well, where do we start?
Well, before we get lost in this mountain of manuals,
It is a lot, yeah.
I was thinking we could map out the territory a bit.
Oh, okay. Yeah, good idea.
What's the overall structure of the PCS7 documentation?
So it's actually pretty well organized.
Oh, okay.
It follows the life cycle of a plant.
Makes sense.
You start with the planning phase, obviously, then you move on to realization.
Realization.
Yeah, that's basically implementation, like actually building the system. Then you have commissioning, making sure everything works,
Right.
then operation, diagnostics, and finally servicing, keeping it running.
So it's a journey from, I have an idea, to this plant's been humming for years.
That's a great way to put it.
Awesome. Let's start with planning then.
Okay, sounds good.
What kind of documentation helps us through that initial phase?
All right, so when it comes to planning a PCS7 system,
Yeah.
you've got a couple of crucial documents.
Mm-hmm.
First up, you have the catalogs.
Catalogs, like product catalogs.
Yep, just like shopping lists for all your PCS7 components.
So if I need a specific controller or module or whatever.
It's all listed there, all the standard and technological components, add-ons, the whole shebang.
That's handy.
It can be overwhelming, though, because there are a lot of options.
I can imagine.
But it helps you figure out exactly what you need to buy for your specific plant.
Saves you from ordering the wrong thing, that's for sure.
Exactly. And then there's the configuration manual PCS7 engineering system.
Okay, that sounds a bit more technical.
It is, but it's all about setting up your engineering system correctly.
The foundation, basically.
Right, like capacity planning, making sure your system can handle the workload.
Right.
Then there's the network architecture, how all the components will talk to each other.
Important, yeah.
And PC specs, too, what kind of hardware you'll
And
need.
self-engineering and control,
Sure,
right?
exactly. You also got to think about AS and IO components.
AS and IO, those are.
Brains and nervous system of your plant, basically.
Makes sense.
It's a lot like building a house, you know?
Mhm.
You need a solid foundation, good wiring, all that good stuff before you start building walls.
Okay, so it's all about getting that infrastructure right from the get-go.
Yep, laying the groundwork is key.
Makes sense.
What else? Oh, you also have the manual PCS7 PC configuration.
Another one.
This one helps you pick the right PC configurations.
So like different setups for different tasks?
Yeah, for engineering, for operator control, for monitoring, all that.
Oh, I see, because the needs are different for each of those, right?
Yeah, exactly. Plus, this manual walks you through the network setup and how to make those PCs extra secure.
Because cybersecurity is crucial these days.
Oh, absolutely. Especially in industrial settings.
You don't want some hacker messing with your plant.
Nope, not at all.
Speaking of security, what about that white paper security concept, PCS7 and WinCC?
Yes. That one's a must-read for your network admins.
The folks in charge of the whole network infrastructure.
Exactly. It's a step-by-step guide to securing your PCS7 network.
So it covers things like
Planning security cells, setting up access points, managing who can do what.
user permissions and all that.
Yep, and implementing patch management to keep everything up to date.
Because outdated systems are vulnerable, right?
Big time.
Okay, so this white paper is all about building a secure fortress around your PCS7 system.
That's a great way to put it. And it's not just about the PCS7 system in isolation.
Right.
You got to integrate it with your overall Windows network security.
So a unified approach to security makes sense.
It's all connected these days.
So let me see if I've got this straight.
Shoot.
We've got our catalogs for picking the right components.
Yep.
Then the configuration manual for setting up our engineering system.
All right.
the PC configuration manual for choosing the right PC setups, and the security white paper for building a secure network.
You got it.
Sounds like a solid foundation for the planning phase, wouldn't you say?
Oh, absolutely. With those documents, you're well on your way to a robust and secure PCS7 system.
And a system that actually meets your specific needs, right?
Of course. That's the whole point.
Awesome. So we've covered planning, but now we got to actually build this thing right.
Right. That's where the realization phase comes in.
Realization, that's where the rubber meets the road.
Exactly.
So what kind of documentation helps us bring those plans to life?
Okay, so for the realization phase, you've got a whole bunch of documents that walk you through everything.
Right.
Installation, configuration, engineering, the whole 9 yards.
Okay, so where do we start?
Well, you got to get that software up and running, right?
Right. Okay.
So you'll need the installation section of the manual PCS7 PC configuration.
Wait, that one again?
Yep, same manual, different section.
Gotcha.
This part gives you step-by-step instructions for setting everything up.
Operating system, PCS7 software, all that?
All of it. Plus any special hardware or software you might have.
So this is like the ultimate guide for anyone actually building the system.
It really is, like having a PCS7 expert right there with you, holding your hand through the process.
I like the sound of that.
It's basically a checklist for building your PCS7 workstation from scratch.
Love a good checklist.
Me too.
So once we got the workstation set up,
Then the fun begins. You can start exploring the PCS7 world with the First Steps document.
first steps sounds gentle.
It is. It's a really nice introduction to the system using a simple project to show you the ropes.
Okay, it's like dipping your toes in before jumping into the deep end.
Exactly. You get comfortable with the system, understand the basics, and build a solid foundation.
All in, like an hour, right?
About that, yeah. Very efficient.
Perfect for busy folks.
Absolutely. But once you've got those basics down, you're going to want more, right?
Right. What's next?
That's where the 2 getting started documents come in. They take you deeper into the engineering side of things.
Building on what we learned in first steps.
Yep. Part 1 reinforces those basic functions, and Part 2 introduces you to more advanced stuff.
Okay, so it's like level 1 and level 2 of PCS7 engineering.
Exactly.
Now, remember we talked about the configuration manual PCS7 engineering system earlier for planning. Does this manual also come in handy during realization?
Oh, absolutely. During planning, it's like your blueprint, but in realization, it becomes your construction guide.
Okay, I see.
It helps you configure the core of the system, controllers, networks, process objects, the works.
So you're not just planning anymore, you're actually building.
Precisely. It's like going from architect to engineer.
Love that analogy.
Yeah.
But we can't forget about all the hardware, right?
Of course not.
We've got a whole pile of manuals for different components like I/O modules, CPs, FMs, ET200 components, all that. When do those come into play?
Those component-specific manuals are your go-to throughout the realization phase.
Especially for...
Installation, configuration, and troubleshooting.
It makes sense.
Each manual dives deep into a specific component.
So it's like having an expert for each piece of the puzzle.
Exactly. They tell you how each component works, how to connect it, how to fix it if it acts up.
So let's recap.
Okay.
We've got our PC configuration manual for the software side.
Yep.
The first steps and getting started docs for learning the ropes. The configuration manual for building the system itself. And then all those component-specific manuals for dealing with the hardware.
Right. Anything else? Oh, don't forget the engineering getting started PCS7 documents.
More getting started.
Well, these are different. They focus on the engineering tools in PCS7.
Okay, like what?
Like CFC, SFC, Step 7, SFC, visualization, PDM, WinCC, all the tools of the trade.
So they teach us how to use the PCS7 toolbox.
Exactly. Plus, they introduce this concept called efficient engineering.
Efficient engineering.
It's all about streamlining your work, making it faster and less prone to errors.
Sounds like a good thing.
It's a game changer, really.
Okay, I think we've got a pretty good handle on this realization phase now.
Yep. It's all about taking those plans and turning them into a working system.
We've laid the groundwork, built the system. Now we got to make sure it actually works.
Right. That's where commissioning comes in, the moment of truth.
And we'll dive into that in the next part of our deep dive.
Stay tuned. All right, so we've planned our PCS7 system. We've built it up now.
It's time to see if it actually works.
Exactly. It's commissioning time.
And a moment of truth.
You got it. So,
what kind of documentation helps us out here?
well, you'll find a bunch of manuals focusing on the operational side of things.
Makes sense.
One of the key ones is the manual PCS7 OS process control.
Okay, OS process control. That sounds important.
Oh, it is. This is like the operator's Bible, you know?
So if I'm the one sitting at the control panel, this is my go-to.
Absolutely. It explains how to interact with the whole system, how to monitor everything.
How to react when stuff happens.
Exactly. Everything from the operator's perspective.
Sounds pretty comprehensive.
It is. It covers the message system, the trend system, group displays.
How to manage the process control, all that.
Yep. It's like a training manual for anyone running the plant.
Especially for new operators, I bet.
Oh, yeah. It helps them get up to speed and understand how it all works.
Build their confidence, too.
Exactly. But what happens when things go wrong?
Uh-oh. That's when the panic sets in.
Well, hopefully not panic.
Right. There's a manual for that, right?
Of course, that's where the manual PCS7 maintenance station comes in.
Maintenance station. So this is for the troubleshooting crew.
Precisely. It's all about diagnostics, figuring out what's wrong and how to fix it.
So it covers all the different diagnostic tools in PCS7.
Yep. And it gives you step-by-step instructions on how to use them effectively.
Like a detective's handbook for your plant.
That's a great way to put it. But sometimes, even the best detectives need backup, right?
Zero.
For those really complex issues, you've got the manual PCS7 service support and diagnostics.
Okay, so that's for the real specialists.
Yep, the trained service personnel who come in when the regular maintenance team needs help.
The big guns.
Exactly. They're all about minimizing downtime and keeping the plant running.
Because downtime means lost production, right?
Yep, and that costs money.
So this manual helps those specialists get to the bottom of those critical issues.
Right, it's got all the in-depth info they need to resolve those tricky situations.
Okay, so we've got manuals for operating the plant, manuals for troubleshooting,
Yeah.
and a manual for those super complex issues.
Right.
But what about those everyday operational tasks and maintenance stuff?
Well, for that, you've got the operation and maintenance section of the PCS7 compendium.
Compendium, that sounds like a big one.
It is, but it's packed with practical information.
Like what?
Like routine maintenance procedures, best practices for operating the system.
Even guidance on expanding or upgrading the system?
Yep, it's all in there. It's like the owner's manual for your entire PCS7 plant.
So this section is about keeping the plant humming along smoothly.
Exactly, and preventing problems before they even happen.
Proactive, I like it.
It's full of wisdom from experienced PCS7 professionals, too.
Okay, so to recap, we've got the OS process control manual for the operators,
Right.
the maintenance station manual for the troubleshooters,
Yep.
the service support and diagnostics manual for the specialists, and the operation and maintenance section for keeping everything in tip-top shape.
You got it. And don't forget, all these manuals are constantly evolving.
Right. Siemens keeps updating PCS7, so the documentation has to keep up.
Exactly. It's important to stay up to date with the latest versions.
So you're not working with outdated information.
Precisely. And speaking of staying up to date, what about that PU manager we talked about earlier?
Oh, yeah, the PID manager. That was for managing all this documentation, right?
Exactly. It's a game changer for accessing all this info.
So it's not just a bunch of PDFs sitting on a server somewhere.
No, it's a dynamic platform that makes finding what you need super easy.
Okay, so what makes it so special?
Well, you can customize your documentation collection. You can use powerful search functions.
You can even create your own little library of manuals.
Yep, it's like having a personal librarian for all your PCS7 needs.
And it's accessible from anywhere, right?
Right, you can use it as a standalone application or access it through a web interface.
So no matter where you are, you've got the info you need.
Exactly, it's super convenient.
The PU manager sounds like a must-have for anyone working with PCS7.
I agree, it really simplifies the whole documentation process.
Okay, so we've covered a ton of ground in this deep dive.
We have.
You started with planning, went through realization, explored commissioning.
Even touched on the ongoing operations and maintenance.
It's been a journey. So what are some key takeaways for our listeners?
Well, I think the biggest one is that documentation isn't just a bunch of boring instructions.
Right. It's actually valuable. It can help you build a better system, operate it more effectively.
And maintain it more efficiently.
It's there to support you every step of the way.
Exactly. It's a knowledge base, a troubleshooting guide.
And ultimately, it can help you become a PCS7 expert yourself.
That's the goal. And remember, Siemens is always updating PCS7.
Right. So the documentation is constantly evolving too.
Make sure you're staying up to date with the latest releases.
And don't hesitate to reach out to Siemens support if you get stuck.
They've got a ton of resources to help you out.
So don't be afraid to ask for help. The more you learn about PCS7 and its documentation,
the better equipped you'll be to handle any challenge that comes your way.
Absolutely. And with a PU manager, you'll always have the information you need at your fingertips.
It's a real game changer.
All right, I think we've covered just about everything there is to know about PCS7 documentation.
Well, not everything, but we've definitely hit the highlights.
Right, and hopefully we've given our listeners a solid foundation.
A good understanding of how valuable this documentation can be.
And how to use it effectively.
Exactly. But before we wrap things up, I have a question for you and our listeners to ponder.
Okay, hit me with it.
In today's rapidly changing tech landscape, how do we ensure that the PCS7 documentation keeps pace?
Ooh, that's a good one.
How do we make sure it stays relevant and valuable for years to come?
That's something to think about.
It is, because PCS7 will continue to evolve and adapt.
And the documentation needs to keep up.
Exactly. So how do we do that? That's the question.
That is a good question to think about.
Yeah, it's something we'll have to keep in mind as PCS7 keeps evolving.
Absolutely. But, while we're talking about this mountain of documentation, I keep thinking about how it all comes together in the real world.
Right, like in actual scenarios.
Exactly. So can we maybe walk through a few examples
Sure, yeah, let's do that.
of when this documentation would be absolutely crucial?
Okay, good idea. So let's say you're commissioning a brand new PCS7 system, and you're setting up an I/O module, but it just won't cooperate.
Those are always fun.
You followed the installation steps, but it keeps throwing errors.
So what do you do? Where do you even start?
That's when those component-specific manuals we talked about really come in handy.
Oh, right. Those super detailed ones.
Exactly. Remember those stacks of manuals?
Your automation systems, I/O modules, CPs, FMs, ET200 components, all that.
Yep. All of them. Each one's like a deep dive into that specific piece of hardware.
So you're saying I should go grab the manual for that specific I/O module?
Exactly. It's like having a specialist right there with you, guiding you through the problem.
Okay, so those manuals will have wiring diagrams and stuff?
Oh, yeah. Plus explanations of all the configuration parameters, troubleshooting guides, the works.
So if I'm struggling with a specific piece of hardware?
That manual is your best friend.
Got it. That makes sense. But what about on the software side?
Okay, let's imagine you're an operator and suddenly you get hit with a ton of alarms all at once.
Not good.
Your heart rate's through the roof. You don't even know where to start.
It's overwhelming.
Right. That's when you turn to the manual PCS7 OS process control.
OS process control, our old friend.
Yep. That's your guide to understanding and responding to all those events.
So it helps me make sense of all those alarm codes.
Exactly. It helps you figure out what's actually going on so you can prioritize and take action.
Okay, so it's like a cheat sheet for those stressful moments.
That's a good way to put it. And if you run into more complex issues,
Daddy, some serious investigation.
then you call in the maintenance crew.
Armed with their manual PCS7 maintenance station?
Exactly. That's their guide to diagnosing and troubleshooting those more difficult problems.
So they can find the root cause and figure out how to fix it.
Right. It's their playbook for those situations.
But what if even they can't figure it out?
Well, for those really rare cases, you've got the PCS7 Service Support and Diagnostics Manual.
The one for the specialists.
Exactly. Those highly trained folks who can tackle the toughest challenges.
The PCS7 Special Forces, we were calling them.
That's right. They're there to make sure your plant keeps running no matter what.
So basically, no matter what kind of issue you run into.
There's a manual out there to guide you through it.
Which is a comforting thought, I gotta say.
It is. Good documentation gives you that confidence.
To face whatever comes your way.
Exactly. It empowers you to solve problems and become a PCS7 expert yourself.
Well said. Well, I think that about wraps up our deep dive.
It does.
Into the world of PCS7 documentation.
We've covered a lot.
From planning to building.
To commissioning, operating, and maintaining.
The whole life cycle. And hopefully we've demystified this whole documentation thing a bit.
Shown how valuable it can be.
For anyone working with PCS7.
Absolutely. So, to our listeners out there,
embrace the documentation, explore it.
Don't be afraid to get your hands dirty.
And never underestimate its power.
It can really guide you on your PCS7 journey.
Until next time, happy automating.